container?
If you
Is the
Prime side
atmosphere
I know
Okay,
every same way.
17 trillion other things we can disagree on if we want. Yes, replay, go for it. Let's hear your question.
Okay, so I've got a buddy who he's been a big flat earther for probably the past 6 years, and he believes in something called the firmament. I'm not sure if you guys know what the firmament is, but I just want to know what your guys' opinion on that concept is. If you're not familiar, I can explain it.
biblical cosmology is what it is.
What are your guys' take? My buddy, he's hardcore debates with me on the flat earth all the time. He's big on the firmament. I think the firmament is quite a reach to try to justify, but to him, that's fact. So I'm just curious what you guys think about the idea of the firmament.
Tell you what, why don't you tell me if it's possible to have gas pressure without a container? How about we start there? That'll be fun.
What was that?
How about we start with, how can you have gas pressure without a container? Can you give me some gas pressure? I want enough to put in one of my tires for my truck, but I don't have anything to put it in. I'll just hand it to me and I'll take the gas pressure. Can you give it to me? Yeah, here's your space time, sir.
Yeah, dude, I'm not a scientist or anything. I assume the atmosphere would have something to do with that, if that's what you're saying. But if you do believe in the firmament, just give me a...
No, I specifically asked you if you can have gas pressure without a container. That's what I specifically asked you.
No, generally no.
Okay, thank you. Welcome to the firmament then.
Therefore, the earth is flat.
Okay.
That's what he's trying to say. Therefore, the earth is flat.
That's no
You can't
flat
have
earth.
gas in a container.
No, that's not what he said. Don't be a dumbass.
I think a lot of that would have to do with the weight of different gases, the atmosphere. Like, for example, if you have like a geyser or something like that, you still have gas pressure underground, even though it's being released. It's not necessarily like a complete container, but you still have a degree of pressure. So
Is a geyser liquid or
I guess
gas?
it depends.
Is a geyser liquid or gas?
Dude, again, I'm not a scientist. Probably liquid underground gas as it heats up and goes up. I'm just asking your guys' opinions on it, and like a straightforward answer on like what you think.
So what he was saying, is a firmament is an example of a container, right?
Okay.
Right, because it's supposed to be a physical barrier based off of what the Bible describes it as.
Right. Okay.
It separates the waters from above from the waters below.
Yeah. Okay, so you're disagreeing with the firmament then. My bad, dude. I don't...
We're not agreeing or disagreeing with the firmament. A firmament is an example of containment, of some form of containment, right? That would put you inside of a box or whatever's going on up there. There's some kind of physical barrier that holds shit between us and whatever's above the firmament, right?
Right.
There's a barrier there.
Yep.
Yeah. We also have the problem on the other side. There's also the problem on the other side. We have gas pressure on Earth, and we're told that there's a vacuum of space. Try and create a vacuum without a container. You need a container for air pressure, and you need a container for a vacuum. You got a problem on either side. Try and figure that one out.
Yeah, like if I had a box, right, and it sucked all the air out of the box.
Yeah.
Replay?
Yeah,
I'm
listening.
If I have a box and I suck all the air out of the box, right?
Yep.
Is the box a container?
If you sucked all the air out of the box, I mean, depending on how you define a container, I guess. I mean, I would still call the box a container. I guess if you pull all the air out, it just compresses into itself. So then I guess it's not containing anything. Still.
What if it doesn't compress into itself?
Container or not, it doesn't mean the earth is flat. Container or not.
Israel, you're about to go on mute, bro, if you're just going to sit there and turn this into the Israel show.
But I was just asking, man. I've never been in this Discord before, and I've got a buddy who talks about a lot of this sort of stuff, and I just wanted to see what you guys thought about it.
So you can't have a vacuum without a container, and you can't have gas pressure without a container. And if you put a vacuum next to gas pressure, the gases are, and there's no barrier in between the vacuum and the gas pressure, the gases are going to immediately fill the void in the vacuum. You understand that?
Yeah, yep. That makes sense.
Right. So how do you have gas pressure on Earth at sea level, 14.7 psi, next to the infinite expanse of space that is a near perfect vacuum for God knows how long?
Yeah, I guess I couldn't tell you that. I don't really research or follow this all that often. I joined in because I got a buddy who's into this stuff, and I just was curious to ask a few things, but I don't know the sides of any of this shit, so I was just getting your guys' opinion. I can't really debate based off of
so if you go by if you go by biblical cosmology and you look up what the firmament is, it's a barrier that separates the waters from above from the waters below.
Okay, so I got one more question, also relates to my buddy's beliefs. So this one kind of confuses me. He believes in the flat earth, he believes in the firmament, but he also believes that the earth is hollow and has some sort of interior that's hollowed out and that stuff could be living in. He kind of takes it to a biblical level where he thinks there's angels.
Wow, you have you have a wide variety of friends, don't you? Yeah.
No, this is one guy. This is one guy.
Yeah. Okay. So so the same dude.
Hey, I'm gonna hop in here real quick. I was just wondering, where do you guys lie on space?
Yeah. Well, we were just talking about that, weren't we? Were you here for the gas pressure without a container thing?
I muted him, Dandelion. We'll finish with replay. We'll finish with replay, and then when replay is done with his questions, we'll come to you, Snowcat. Okay?
Yeah. So replay. Yeah. These
the hollow
people.
Earth, yeah.
Okay, so all I was going to say is the thing of it is here at the 24/7 Discord channels, here in our outposts, like the one in politics and in our home server, we try to focus on falsifying and destroying the fantasy globe model and demonstrating how there's no curvature, no rotation, no forward motion of the Earth, because it pretty much is a 24/7 job just doing that, because the delusion, the indoctrination, and the science fiction program that's taken over people's minds is very hard to get rid of. So if you start introducing other unverifiable factors, like the ones you're talking about, the hollow earth, whatever, that's cute and everything. People can imagine about that if they want. You know what I mean? They can write little stories about it if they want, and so on and so forth. But it's not really useful to what we're doing here, because what we're trying to do is to get people to understand you need to abandon this idea that there's some kind of magical model and story that's going to explain every single thing on Earth, and that there's some great expert, out there who knows everything, who can explain everything. That's what the globe claims to have, even though they don't, because their stories don't hold water. They aren't verifiable, testable, repeatable, or scientific. So, I don't care about your hollow earth friend. He can do what he wants. But we're not here to give people a new, unverifiable fairy tale for them to join in on. Because part of the thing is to break the addiction to the external locus of control. Because the external locus of control is shown by many studies to be a way to lead to a less successful and less happy life. An internal locus of control where you are self-motivated, where you trust your own lived experience, is a much happier and healthier way to live. But to just go from one wild model to another one is not healthy for anyone, because then you're still just living in a childlike delusional fantasy state and not dealing with the world at the really is level.
I ask one more question directly related to the flat earth, not related to anything else with my buddy. So my question is, again, I've flown, I live in the United States. I've flown to Japan from the United States, and I've also flown to Europe from the United States. This to me is like the simplest reason why the globe would make sense. Obviously, there's a ton of other stuff you can debate. How can you fly from the United States to somewhere that would go over the ice barrier to Asia and also be able to fly to Europe if there
are you using the Mercator? Are you using the Mercator map?
They
Yes.
have their own maps.
Gosh.
They have their own maps. It's bad.
Again, I'm not sure all the scientific. I just want simply like an explanation.
Are you asking the question if the Earth is
how can I fly from here to there, but also here to there?
Are you asking the question?
We do not live on a map. Maps are not what we live on. If you have a problem with the map, you have a problem with a map. Maps are a projection. These maps come from projections of the globe, okay? The globe that you think that you live on. These different maps come from that projection. Now, none of that is real. I can tell you where the globe comes from. The globe comes from measuring angles to celestial bodies in the sky, in the celestial sphere. Okay, not an actual sphere, but an arc in the sky. And we measure elevation angles to celestial bodies, the sun, the moon, Polaris, other stars. There's 58 different stars that are used for navigating the Earth. And all of the known land and waterways we have mapped into the stars above our head. That's where our globe exists. We don't live on a globe. We live in the globe. And the map is in the sky, and it's based on time and elevation angles. Time is very important because stars move. So to have a ground position underneath the star at a particular point in time, you need to have a specific time that you're going to do it at. You need your elevation angle, and then you'll have a ground position of a star. Okay, so the whole globe Earth is mapped in the sky above your head. It's not a real thing. So when you say that there's an ice wall and they're going this way and going that way, I don't think you know where they're actually going, because you're looking at a map that is just a projection of the globe. So what it sounds like to me is that you have a problem with the globe.
Can I refine my question a little bit then? Do you guys believe,
Sure.
Again, I'm not an expert, I'm not sure exactly how you guys see this. Can you fly from, let's say, the United States directly to Asia or directly to Europe? Or do
I'll tell you what.
Okay, explain that.
I live in northern British Columbia, okay?
Yep.
And I am on a flight path from the U.S. to points in Asia. I have planes that fly over my head that are going to Japan, they go to Beijing, they go to Russia, and they all fly over my head. And that's because you're looking at the wrong map. You're not looking at how the continents are actually laid out. You're looking at a map, which is a globe projection. You're looking at a map where east and west is a straight line. East and west are not straight lines. They're circles around the North Pole. So I can tell you right now, you're looking at the wrong map. And that's your problem. And you've got a problem with the globe projection map that doesn't deal with your reality.
So essentially, you can fly from anywhere in any direction to different locations, is what you're saying. You don't have to fly in one direction to get from the United States to Russia.
B, you don't think that you could go from point A to point B? Yeah, you just fly. All these flights, they fly waypoints. They don't fly in circles. They don't fly in arcs.
Nobody here is a
They
pilot, by the
fly
way.
from a point A to a point B. They'll make a turn. They'll take another vector, and that's how they fly. So I don't know. This
So
has
I'm
nothing
just saying,
to do
if
with
the Earth
fact
was
that
flat,
Earth
wouldn't there be a
measured flat,
theoretical
navigated
edge
flat,
that you
aviated
couldn't
flat.
that you theoretically couldn't fly over, and you'd have to go in a different direction to get from one location to the other because you had reached the edge rather than being able to
Who's
fly?
going to the edge? We have the known mapped land. I already told you about that. We have the known land and it's mapped, and we map it according to the stars in the sky. So nobody's going to fly somewhere where it hasn't been mapped yet because they won't know how to get there. So planes are only going to fly from destination A to destination B. That's what they do, and they will always do that. Nothing's going to change that.
Does somebody have a map of what you see as the Earth that you could post in voice chat so I could reference it and see exactly what we're looking at?
Well, all maps are flat. I can tell you that because they're all based on longitude and latitude lines. That all comes from elevation angles to the stars. So all the maps are flat. So the thing is that you're just not sure in how you're interpreting them. You're interpreting them in a way that you think, but that's not what's actually happening. And again, I live in northern British Columbia. I have planes that fly over my head from all points in the U.S., from LA to New York. They fly over my destination, and they head off into points in Asia, Japan, China, Thailand. I get
That
all
sounds
these
like
flights
Jordan
over my head.
Peterson. Are you Jordan Peterson?
Yeah. So what I'm saying, though, is if there were to be an edge to the Earth, wouldn't
Nobody's
there be
found
a
the
point?
edge. There's no edge. We just know the known land. Nobody's talking about an edge.
How is
you
the
want
Earth
an
flat
edge.
without an edge, without an end?
Because nobody's been to the edge. Okay, we got an ocean, and there's a shoreline for the ocean. That's the known land. We all live on the known land, and we have an ocean around us. Nobody's been to an edge. If there is an edge, it has never been discovered. Okay, it's just like in the heliocentric model, the universe apparently is expanding all the time, expanding into nothing. How does something expand into nothing? Like, do you want me to go on about you and the edge of your universe? Just because we don't know where the edge of the earth is, we can't get there.
No, the one part I just don't understand is if the Earth were to be flat, how would you be able to fly in any direction and cross over and reach the same locations? Wouldn't there be some sort of point where you go?
What are you talking about? Having to cross over something? What are we crossing over? You're going to go from point A to point B.
You're not understanding what I'm saying with that? The way I've always seen. Okay, so the way I've always seen flat Earth models laid out is there's always been an edge, and if there were
listen, buddy, you're asking for a projection from an outside perspective of reality. No man has ever been out there to tell you this is how the whole of the existence works and looks like.
No, I'm just saying, if it were to be flat, wouldn't you reach a certain point? Yes.
Replay.
Yeah.
Replay, listen to me. When you're thinking of a map, you're thinking of where Europe is in the middle, the United States is on the left, Asia is on the right. How the fuck do we get to Japan from California, right?
Right. Yep. Exactly.
That's fucking retarded, bro.
I can tell you that Asia is a straight line.
What I'm saying is, if it's China, how does it all connect? That's all I'm asking is, how does the Earth all connect to one another?
I'm trying to help you out here.
No, I'm trying to understand.
In northern British Columbia, it is a straight line from my destination to Alaska, to Russia, to Japan, to China, to Thailand. to Indonesia. It's a straight line from my house. All those places are on a straight line. So if a plane flies over my head on that vector, they could go to any of those places by following the straight line above my head.
I'm gonna give somebody else a chance to talk. I've been hogging the mic for a minute. I'm gonna mute myself and give somebody else a chance to talk.
Could I ask a question?
Snowcat had his question about space. Is that Snowcat? Yeah, go for it.
Yeah. Sorry, I was just a little confused about the vacuum and how that works. Like, I guess, how does that work? How does it keep the gas in?
So vacuums don't keep gas in, dude. That's the whole problem.
Yeah. Well, that's kind of the thing, because when you can take like a tub and push it underwater, and it creates that pocket. I mean, is that not a vacuum? And how does that work?
A pocket, an area devoid of matter.
Yeah, it's devoid of matter.
Hey, Jamesy, you're hot.
Air? There's no air.
I don't think so. No, because
you're kidding.
Because you're pushing it underwater.
But it's not a vacuum if you're pushing it underwater. It would actually be air pressure, right?
Yeah. Well, it's just going to be a space devoid of matter, separating the thing that you're pushing under the water and the water for what? What reason?
Well, no, because I think you hear me out. I don't think you get the question. You have to, when you push it down, I mean, there's nothing in there. So how does the space keep? No,
air's in there. Got air in there.
That's what bubbles are, dude.
What is air?
I'm not sure. Well, bubbles are. Well, yeah, bubbles are air. But I'm talking about when you push a tub underwater,
Why don't you go do this in your bathtub, dude? Go get yourself a bowl, flip it upside down, and then push down in the fucking bathtub. There's air in your fucking bowl, dude.
Separating the bowl and the water, there'll be a vacuum between them.
That's my thing. Because that's what I've tried that, and that's what I was going to ask about. Because I've tried.
You have a vacuum.
Pushing
Is it a perfect vacuum? What Tor was the vacuum?
Yes, and then so I have a perfect vacuum here, and then how does that? Yeah. Because so I have a bowl right at the bottom of the tub, and I put red food coloring in there so I could see the water, and then so I have that at the bottom of the tub. How does
Okay, if you've got a vacuum in the bottom of your tub, what's going to happen is matter is going to rush in and fill it instantaneously, which is what we're saying would happen with the gas to the outer space vacuum.
Wait, how do you know that?
Because that's what happens with a space devoid of matter. Matter will rush in and fill it. You got water does this, gas does this.
How do you know that?
Second law thermodynamics.
Entropy. Yeah.
So you accept. Wait, hold on. So you accept science whenever you want it to work for you, but you don't accept science whenever it says the Earth.
No, we accept science. So that would be the scientific method. There's nothing that goes through the scientific method that has been validated that we just reject. So no, you're totally incorrect.
Can I finish my point?
But this isn't something that's even subject to the scientific method. It's just a natural law. It's just something that happens again and again and again. We don't need to determine a cause for it, which is what the scientific method is for. You just observe it happening over and over again. So, I mean, the scientific illiterates trying to get us on a gotcha with science is not going to work.
So you've observed
you're conflating pseudoscience with science.
Yeah.
So we accept.
Theoretical astronomy and shit. Yeah, which is pseudoscience. Yeah.
Yeah, we accept demonstrable. We accept that which is demonstrable. So if you can demonstrate what you're talking about and prove it, right? Yeah.
So can you demonstrate a vacuum?
Yeah, I actually did. I did the experiment myself.
I'm going to just take Neuralist out of the conversation because I've talked to him before in PNR. He's a complete sea lining waste of time troll. So Snowcat, if you want to demonstrate your vacuum in your bathtub for us, that's cool. Go ahead.
Yeah. Okay. Thank you. So basically, bring us back to the bowl analogy, which. The bowl kind of is basically a little mini atmosphere down there, except devoid of any anything because it's
it's an atmosphere which is full of air and particulate and water and other matter.
This one,
but other than that, it's devoid of matter, is what you just said.
Yeah, and then I had the red food coloring represent space around it, and that seems to work. So I was down there. I could keep that down there. I just kind of held it down. And that seemed to work for like hours too. I could kind of hold it down there. How is that not like the Earth?
Does anybody know what the hell this guy is talking about?
No, I got no.
Do you guys have a diagram I could use? Like, do you have a drawing app I could use?
Snowcat, can I talk to you so that we can figure this out? Because everybody's really confused. You have taken.
I know what he's saying, but he's not. He doesn't understand what a vacuum is.
Just hang on. You've taken a bowl, you've turned it upside down, you've put it on top of the water with air in it, and then you pushed it under the water. Is that what you did?
That is what I did. Yes.
Okay. So not a vacuum. Thank you.
Well,
yeah.
No, but
it's not a space devoid of matter. You got food coloring, you got air, you got water, you got all sorts of materials in there, and you already said this. And then I said, other than all that matter, you got no matter, and you went, yeah, this is just stupid, dude.
I mean, I think if you guys were there, you would understand.
I think we'd understand that you were actually really silly. This is not a vacuum. All you've done is you've taken air and pushed air underneath the water. If anything, you've created a pressure zone because the air will be pushed up because of the weight of the water around it and beneath it, pushing up on it, that you'll create a higher pressure inside there. Not a vacuum, not even close to a vacuum, even further away from a vacuum.
But it's also in a container, right? The bowl's a container.
Yeah. What? Sorry, it's hard to hear. What did you say?
The opposite. Is the bowl a container?
Well, no, because the bottom's open, so it's not a complete container. I say bottom. I mean upside down. So
it's an open.
So you could eliminate the bowl and demonstrate this without the bowl.
No, because the bowl is the vacuum, and that's kind of what makes the whole thing work.
It's not a vacuum. Right? You're wrong, Snowcat. It's not a vacuum. It has air in it, and you've pressurized it. It's not a vacuum. Stop calling it a vacuum. You're just wrong.
I haven't pressurized it though, because the top is still technically open.
You turned a bowl upside down with air in it, and you pushed it into the water. You pressurized it. You did not create a vacuum. Stop with your nonsense.
You're just demonstrating density and buoyancy, right? So you have buoyancy differential, and you're using containment. So what is your point?
I think it could have had to do with the food coloring. I think that might have been messed up with the dependent variable, but
doesn't matter how much food coloring you get, you're not going to create a vacuum by doing that.
No, I don't think it was how much. I think it was the color, because they put red 40 in there.
Okay, so it's the wrong color. If you used the right color, it would have been a vacuum. Is that what you're saying? This is absolute nonsense. Why are you here wasting our time? Absolutely, this is just nonsense, dude.
Yeah, he can't be serious. He can't be serious.
I mean, you guys are free to talk. I can listen.
Yeah, I think you drank too much of the red 40, and your autism is not allowing you to understand the reality of the world we live in.
I'm okay, guys. I'm okay.
Sunsets prove the Earth isn't flat.
I'd say you're far from okay.
You have this proof, non-theist? Is that what you're claiming?
Well, sunsets prove that the Earth isn't flat.
Oh, that's your statement.
It's proof. Okay, put it in a syllogism.
I don't need to put it into a syllogism for you to observe.
Is the sunset when the sun is at 0 degree elevation? Is that the sunset that you're referring to?
No, the sunset is when the sun disappears below the horizon line.
Oh, you've seen the sun go below the Earth. Okay, interesting.
I've seen it disappear behind the horizon.
Behind the horizon. The horizon's a physical plane?
And then when I went up on top of the county building in my area, I could watch the sunset again because I elevated
we agree with you. We agree with you because you've increased your angle to the sun. Therefore, you can see further. Eventually, it'll disappear from your view, though, again for a second time. And if you can't go higher, you won't be able to see it for a third time. But yeah, you can see it 2 times, but it's not going below no Earth. You haven't seen it go below no Earth. That's never happened in your life. You only think that. You just have a belief.
Okay, are you done?
So you notice how he said that he had a proof. He had a proof claim. He couldn't put it in a syllogism, and then he just had a bare assertion after he gave up on the proof and said, "I don't need proof." Essentially, so you don't have any proof. So what are we even talking about at this point? Yeah.
Are you done? Are you done?
Yeah, you forfeited your proof. You don't have that.
Are you done? Are you done? Calm down.
Well, I mean, it sounds like you're done because you said you had proof, and then that went out the window. Anyway, go ahead, Napalm.
Calm down.
Yeah, I have a quick question. Is the horizon a physical or an apparent location?
So it matters on your elevation on the globe of the Earth. Your horizon level might be lower than your eye level if you're up higher. As you increase.
I didn't ask you where it was located in your field of view.
No,
I asked you if
you're not listening to what I said. I said in the beginning. Excuse me.
Chill.
Excuse me.
Chill.
Excuse me. You're not listening. You're not listening. Excuse me. Be quiet for a second. Be quiet for a second, and you might learn something. Hello? Somebody mute this guy. Somebody mute this guy.
We're going to mute you. Actually, you're going to have to listen to his question and answer it fairly, dude, or else you're the one getting muted.
Yeah, I didn't ask you where it's located in your field of view. I asked you if it's in apparent location or a physical location.
He ran as soon as he couldn't just talk through you. He's gone.
All right. Sorry.
No, it's okay. He was the one filibustering and stuff, and he didn't want to actually deal with any questions.
Because that's the thing, they just want to assert that it's a physical location, but don't want to actually understand whether or not it's physical or apparent, right? It's weird.
Yeah, they don't want to deal with that. They're just going to run away from that question, even though they have their claim already in what they're saying. They're saying it's a physical obstruction. You try to nail them to that, and they suddenly get all squirrely. It's weird.
Yeah, and then they make up all the other nonsense about the geometric horizon and the apparent horizon and all sorts of the refracted horizon. There's all kinds of them. There's so many different horizons. They don't even know how many horizons they got anymore. But when you slice it out, the horizon is where the sky appears to meet the land or the water.
That's it. Yeah, that's all it is. That's all we have. Yeah.
It's an apparent location. It ain't a real place. It's just,
decent.
Just a place kind of thing. Sort of.
Oh, yeah. They're both good, man. Very good.
Exactly. So if it appears to me somewhere, then it's just apparent, right? It's not physical. Why don't they get that?
Hey, can I hop back in for a second, or somebody talking?
Yeah, go for it.
Go ahead. What do you got?
Okay, so I pulled back up. I was thinking of what you were saying with the Newfoundland to Japan and all that. And it's the same sort of idea, but I took a look at Flat Earth maps so I could refine my idea here. So let me change the locations for a second. We're going to talk about flying from, let's say, Buenos Aires, Argentina, to,
you're going to have to share the
let's
map.
say, Sydney.
You're going to have to share the map with us so we know what you're referring to. So post the map into the side chat, and then we'll see what you're looking at.
Well, dude, I mean, all of them are flat Earth maps. So
it's
you'll just be going, this flat Earth map versus this flat Earth map.
I mean, I know. I got to make sure. It's not letting me post images into voice chat. Here, let me see if I can post a link. Yeah, okay. I posted the link in the voice chat.
I hope it's a globe projection, because if it doesn't work on a globe projection, does that mean that the globe is not real?
We do not live on a flying disc in outer space. You need to stop right there. You're gaslighting us. That's not us. Nobody here claims that. Nobody here believes that.
Do you have a map you could post for me so I can take a look at it?
Okay, all maps are flat. That's what I can tell you. It's the interpretation of the map that's important for when you're going to use a map as to how it's going to help you out. But all maps that have longitude and latitude lines are all flat maps, every one of them, because they were all built the same way with elevation angles to celestial bodies using a flat, horizontal, topographical plane that we live on.
Okay, so
why isn't the globe just used? Just use the globe. Don't need maps, just use the globe, right? Globe's correct. The globe's correct, right? Nobody ever should ever fucking need a map ever. You've got a globe. Use the globe. Globe's right?
So anyway,
take a globe with you. Put a globe on your dashboard. You'll never get lost.
The point that I'm trying to make is that, let's say, just theoretically, you fly from Argentina to Australia. That should only be a couple hours in the globe, because you fly over, on the globe idea, you fly over Antarctica, right? Versus if you had to fly
Australia
directly.
should only be a couple hours, dude.
Over Antarctica.
I don't know the exact.
Nobody flies over Antarctica. Nobody flies over Antarctica. Ever.
My point is just that if the Earth is a globe, some flights cross south below the globe, some would go over, whereas flights from other locations.
Do they show that?
I mean, yeah, you go from the quickest location. I can pull up some flight maps.
This guy is completely lost in what he's saying. He just said Argentina to Australia. That should only be a couple hours, right? On a globe.
I don't know the exact.
Okay, dude, it takes way longer than that. So you've already debunked your globe with the metrics you've given us. Thanks.
No, you get what I'm trying to argue, though, right?
No, you don't even have the numbers. How can you? There's no substance to what you're saying. You don't actually even have any of the information to carry the conclusion that you're trying to, dude. That's already been made obvious.
I mean, I don't need a
This isn't a real concern that you have. You don't
why
even.
I'm wrong. If you can acknowledge
basically, in your head, it's like whatever numbers they are for this flight time, that equals globe. No matter what they are. That's pretty much
the simple point I'm trying to make is if there's a globe.
Confirmation bias for you.
No. Listen to me, man. All I'm saying is that if there were a globe, you could fly from Argentina to Australia either over the top of the world or under the bottom of the world. Whereas if there's a globe, a flat Earth, you could only fly in one direction. Correct or incorrect?
Incorrect.
Okay, explain it.
I don't have to take just one direction to the grocery store. I can go the long way.
No, but if the Earth is flat, you can only fly either north or south to get there. If it's a globe, you can fly under the world or over the world to get to the same.
All right, who does that?
Right?
Those are the same thing.
That?
It's just for
who does that?
It's just for conversation, man.
Who does what you're talking about?
But it's for conversation.
Then it's fucking pointless talking about it, bro.
No, it's not. The point is that if you can fly to the same location,
the point is that you're talking about hypotheticals. Well, if it was a globe, you could do this, and who'd do that? Oh, who did it? I don't know. Nobody. Nobody does it. I'm not saying anybody does it.
Well, obviously, commercial flights aren't doing this because you're going to take the quickest path to get to the destination.
No shit.
But
so you're just saying so you're just saying they on the globe they do what you would do on a flat Earth. Oh, okay, cool. Thanks for that.
I'm saying you can fly in either direction to get to the same location. That's what I'm saying.
Data. Hey, replay. We got black box data from the NTSB, and we know what planes do when they fly. And you know what they don't do? They don't fly over a globe. They fly over a flat horizontal plane. That's what they do. So you got that to deal with. There's no globe to fly over. Never happened. No planes do it.
All right, give me a little bit. I'm going to mute myself again, and I'm going to come up with actual flight data, and then we'll bring this back.
We already have flight data. I'll post it into the side chat.
No, I know. Just so I can explain what I'm trying to debate better, so you guys can understand what I'm trying to say.
There's nothing about black box. There's nothing about black box flight data that indicates anything about needing to fly over a curve or account for rotation of the Earth or anything like that.
No, the whole point I'm trying to make is simply that you can fly north or south and get to the same location. East or west, get to the same location.
Can you?
Yeah. I mean, you can. Yeah, you can fly from
Well, I asked
the
you
US.
who did, and you said no, but I'm not saying anybody did it.
So, new example. Let's say you fly from the US, you fly to Saudi Arabia, and then you fly back to the US. You've flown over the whole length of the Earth, but you're going east the entire time, or you're going west the entire time. At no point do you fly back in the direction you came from. You continue flying in the same direction, and you travel the length of the continents on Earth.
Airplanes don't work on a globe.
So
that's true.
So if you fly from the US, you fly to Japan, you fly to Saudi Arabia, you fly to the UK, and then you fly back to the US. How do you take the traveling of the whole Earth going east?
Why can't you do that on a flat Earth? Why can't you do that on a flat Earth?
Because you hit an endpoint. Because at some point you hit the edge of the Earth.
He doesn't know.
If you continue going east in the same direction and the Earth is flat, you're going to hit the edge of the Earth.
Put something coherent together. You don't know what we're saying. You don't know what you're trying to say. Earlier, you said Argentina and Australia was a couple hours. That's not true at all, ever, for anybody in any paradigm. Like, you don't have any of this information. You're spitballing stuff out of your imagination is what you're doing. It's not helping anybody.
Does he think he lives on a Mercator map? I mean, how are you going to get to all those countries without changing direction, bro?
Because if you fly from the US to Japan, you're flying west, then you fly to Saudi Arabia, you're still flying west, and then you fly to Africa or Europe, whichever, you're flying west.
Is that a straight line, is it?
No, it's not a straight line, but
so you've gone in a circle then?
West.
So you can't go in circles on a flat Earth?
You're not going east at any point. My whole point is you're generally going west.
So you can't go in circles on a flat Earth then?
I mean, I suppose if you flew in the center latitude,
you know that east and west are relative to north, right?
Right, yep.
Right, so yeah, you hold on to a pole that's the North Pole, and you walk around it in an east or west fashion, and maintain east or west, you're going to go around in a circle, right?
Yep.
Yeah, so you can't do that on a flat Earth?
Well, can you guys provide me a map? I just want to know what you guys. No, I'm not trying to be insulting or anything. I just genuinely want to see what you guys see as a map, so I can give a better argument to this. Because I just sent you guys the map that I thought you guys believed, and you guys said no. So I just want to know what you see as a map. I just want to be able to reference this so that I can formulate a better argument.
I posted about 200 of them for you. Just take your pick.
Where? Oh, in voice chat or where?
Yeah.
Voice chat? Okay, give me 1 sec. The Fizz World one? Who said that? Sorry. Who posted it?
Sheepdog.
Okay, 1 sec. All right, I gotta scroll up for a minute. I'm not finding it.
Well, no, don't do that. We tagged you. Just click on the response or whatever.
Oh, see attachment. Okay.
Yeah, exactly that. Yeah.
Okay, I see it. Oh shit, that's really small. Let me see if I can zoom in on it.
Yeah, those are all the maps. So.
All right, I'm downloading it. I'm downloading it. Give me 1 sec. Maps of the world. Opening it. So there's a lot of different maps. Are these all? Can you explain why there's so many?
Different purposes for different projections.
Okay.
Some are for navigation. Some are for time zones.
Okay.
And yet none of them are what we live on. We don't live on any of them.
In the first Mercator map, I think he put 4 islands at the North Pole. I mean, information changes, like they like to say about science, etc.
So I'm still at my first question. Explain this to me like I'm a fucking 5-year-old. If the Earth was flat, how can you fly in a complete line west or east and just endlessly keep going without hitting an edge?
If that's the curved line, it's a circle, then you can do that. But Plum Bob is going to say something else, so go ahead, Plum.
Yep.
Sorry, I didn't mean to jump on you there. You can't fly in a straight line, east or west. East and west are circles because it's always in reference to the North Pole. So you got your compass in your hand, and you're going to take a few steps, and every once in a while, you're going to have to alter your course so that you keep the peg on the North Pole. Otherwise, you're going to get lost. You don't want to get lost. So you want to make sure that the peg of your compass, the needle, stays on the North Pole. And you're going to make a circle, either going west or you can go east. And if you continue to go east or west, you'll end up making a circle around the North Pole and you'll end up right back where you started. And I hope that's not too difficult to handle for you.
No, I get that. So I guess my next question is the edge something you can run into? Why have we not
been to the edge?
Why
Nobody's
not?
been to the edge. Because nobody's been there. We only know the known land and the known waterways. It's maybe the edge is still left to be explored. Maybe it hasn't been found yet. Just like the edge of the universe hasn't been found, and yet we're expanding into it every second. We're expanding into nothingness. Doesn't that sound stupid?
So what about satellites? What's your thoughts on satellites?
Oh my God, we're doing just a bunch of bopping around to different stuff.
Satellites don't work on the globe.
Well, satellites orbit the Earth according to the globe.
With having electronics up in the sky.
fantasy.
What's the problem with having electronics up in the sky? We can have electronics up in the sky. We can have planes up there that are capable of flying for months on end. Solar powered stuff.
Propulsion,
We've got
but
balloons.
satellites use gravity to orbit around the idea of the globe
put up
Earth.
there. They've got little boxes that they put up there. They got solar panels on them, and they can stay up there for a long time. But they use like helium, and they use balloons, and they use powered air flight.
Plumb up.
But
there is a system. Shut up! That I'm trying to address Plumb up. There is a system called electromagnetic laser array, and they can charge the airplane from the ground with lasers from station to station.
Yes, and also by using electrical charges, they're able to change the altitude and elevation of them too. It's like the technology is pretty wild. So the whole concept of we don't believe in satellites is pretty stupid. Satellites are very real. It's technology
not that you don't believe in that.
that's up in the sky.
Simply that the idea of satellites is heavily based on gravity. You get it up into space and then you let it orbit.
Electromagnetism.
Wrong.
So then I guess I'm going to move this to a new point. If we have such advanced technology, why have we not been to the edge of the Earth yet? Why is this such a big barrier?
You're probably not even allowed to leave your country, dude. What are you talking about?
I've been to Japan. I've been to Europe. I've left my country a ton of different times.
Have you headed towards the ends of the world? Do you know the pilot that's gonna take you there and take you back? Do you know him?
Have I been to the edge of the world? I mean, no, but
to the ends of the world.
To the ends, no, but I mean, there's lots of scientists in Antarctica. There's lots of scientists who've lived in the North Arctic. There's science boats that are continuously in the North Arctic. There's permanent installations.
So
in
once
Antarctica.
you find it, let us know.
But what about the videos that you can see in the Arctic?
Yeah, that's the Arctic. That's what you see.
Yeah.
Isn't the Arctic supposed to be the edge of the world?
Arctic?
No. What is the edge of the world?
From your
it's whatever you imagine it to be in your head. Because
he's confused with the Antarctic.
If we have satellites and we have such advanced technology, shouldn't we know this?
Dude, hold on. We're not making any of those claims about where the edge or the end of the world is. We're not doing that. So I think you confuse Arctic with Antarctic, but we're not even saying that.
I mean, I'm talking about the Northern Arctic and Antarctic. I'm just saying that if we have satellites, we do have planes, obviously, we have all this stuff. Why do we not know what the edge of the world is? That's my question. Why have we not been to the edge of the Earth if we have such advanced
like you and me, because we have the information that we're spoon-fed, because we're not explorers. We don't know the limitations of this realm from first-hand experience. That's why we don't know.
Right. Edge of what? So get yourself an airplane, right?
I can't even claim if anybody actually does.
Airplanes exist. So get yourself an airplane, go fly it, dead reckoning south. And you tell me when you end up exactly where you started. Have you tried that?
I'm not a pilot, but there's lots of accounts of people having done it.
That's why we don't know.
So planes exist. So get in a plane, dead reckon south. I'm not saying use magnetic south. I'm not saying use GPS south. I'm saying start from where you're currently located, wherever you take off, dead reckon south, and then end up back where you started.
Hey, can I add something real quick, Replay?
Yeah, absolutely.
Just so you know, there's never been a single flight in the history of humanity that has gone circumnavigation from north to south to north again.
What about east to west?
Ever. Okay, so you're just going around a northern magnetic section.
East to west works on both conceptions, right? So that's why I said get in an airplane, dead reckon south, and come back to where you started. Dead reckon south, come back to where you started. It's 2025. Why has that never happened?
Is the map that I sent earlier similar to how you guys see it, or no?
Maps are projections
just so I can visualize. Just so I can visualize. So according to the map I sent, the North Arctic would be the center, and the Antarctic would be the edges.
No.
Okay.
Maps are a projection of the graticule based on an individual's location relative to the celestial sphere. That's all it is, bro. So when you get in a plane, you dead reckon south, and you come back to where you started, then you can come back and have a conversation. Because maps are merely projections based off an individual's current location relative to the graticule and the celestial sphere. Does that make sense?
Yeah, no, I get what you're saying. I'm wrapping it all back to the same thing where you can fly north to south and you can get to different sides of the world from either direction. But yeah, I get what you're saying. So, I'm gonna mute myself again for a minute. I'm gonna dig up a little more flight data, and I'll come back to you guys in a bit. Let's let somebody else talk.
Did you see the flight data they posted for you? The black box data?
Who posted it? Let me pull it up.
Maybe Plumbob. I'm not sure. Let me check.
I see flight pass from Snack. Is that it? I'm gonna open that one up. I see something posted by Snack flight data.
Plumbob posted it.
Santiago to Australia. Okay, yeah. Let me look at this for a second.
It's something that Plumbob posted.
Oh, Plumbob did. Okay, let me look. Looking for it. Give me 1 second.
It's right at the bottom. I reposted it.
Oh, okay, that one. Yep. Okay.
That's pretty important. I mean, I think that kind of just shuts the conversation up.
All right. Again, I'm going to mute myself for a minute so I can go over this stuff. I can't just read it and instantly give you an opinion on it. So give me a minute. I'll mute myself.
You go ahead.
So pay attention to it. There's one line in the chart there that is labeled as pitch. It's the pitch of the aircraft. And the pitch of the aircraft maintains itself when it's flying at level flight at approximately 3 degrees above the horizon. That's the air cushion that it creates so that it's got lift so that it can keep flying. And you'll notice that the elevation, the ground, there's no curvature. And at no point did the plane have to dip down to go around a curve of supposed globe, which if it was a globe, it would most certainly have to do, especially at a plane flying at 500 to 600 miles an hour. That curve's going to be coming pretty fast, and you're going to have to keep pitching your nose down. So why does the pitch data say that the plane didn't do any of that? It just flew over a horizontal plane.
I will look at the pitch. I'm gonna read all this over, do a little bit of quick research, and I will get right back to you guys.
Yep, go ahead, put a spin on it, and try and make it turn out curved for you so that you feel better.
Yeah, do what you can to cope.
You know, we get questioned so much about this stuff, but as these people, they grew up like us with the heliocentric model. Not once did we ever question the heliocentric model when we grew up. Maybe some of us did, but for the most part, no. We just accepted it. We believed it, just like these people that come here, the Globers, and they just believe it. And yet they're defending it at every cost. It's got to be a globe. And they never questioned it back then, but they're questioning it now because it's just got to be a globe.
We got Snowcat still. Is he still going? What do we got now?
Hey, what's up? Yeah, I guess you guys were talking about the flight logs and stuff like that. I was just curious, like, what are some great sources and stuff that you guys use to get some of this stuff? Because I'm curious and kind of learning more about that.
Okay, cool. Plum Bob, if you want to go ahead.
Well, it came from NTSB, National Transportation Board of Safety. Or Safety Board, I should say, NTSB. That's where that data came from, is that National Transportation Safety Board. That's where I got that from.
Is that because I know there are several places that track flight. Is that the best one to find the flight data? I was just curious because I was looking up some myself.
I don't think we need to find any more. I think we've seen enough. You know, we know now that the Earth is measured flat, aviated flat, navigated flat, and practically used as flat. We don't need any more. We just have to even just look at the simple principles of water, the physics of water. And apparently, 70% of the known surface area of the known land and waterways is water. And if water lays flat and level, how can you have a sphere with 70% flat? That doesn't make any sense. Where's the critical thinkers in here?
Yeah, I can't argue with that.
Many try.
In other words, there's no debate. It's not a debate that we're going to have that somebody can win just because they've got more money or stupider arguments. It's just flat. The Earth is flat, aviated flat, navigated flat, practically used that way. And that's what we got. And that's where we are. And if you don't like it, that's your problem.
Yeah, the debate's definitely over. It's been over for a long time. It's just a matter of whether people are able to accept the very obvious truth that the globe is a complete failure.
That's where the critical thinking comes in. And we need more people to critically think. It seems like that's gone for down for a jump out of an airplane somewhere and crash landed. Nobody does that anymore.
Do you understand where the globe was derived from, Glober?
Are you talking to me? I'm kind of on the fence right now.
Okay.
But I was curious about the ISS. Like how does that all work?
Well, there's things above us, right? There's things above us. There's things that can be above us, regardless of whether the shape is what it is, right? But do you understand where the globe was derived from? Angular measurements, curved visual space. Do you understand what that means?
No. Those kind of sound like Jewish words.
Sounds like what?
Sorry, go ahead.
What did you say?
I didn't say anything.
The Earth is not flat.
Well, tell us all about it.
Yeah, it is.
Yeah, so it's all derived from angular measurements to curved visual space. So how do you think maps are created in the first place?
Yeah, it is.
No, it's not.
Do they use measurements?
Measurements of what?
Usually like land. So they'll get in like an airplane and then they'll look down and they use rulers and I don't know, there's some math involved.
Wait, they get rulers out on airplanes and measure land below them? You think that's how maps were derived?
Because if you take the ruler and then you multiply based on how high you are, they can kind of, and then they get a very skilled artist up there. I think nowadays they use digital artists, and they can kind of create the map.
So you think navigation is based on rulers in airplanes?
I mean, I think that's how they create the maps. I don't know if they navigate that way.
So you're telling me that maps that have been around since what? The predating Columbus, right? So pre-1400s, predating airplanes, were derived from rulers?
I don't think those were.
And airplanes?
Those were really shitty. I don't even think they invented rulers, and I'm pretty sure they didn't invent airplanes. So I think that came a lot later, but because those maps back then were really bad.
So if I can pull you up maps that were derived pre-airplanes that somewhat are close to what you think your conception of the world is, you think they're shitty?
Yeah, throw them at me.
Okay, well, just Google Maps when was the first flight? When did we first have
Google
airplanes?
Maps uses planes, doesn't it? Or are you talking maps before planes? Looking it up.
Maps before 1900, man.
Yeah.
Oh.
There's a whole lot of navigation that took place pre-1900. There's a whole lot of maps that took place pre-1900. How were those derived?
Very poorly. I mean, I think they just kind of had to walk and use because they didn't have the planes back then, so they kind of had to walk and use tape measures.
Give me the methodology that you used. That you said that they just walked. So what are they walking and writing on pieces of paper? Like, give me the methodology. You said they
were walking,
walked.
Then they were measuring, and then they
Did you hear him?
Pieces of paper.
He said they were walking with a tape measure before airplane.
Yeah.
Yeah, he's just being silly. So, yeah, Snowcat, what I want to ask you is, you said you weren't sure about the globe, so what is your reason for doubting it?
Well, I saw the moon landing, and I thought that was obviously fake.
What made you think that?
Just the kind of the lighting was really off. Like it felt like it came kind of showed from multiple angles, and just kind of some of the, like, honestly, a lot of it just looked weird, especially the reflections and the light.
Okay.
How'd you go from that to there not being curve on the Earth then? Because a lot of people think the moon land. I mean, no, we should say. I mean, they're obviously fake, but not all those people understand that the globe is also a lie. So how'd you go from that to that?
Well, I mean, obviously once you kind of realize that the lie about that, I feel like it's pretty you kind of start to go down, like see what they start to lie about more, and that's when you kind of start to realize that they don't really tell you everything.
That's pretty vague. So what would you say was the one piece of information that really clinched it for you?
One piece of, well, I wouldn't say it was a piece of information as much as it was just kind of, realizing that it was not what they were saying. There wasn't one piece of information.
Yeah. Okay. So you still believe in the globe? I mean, why is it you want us to?
Yeah.
Why do you want us to think that you don't? We don't care if you're a glober.
Well, I don't want you to think that I don't. I'm just.
Well, that's what you said. Yeah, you said you didn't really. You were on the fence. You weren't sure, but.
Yeah.
I don't hear any uncertainty in you. I haven't even heard one piece of information that makes you think you're seriously questioning it.
Hey, Snowcat, are you trying to pretend to see if this is how we became flat earthers?
No, but how did you?
We went out and looked.
Yeah, I mean, if you were serious, I mean, there would have been at least one, piece of
no, I mean,
objective information in your little fairy tale there. Mm-hmm.
I believe it was when Plumb Bob explained maps, how they make maps now. I'm talking about before. I completely.
Do we have any people with serious questions? I mean, go back to this troll if we want, but if there's anybody in here who has serious questions,
I got some new stuff.
Okay, let's hear your analysis of the flight data.
So back to the flight data. Somebody told me that there's never been a flight over the Antarctic. I just pulled up a flight in 2021. Somebody flew from Buenos Aires, Argentina to Darwin, Australia. You can look it up. It's verifiable. It happened. And then I have some other maps that I want to post. I've got the URLs all saved. I'm going to post them all in voice chat for you guys. And this is kind of where I've been trying to get at from the start. I don't know if I explained it poorly, but my point is just, why can you fly from, let's say, Tokyo to New York in 13 hours, or you can fly from Sydney, Australia to Santiago, Chile in 13 hours, when, if the Earth was flat, Australia and Chile would be very far from each other, whereas New York to Tokyo...
Prove it.
Just look at these maps I posted. Look at the maps I posted in the voice chat.
Yeah, I don't respect this because not 20 minutes ago you said it would take 2 hours to fly between those places.
Dude, I was giving my point wasn't an exact amount of hours.
You haven't digested. You don't know anything about it. You've just Googled this on the fly. You don't know that it carries to the conclusion that you're trying to draw from it, and here you are acting like you're some expert on this argument.
No, I'm not trying to be an expert, and this is on the fly. My point isn't that I have some exact number of data I can give you. My point isn't that. My point is simply that if the Earth was flat, the distances between either what I view as the southern and northern hemisphere, one would be further from the other, whereas the flight data shows that they are equally close to one another. That's my whole point. I'm not giving you exact numbers. My point is that one hemisphere should be farther from the other.
Yeah, prove what the actual distances would be. Go ahead.
Okay.
After 20 seconds of Googling, just let us know.
To Darwin distance.
Okay. We'll wait for the proof. Yeah, we'll wait for you to Google it. Yeah.
Okay, nautical miles, 7350 nautical miles. Now let's do Tokyo to New York nautical miles. Tokyo to New York.
Dude, you made a claim of what it would be if the water's not curving, like it doesn't. Prove that.
Are you using nautical miles? If you are, those are flat Earth. You know that nautical miles are flat Earth because you're going to make elevation angles to stars to get.
I mean, it's simply a measure of distance. At the end of the day, what measure of distance you use doesn't prove either idea of the Earth. At the end of the day,
not a measure of distance.
A nautical mile is a measure of distance. I'm not an expert on any of this. I am pulling shit up on the fly, but sorry, say that again.
I'm saying the flight distances you're going to claim, they're not measurements.
But has anyone looked at the links that I just sent yet? And can somebody... I'm not looking to like switch the subject to this and that. I just want you guys.
Yeah, the first one's a straw man. The first one's a straw man, and I don't want FlatEarth.WS's flight path version of that flight. I want to see the actual flight path from the actual people who
I'll pull that up.
the data.
Go to the second one, and I'll work on fixing the first one.
And while you're at it, you can also tell us how you verified the distance between those two locations.
Dude, I wasn't there. I'm not a pro at any of this, but at the end of the day, you have to put a certain degree of trust into public flight data. You guys are using public information as well, and I can respect
I'll give you
that.
another example then. I'll give you another example then.
Okay.
If you're flying 500 miles an hour on your plane, right? The plane is going 500 miles an hour. But you have a tailwind of 300 miles an hour. How fast are you flying?
I mean, if you're flying 500 miles per hour, you're flying 500 miles per hour. It's a matter of how much fuel you're using at that point.
What? If you're flying 500 miles an hour and you catch a tailwind of 300 miles an hour, how fast are you flying?
I suppose you would move towards 800, but obviously the pilot is going to slow the throttle on the jet so you match a certain level of speed and efficiency. It's like back in the 80s, they used to fly much faster to their destinations, but they started flying to conserve fuel. To conserve fuel. That's how commercial flights work. They conserve fuel to make it the most economic because we live in a capitalist society.
They call it wind.
Well,
they call it gesture and they save on fuel.
Yeah, I mean, it's like, okay, so when I flew to Japan, I got there in about 10 hours. I got back in about 8.5 or something because of the tailwind. They didn't have to, I guess, decelerate as much and use the amount of fuel that they were aiming towards. So yeah, you're gonna accelerate, but I mean, we're getting off of the point I'm trying to make.
By the way, your second link, it's also a straw man.
What is that? I'm sorry.
They're all straw mans, T-Dub.
It's a false representation of your opponent's argument. Actually, we didn't even make an argument about it, but one's been presented for us, apparently, according to this.
Well, I wasn't pulling them up as some sort of art, like, no, okay, sorry. My point was simply, how can you fly from two spots of the northern hemisphere, have them be the same distance from two spots in the southern hemisphere if there's only one hemisphere? Theoretically, one side of the Earth, either the northern or the southern hemisphere, has to be the center.
Premise. I'm gonna argue with your premise. Prove it.
Prove what?
Prove the distances that you just claimed, and then went ahead and built a conclusion on.
Just argue my theoretical argument for a second. Is there not?
Nah. No, thanks.
So isn't one hemisphere the center and one the outside if the Earth is flat? No,
I'm not going to argue your imaginary stuff, dude. No thanks. That's not the purpose of this.
I'm trying to make a legitimate argument with you guys. I'm not trying to bullshit anything. If the Earth is flat, one hemisphere is the center and one is the outside. Am I wrong in that assertion?
No, you're trying to use nautical miles, which are derived from an alleged circumference of the Earth, which is merely derived from the celestial sphere, which is measurement of the stars above you.
But the measurement I'm using...
it's not an actual measurement.
I'm using hours as a measurement. Flight hours based on commercial flight data.
Yes, you're using timing based on the stars. So you're using the graticule, which is literally the observed celestial sphere above you based on your current location as an observer. So you're measuring two curved visual space, and you're assuming that curved visual space is a curve below you.
So I can sit on a flight from these two locations with my phone, put a timer on.
Hold on, replay, because you're walking right past what he said. Do you understand what a graticule is?
No.
No? Okay. So when you're looking out at the horizon, and then you look up into the sky, and you take an angle from the horizon to the spot in the sky that you're looking at, that's called a graticule.
Okay.
It's a degree of.
I mean, half an hour ago, he thought it was 2 hours from Argentina to Australia.
I wasn't being exact, dude. I was trying to simply make a point from flying in two different directions and having it
based
be
on
different
stuff that you
times.
just make up and don't understand and can't verify. Yeah.
I've been very honest from the start that I'm not trying to use exact measurements in this. I'm arguing the basic idea that if the Earth is flat, one hemisphere is center and one is on the outside. That is all
I know what you're doing. You're looking at the AE map. You're looking at this map that seems to be in a circle because you Googled flat Earth map, and then you're trying to straw man that map.
Can you suggest them a better map?
Yeah, I mean the maps you sent me were completely rectangle, and at some point you need a map that properly represents flight data for me to be able to debate this with you.
Map. We do not need a map in order to determine that the surface of the Earth is flat. No, we don't.
No, what I'm saying is I'm just trying to debate flight data. That's all I'm trying to debate.
Relax, dude. Relax. You're learning all this for the first time. So all real maps are local maps. They're not global maps. They're not maps of the entire Earth. They're just maps of the local region. And all of those maps display flat Earth topography on them. Everything's based off of sea level, which sea level is that water is level when at rest. It's level at the ocean, and then all elevation is based off of that level at the ocean. Do you understand that?
Satellite, what you're saying, I understand, but what I'm saying is if we have satellites, how can we not map the entire planet together?
But if we have
be able to have a map of the whole Earth. If we have satellites where we can see the whole Earth, how can we not put together how it connects to one another? How can we not connect to the Earth?
Do you have access to all the satellites?
I mean, you can get certain levels of public satellite data, but at the end of the day, I get what you're saying. The government lies. I'm not disagreeing with you. But my point is, the amount of public satellite data that exists at this era in time is so expansive that you can no longer say that if we have satellite data coming from different countries. Sorry, say that again?
You say the data that's available is so expansive at this point, but you don't know that to be true.
I mean, how many countries have satellites? I couldn't give you an exact number, but I would say 40 to 50 countries probably have satellite data. A lot of it's public, obviously not military satellite, but there is certain satellite data that is public. Yeah.
You remember the satellite that supposedly China flew over the United States?
The hot air balloon?
Yeah.
Yeah.
Who was the president at that time?
Biden.
Okay, and what did he do? What did he do to that satellite?
Oh, we shot it down.
Shot it down with a missile.
He shot it down, right. So when you say, well, what about the satellites? That's what I think of when you say satellites, that they're all on balloons at really high altitudes. This one was just low. They got busted, and they had to dispose of it over water because if it fell on land, a bunch of conspiracy theorists might actually go there and try to figure out what the components are.
Wait, no, they weren't worried about.
I missed your point.
Why the motherfucking government was on that one?
Oh yeah, absolutely. I mean, I guess. So with a balloon satellite, I think the reason why you shoot down a balloon satellite is it's much closer to the ground. It's able to gather much more data through electronics, not just through imagery, but you're so close to the actual ground that you're able to wirelessly probably connect to a lot of different devices, download data, get much higher resolution pictures. I mean, a balloon satellite, when it's close to a potential, like, let's say, military asset, is much more valuable than a space satellite is. So that's why
so
I would
naive.
Yeah, another fucking base with flame replay.
Dude, I'm just trying to debate. You guys don't have to come at me like that. Just explain why I'm wrong.
You haven't proven the Earth curve yet.
No, I mean, Sheepdog, I'm liking talking to you. You're being really good about this, but a lot of people are just kind of shitting on me.
I'm giving you alternatives to your explanation. So really,
you're good.
What I want from you is measured Earth curve. Drop over distance.
Do you know how to do surveying? They got that shit, bro.
Do I know? I'm gonna be honest. I joined this Discord like a day ago, and I just thought it'd be fun to hop in and talk to you guys. I haven't done a ton of research on this. I haven't talked to my buddy Brian, who I used to debate this shit with, in years, and I just thought it'd be fun to hop in. I don't have all the data or the numbers. I just thought it'd be fun to talk about the flight data thing because that's always been my biggest thing that me and
if that's
my
your
buddy would
argument, then you
discuss.
go for it.
I mean that's what I can actually argue.
How your flight data or whatever it is you're appealing to proves the Earth's surface is curving.
Okay, so back to my point. Those links I just sent, all I'm asking is an explanation. Let me pull a few
No. What you think about them should stand alone and represent the globe with no need for a comparison to anything else that we think. Just show how it proves the Earth's surface is curving into a ball shape.
Yeah. No, they do. Give me one sec. I'm just pulling them up so I can look at it while I talk. Okay, so we have flights from New York to Tokyo. Takes 12 hours and 40 minutes. And we have flights from Australia to Chile, and they take 12 hours and 40 minutes. So back to my point. If we have a northern hemisphere and a southern hemisphere, the globe, it makes sense that both would take 12 hours and 40 minutes because you're flying from two equidistances just from different hemispheres. But if the Earth is flat, one hemisphere, which it would be the south, I would guess, would be further from one another because it would be on the outside. So that distance should be much greater than two distances from the northern hemisphere.
You're comparing what you think how a flat Earth should look and be distributed, right?
I swear to God. The way
you're just using a straw man again.
Sheepdog sent me a map
without
earlier.
saying the word flat Earth. Show how your flight data represents a globe.
Oh man! I swear to God, if I meet one of you motherfuckers, I'm gonna hurt you physically.
So you won't be able to do this, right? So your argument is reliant upon your opponent having some sort of alternative that you can compare with, right? So it's not a standalone proof for the globe, bro. And we're not using it, and we're not using it as any kind of. We're not using flight paths as any kind of proof, right? We've got flight data that shows that the way that aircraft operates absolutely does not involve flying over a ball, especially one that's spinning, right?
Oh wow, the Earth doesn't spin. No, it's the whole galaxy that's turning around us.
No, I get what you're saying, but to me, like, obviously, I'm not deep diving into the science of all this. You guys could probably just trash on me with all that, but what I can simply argue is flight data. So if you guys could give me some better maps, I saw the maps Sheepdog sent me earlier. Those are kind of hard to see what you're.
No, we're not doing that. It's not our aim. It's not our purpose. We don't. That's not our argument.
But that gives me an angle to see where you're coming from.
No, it doesn't. The angle we're coming from is the measurements of the Earth's surface directly on the surface, not speculation about the way. The flight paths or anything like that, all right? It's just direct measurement of the surface of the Earth. The surface of liquid being horizontal when it's at rest.
So, okay, question then. So, based on your measurements, is Argentina and Australia's distance from another further than the United States' distance from
We're not
Japan?
talking about distances, bro. Like, at the moment, like, we're just talking about the quality of the surface of the Earth, right? It's either has curvature rate to it, or it's just planar in nature, right? Particularly over water. Water's going to have the least amount of topography. Land masses are a bit harder to, like... But you know what? Do you know what? Even today, they use sea level as a horizontal standard, a horizontal plane of reference, a datum by which they can then gauge the elevation changes across land.
Yeah, that's
so. You know how they say this place and that place is so far or so far high or so far below sea level. That's a horizontal plane that they're describing, and they do this for the entire mapped Earth.
So if I explain to you guys that the Earth's surface is flat and curved at the same time because gravity warps space-time, are you familiar with that concept?
Yeah, don't red herring, bro.
That ain't a red herring, motherfucker. That's legit physics.
Yeah, it is. We weren't even talking about that. So you just expect us to move on to this different topic with you, right? Just disregard this other guy that we're in the middle of conversing with.
Oh, you guys are good. Give him a minute. I'm gonna mute myself. Go over shit. Give him a minute. I'm gonna mute myself. You guys talk that for a minute.
He's not making any sense. So,
what? Who, me?
Yeah, we'll probably find out in about 5 minutes.
You don't understand how something could be flat and curved because gravity warps space.
Because it's warped by space time.
No, by gravity.
Give me a demonstration.
Orbit. When you go in orbit, even
show me an
flying a
orbit.
plane, it's not.
Show me an orbit.
Well, show you one. You can watch the ISS fly overhead if you want. Or the Starlink.
How do you know that's an orbit?
What?
How do you know that's an orbit?
Why don't you get in a fucking rocket and go up there and look? I'm not doing that, but you want to so bad. Why don't you?
It's your evidence.
He doesn't know what he's talking about.
What? I know what I'm talking about. You motherfuckers think that you can trick a motherfucker into thinking something ain't real when it is. I don't like that at all.
Oh.
Oh.
Where's your evidence?
Oh, put your real name on that motherfucker and say shit.
Oh.
Yeah.
What is going on here? We opened up the complaint department, or what's happening?
Yeah. They took on my fucking shit before. Anyways. Wait, look.
I'm playing the dandelion. Ooh. What?
So you guys don't want to discuss pi or like orbit?
You guys ever see a bird fly over your house, motherfuckers? That's an orbit, motherfucker.
Hello, team. I do have something to say. I have something
What
to
is it?
say. Well, a long time ago, I heard that if the Earth is actually flat,
oh my God, right?
cats would have pushed everything over the edges. Have you guys heard that one before?
Yeah, and what would it fall off into?
I don't know. Maybe some abyss somewhere. I don't know. Well, you guys don't believe in space, do you?
What would pull it down?
It's falling all the yarn balls.
Yeah.
I don't know.
The reason why we can't get to the edge is because there's cats guarding it.
Yeah. Cats push everything over, right?
Yeah.
They beat it.
Hayden, you've been here a long time and you're still on the edge.
I'm on the edge. I just talked to you like 3 days ago today.
No, not me.
You guys are fascinating.
Are you actually Steven Tyler, Raiden?
No, I don't have any alt accounts or anything. I'm the same guy.
It was a living on the edge joke.
I got you. Okay, I see.
He's the same.
I'm thinking about doing what Scott Mackey talked about doing. I may write a book about you guys one day. I've never done that before. Mind of a flat earther. Does that sound like
So I kind of derailed the whole conversation. You guys don't want to talk about gravity or space time, dude.
It better be a big book, Raiden.
Raiden's the one that's wanting to talk to us now, man. You didn't want to talk to us anymore. Now nobody wants to talk.
Yeah, but Raiden doesn't want to talk about the topic. He wants to talk about the people and their minds.
I'm done. I just had a joke about cats. I'm done. I don't want to tell you.
Yeah, okay, shut up then.
Yeah, so what's up with that whole like gravity shit and how it warps like the physical reality of matter and all that thing? Like,
yeah, what is up with that?
Yeah,
hey, do you know what the calculations that they got for the GPS satellites that circle the Earth all the time? They have to like coincide with relativity and all that shit. Are you aware with that kind of math, or are you guys just a bunch of fucking wannabe fortune tellers or some shit? What are you?
Do you have the calculations that they use?
No, because my math ain't that advanced, but I know of them.
Oh, okay. So then how do you know that their math is talking about
Buddy, you can get in a fucking rocket and go up there if you want to.
Can you? Oh, you think that's the you?
Now it's for the money they spend on that American Fred, I reckon you could.
Maybe.
Oh, it ain't no maybe, buddy. At the very least, you could pay SpaceX.
How much
money? How much did they spend on that trip? About $1 million or $250,000, $500,000? What was that?
Oh, damn, dude. Maybe you should go do it and prove it.
Yeah, man. Yeah.
I'm not the one questioning reality. You guys are.
You're the one who came in here.
Yeah, because I like talking
Something
shit.
to prove? You got something to prove, though?
I don't know. I kind of like certain shit, especially with people that are just like trying to like warp the fabric of reality by telling lies, thinking they can create their own delusions and make them real.
Projection noted.
Yeah, exactly.
Like you're going to beat people up.
If only you knew how deep your own delusion was, man.
He's triggered. Trigger rush? Okay, God.
Anyways, what were you talking about?
You were projecting.
The curvature of the Earth.
Yep. What about it?
Or the lack of it.
Yeah, well, the funny thing about space-time...
That's space-time. Tell us about space-time, man.
How big is the Earth?
It's like around 40,000 kilometers is the circumference? Yeah, it's 40,000 kilometers around, just about, like 42, something like that.
What does that mean to you?
Not a whole lot. I don't plan on going around that motherfucker anytime soon, so what the fuck do I care? What's it mean to you?
Well, that means that there's a number there, and that number can be tested using observations of measurements.
Right.
Right.
You know, it's not exactly the same. Damn! Well, hey, they like the fucking soundboard over there, huh? Hey, you know that you could measure different... What would you call them? Oh, longitude... Yeah, that's funny. See, lines of latitude is different, though. Because the latitudes, they're not all the same. They're, they're shorter when you get north or south, but the equator is the longest one, of course. You guys are, you're not really adding to the conversation.
Who says anything about latitude and longitude being shorter or longer?
Well, you said something about the circumference of the Earth. I told you it's around 42,000. But it depends on where you're measuring from and where you're measuring around.
It's 40,000 kilometers. Now it's 42,000 kilometers.
Something like that. It's around 40.
Okay. You don't know.
It was exactly. It's different depending on where you are. So.
Okay. How much drop over distance would you observe when you're looking out over a flat surface, or what would be a flat surface?
I don't know. You guys always talk about that inch every 8 miles or some shit, or 8 inches a mile. What's the number again you always talk about?
I don't know. You're the one with the claim, so.
I'm not making a claim.
Yeah, you are. You're saying the Earth is a ball and it has a circumference of 40,000 kilometers.
Reiterating what is modern accepted science. It's not making.
Okay. Did you ever go out and test that?
I don't have to, because like millions of people have done it before me.
You made the claim we run millions that we just believed.
So you're just taking their word for it?
Right. So now I'm going to take
that sounds religious. That sounds religious, not science.
Yeah.
What you're talking is religious.
Like what?
That shit,
for example.
I don't question everything. Some things can be verified.
Okay. Sounds like you're naive. Thank you for sharing your naivety with us.
You think I'm naive because I believe...
I know for a fact you are. You just told us that you just believe what other people say.
Yeah, but I've had, education, I guess they call it these days. So where I can
indoctrination, education.
Indoctrination.
Psychological operation.
Yeah, you've been sold a bill of goods, bro, and now you're here defending it.
Now, what's
saying motherfucker every third sentence.
Getting more They just mopped the floor with you, buddy.
I don't think so, dude. You can question everything until the fucking cows come home and you're blue in the face, but it don't get you nowhere. Unless you're actually like...
According to you, don't go test nothing. According to you, yeah, don't go test nothing. Nope. Yeah, that's
Yeah,
smart.
I haven't turned blue yet.
I have lasers and all that craziness, man. I ain't got the equipment to test that shit. And plus, I don't need to.
Now you don't need to. Now you don't got the equipment. Yeah, okay.
Dude,
Cool.
I'm fucking you on a fucking cell phone, through a headset, through a satellite, through a tower, through all that shit. Bro. Like, you're still denying?
You can do it with a mirror flash. You're just lazy. So
I was about to say, I was saying the word mirror. I was serendipitous. Yeah, I was just gonna say, like, I bet you guys would look right in the fucking mirror and be like, that ain't me. That's funny, but hey, man, whatever.
You drunk, bro?
Yeah, no doubt.
No, which I was.
I hope you are.
Oh, you hope I am. Why? Why do you hope I'm drunk? You trying to take advantage of me?
Well, then you'd have an excuse.
To what? To try to school you fuckers out of reality? Now, I don't know why you guys get off on this shit. Maybe you don't have girlfriends or something. I don't know what it is.
Do you have a question, Eric? Do you have a question about the flat Earth?
Yeah, so do you guys know anything about motherfucking orbital mechanics at all?
Orbital mechanics. What would you like us? Yeah, what would you like us to know about that?
I'm asking you what you know about it. You speak.
Well, I know nothing's orbiting any globe because there's no globe. So
I know
what else
nobody's
is there
ever.
to know?
I know nobody has ever seen a full orbit of anything ever. Did he disappear?
That's a fact.
He left.
Yeah, I was calling him a troll, but he just coming in here to.
What's up, Professor?
I mean, you can't really not do that though, because that would just have children that aren't part of your society. Like that isn't. I don't know. The shape of the Earth isn't the only thing we instill in children. Like there are a bunch of other stuff you tell children.
I agree.
They'll be part of your function.
Yeah, that's fair and all, but when you look at the media that children get, it is disproportionately focused on the cosmos and the ancient past, such as dinosaurs, etc. It's unbalanced in the amount of time they focus on making sure that they say globe, globe, globe a million times, that they say stars, that they say cosmos, that they say dinosaurs. I mean, just look at kids stuff that you can buy. Like a large portion of it is covered in dinosaurs or space propaganda. Like it's not even up for debate that is what the majority of kids stuff is covered with.
Right. 2 questions for you. First, what would you want to see on TV? And second, do you not believe in dinosaurs?
It doesn't matter, dude, whether I believe in them or don't believe in them. Why is it so important that young kids who can't even think and understand time on that scale have to be told dinosaurs, dinosaurs, dinosaurs?
Yeah, no, but that's what I'm asking then. What would you want a kid to see on TV then? Like, what would you want a kid to be shown?
Well, how about living animals that are actually alive that can be actually seen and touched and felt, and not fantasy animals?
Okay. Besides
that, rest assured, all of the depictions of dinosaurs on they're constantly changing what the dinosaurs look like, what they were doing, when they lived. It's all fantasy. Like it's pure fiction. The majority of the stuff about dinosaurs, when you could really teach them about actual animals.
I mean, they do teach them about actual animals, though. Like a big part of kindergarten education is literally just teaching kids animals. Like I don't think I hope you guys remember kindergarten, and I think you guys do, but
no. See, you're missing it. It's the damage of the exposure to dinosaurs in space has already been done before you even get to kindergarten, dude.
But what's so bad about learning about dinosaurs?
Dude, it's not per se that it's bad to learn about the concept of dinosaurs. That's not the point. The point is they're cementing in these kids' head a cosmological scale of time and creation, in that they're synergized together in this worldview. You're basically indoctrinating them with a worldview.
Oh.
It's not about dinosaurs. It's not about space. It's about the worldview attached to it.
I get that, but first of all, if you were to, like, I don't know, have your ideal way of raising a child, you would still be indoctrinating them in a way, because like raising a child is inherently indoctrinating them. Like when you're teaching them a language, you're technically indoctrinating them. You're teaching like that's the only thing that you could speak now. If when you're teaching your child what's left and what's right, that's technically indoctrination. You're making them assign to a part of their body a name and to the other part of their body another name. Like that's indoctrination. It's not an objective truth. It's something we use as a society to work better. We just work better when we both have a common left and a common right. But at the end of the day, it's something completely arbitrary, that, and therefore it's inherently like indoctrination. Like education and like raising a child is inherently indoctrination. It's not bad to indoctrinate a kid, because that's how you make them be able to like question their ideas at the end of the day. If they wouldn't have that basis of like what you call indoctrination, they wouldn't be able to question stuff. Like
yeah, exactly. So you're right. So if kids aren't inundated with space and dinosaurs before they're in kindergarten, oh my goodness, society would fall apart. You're right.
No, I'm not saying that. That's really not my point. I don't think you understand my point. My point is, if you don't teach a kid about space and time, and like dinosaurs or whatever, why would they ever have an interest to question that? Why would they ever even know about that? Like, why would they ever even think about that if you don't ever speak to them about it? Do you get my point? Like,
right. So then parents should tell their kids, hey, this is a bunch of mumbo jumbo that isn't actually scientifically proven at all. It's mostly fantasy and worldview and philosophy under the guise of science, which you're going to be taught is one of the most ultimate arbiters of truth. And then they're going to try to trick you into this worldview. And so you should be suspect about it, because none of this is primarily accessible. And you'll notice that everything that you see about it is pure cartoons. Yeah, you're right. Maybe the parents should teach the kids that.
Sure. I'm not necessarily saying that. I don't think you're getting my point. My point is,
I am getting your point. Why is it the case that if somebody says they want to homeschool their child and teach them flat earth and not teach them the quote unquote mainstream, why are they considered a pariah in society, and that maybe there should be legal rules to prevent them from doing so?
Because that's not the standard. Like, it's normal for that.
Who cares, dude? So if you just invent a standard, then you can impose it on parents and usurp their natural right to raise their own children?
Yeah, we have standards in general that people have to respect in order for us to work. You, for example, would be arrested if you didn't feed your kid, because it's a standard to feed your kid. Like, that doesn't make it...
No, it's not a standard to feed your kid. Holy crap.
Yeah. It is, though. It is, though. It fits the definition of a standard. Why would that not be a standard? Yeah, okay, it's a standard because of very obvious reasons, but at the end of the day, it doesn't make it any less of a standard. Like, it's still a standard in the semantic sense of a standard. Like, yeah, okay, people need food. It's a very reasonable standard, but it's still a standard, though.
Yeah, people need food. They don't need to imagine Uranus smells like farts and it's raining diamonds on Smegma Prime.
What? Is that what you were taught?
No, dude, that is literally the news that comes out all the time. They sent a probe to Uranus, the planet, and they found out that it lets off a gas which smells like farts. Literally can't make this stuff up, dude.
I mean, it's not... Yeah, I wouldn't be shocked. It's a gas giant. Sulfur smells...
Yeah, I wouldn't be shocked if knowing any of that had any relevance to my daily life whatsoever, especially not some planet allegedly 1 trillion miles away that it rains diamonds on, which no one will ever be able to mine. It's like, who cares, dude? Stuff is so irrelevant, yet it's propped up as if it's somehow important.
I mean, yeah, a big part of science is that, I guess.
Yeah, a big part of science, falsely so-called, is making a bunch of outlandish claims about things that they can never prove or make valuable to anything we ever are going to do in exchange for prestige and money. Yeah, I'd agree with you.
Science isn't paid that well. You'd be surprised. We're not paid that good in science. But
hey, listen. Somebody in a field which is absolutely unproductive getting paid at all is too much.
You just called it prestigious and a waste of money, though.
No, I said some people do get prestige from being a scientist. In fact, scientists are revered in society as being the upper echelons of sincerity and truth.
I don't know where that's happening, but no, we're not. I don't get paid. Literally, I get paid a shit. Like I'm paid awful. Like what do you mean we're revered?
Okay, cool. What type of science do you do?
I'm a chemist. I have a PhD in chemistry.
Okay, so what products do you make?
What do you mean? What products do I make?
Well, like in order to get paid well, you have to provide a good service to somebody who's going to pay you for it, right?
Yeah,
so what do you make with your chemistry? Like, do you make chemicals? Do you make pills?
No, you don't. Yeah, okay, so research isn't just like making stuff. Like when you do research, it's way more niche than what you'd imagine it to be. Like it's not I make drugs.
Okay, yeah, I'd agree with you. So what you need to do, friend, is you need to start getting grant money to do research on exoplanet chemistry and trying to recreate the raining diamonds on planet Snoofa Prime 10,000, and then you could make a lot of money.
Sure, cool.
So instead of actually doing real chemistry on the Earth that might get me a better polymer for my earphones that's microbial and won't actually scratch my ear and leave me a rash, you could pretend that you're doing science on another world.
I don't get if you're angry at science in general, chemists in general, or just people that like doing stuff about planets. I don't really know who you're angry at.
I don't know. See, your chemistry doing actual research in real chemicals is something real that should actually be remunerated with reward.
Thanks.
Versus other dudes who are pretending that they know the chemical makeup of a object trillions upon trillions of miles away as if it's relevant, and money's being funneled to them instead of to you, which could actually get me a phone case that wouldn't slip out of my hands.
Okay, sure, I get your point. Yeah, I mean, it definitely feels distant when people talk about that type of stuff. I personally don't see the necessity of that type of stuff, and that's why I wasn't ever interested in that part of chemistry, and that's why I never, when I was...
Yeah, bro, that stuff has no necessity. I'll tell you, so here's the necessity of all of that quote-unquote research.
It definitely does.
It don't, dude. It has zero. The only necessity it has is into backing up the materialistic, secularist, atheist worldview nonsense. That's the only thing that it's ever done for anybody.
You'd be surprised how much of research seems very meaningless, and then it turns out to be really meaningful in the end. Like research isn't something that's like, okay, you study something for a few years, and then okay, boom, you've discovered something that's like life-changing and has really like good applications in very many like different fields. It doesn't really work like that. How research works.
Yeah, fair enough. Well, let me ask you this question, brother. Let's do some research. So, on the Earth, they've only dug down 8 miles, approximately.
Okay.
So they weren't even accurate with their predictions of what they would discover for 8 miles deep on the actual Earth we're standing on. Yet they want to tell you what planets that are trillions of miles away are made of. Think about that for a second.
Yeah, it's very hard to imagine that be true. Seeing how
it's not hard to imagine. It's hard that anybody takes it seriously.
No, I get your point. It's not intuitive at all, but a lot of science isn't intuitive. Like there are a bunch of things that are intuitive.
No, it's not that it's not intuitive, dude. It's that they have no evidence for their claims.
I mean, I don't know if they do. I haven't really checked their papers. I'm not.
Dude, sure. Listen, friend, they couldn't even get right what is below the surface of the Earth we're literally standing on, yet they want to tell you what other worlds that they have no tangible access to are made of. Are you kidding me, bro?
I mean, we can't get a lot of stuff on the Earth, right? Like, for example, you know how when you're going for a surgery, right? Or when you go to the dentist, they inject you with something with lidocaine to like numb you, to not feel anything. You know that, right? I assume you've had that happen already.
Yeah.
We don't know how that actually works. Like, we don't actually know how lidocaine works.
Exactly. So they don't know how lidocaine works on the Earth and the interactions between the body and the chemicals and all of that. Yet they're going to tell you how the chemicals work on a world trillions of miles away. Like, get real, brother.
No. My point is there's a bunch of stuff we don't understand, but that doesn't mean it makes it any less true. Like we don't understand how lidocaine works, but it doesn't mean we're gonna stop using it. We don't understand the molecular like pathways and the whole signaling that goes on for that specific drug. Sure, we don't understand that, but that doesn't mean we're not going to use it. Same with how we don't understand specifically what's in the earth, even though I don't know if we do. I haven't really seen a paper on that. I need to research that a little. But yeah, we probably don't understand that, but we understand something that's way more complex because it's probably easier to analyze.
Yeah, I agree with you. So let's set the baseline. It's easier to analyze the composition, structure, mass distribution, and elements to the core of an object trillions of miles away that we can only see with light versus the actual composition of the Earth we're standing on. Do you realize how stupid that sounds?
It may sound stupid to someone that hasn't had
it is stupid. It is stupid.
That doesn't have any formal training in the field. But I'm telling you, I can understand the structure of something that's only a few electrons long, but at the same time, I couldn't really tell you how a car works, right? Like, it's something that's very hard to understand when you don't have any formal training in the field, and when you haven't really had that much interaction with the field, like with science in general, from a very like formal.
No, dude. Often I find that I know more. So, for example, we had an astrophysicist in here, specializing in discovering exoplanets, new planets.
Right.
And he showed us an image of one of the things that he was doing, and it was basically like a 16 by 16 pixel grid, where some pixels were in the bottom left corner and some pixels were in the upper right corner, and they had different intensity. He was saying, "Oh, this is the host star, and this is the planet, and it's rotating like this, and it's made of this, and it has this mass." And I was like, "How could you know that from the 16 pixels?" And he's like, "Oh, well, you take the way they're moving, you assume an elliptical orbit, then you apply the assumption of the gravitational model." Right, of the ellipsi and the foci, and then you do all this math and blah, 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 blah. And I go, well, what's that math based on? Because all you see is these pixels and the scales. And so we went back through the cosmic distance ladder. This guy didn't even know the first rung of the cosmic distance ladder. Yet he's going to tell me that he can tell from 16 pixels that this is, 3 planets and this one is a star. I mean, get out of town, brother. Get out of town.
I'm not shocked. A lot of science is that. I can tell you, I don't know, what can I tell you right now? I could probably tell you right now, if you were to give me like a random solution, I could probably tell you what's in it just by looking at it. And it's not a lot of information, but to someone that has a lot of training in that field, you'd be able to do that. Like, if you were to give me right now, I don't know, just a few lines. Do you know what an NMR spectra is? Whatever, it's a thing in chemistry.
Endometriosis?
No, NMR spectra. It's something like whatever. It doesn't matter. When you look at it, it looks weird. It doesn't look intuitive at all. It's just a bunch of lines on paper. When I look at that, I can tell you what molecule I have in front of me. I can tell you how the atoms are linked to one another, what the charges are on them, how the electrons are distributed, stuff that's like at a molecular level. You don't see that. But I can
you do it from 16? Yeah. Cool. Can you do it from 16 billion miles away from the sample?
If I have the sample, it's a very different thing. In order to do an NMR, you need.
I know. That's what AI is trying to tell you, is that they don't have access to the sample that they claim they know the composition of. They don't have access, and they've never had access.
I can't. I don't know if I can give any truth to that claim because I haven't seen anything in relation to that. I need to see like a paper or something that says they didn't have a sample because I don't know how they do that. I just don't have any training in that field. I don't know how they personally measure the.
Oh, dude! The only way for them to have a sample would be to have a vessel that can travel billions upon billions of miles and then return to bring it back to them. No such vessel exists. Okay, let's rest it right there. So they don't have a sample. Period. End of story.
So how did they determine, like, how did they make their claims then? Like what's the basis of their claims?
Conjecture.
Like, so you're telling me they just wrote a paper that says, you guys, we think it smells like sulfur because it looks like sulfur. Like, is that it? Is that what they're saying? Like, or we think it's gassy because it looks like gas, or like what's I don't know. Like, what's the claim they're making?
I think they use probably like reflection spectroscopy or hold on, I have to look it up. For the Uranus smells like gas, it's something novel. Hold on.
Well, that before we go on, while you're looking that up, I just want to make sure everyone understands that when I first came up on that article, so here's the article. I'm just going to say it as I read it. Organizational name, penis.
Wait, do you have it in front of you?
Just hold on, brother. The organizational name was called penis. It was an acronym. Hey, let me finish. You're ruining my joke, dude. Holy crap.
Okay, go.
Do I need a banner that says "joke incoming"? Do not ruin.
Yeah.
So now I had to say the word penis 2 times without any context because of you. Now I said it 3 times. Holy crap.
I'm sorry.
Okay, so the organization's name is PNAS, pronounced penis. And it says, from that organization, your anus smells like farts. So that's a joke that writes itself, brother.
Yeah. Are you sure it isn't a joke? Like, where'd you find that?
No, they're deadly serious, dude. That organization actually has all kinds of literature that comes out. I can't remember what the name of it is, but it might be the P in the end stand for something, and the end might be astronomical sciences or something. I can't remember.
Wait, let me look them up on Google Scholar. Cool.
Look, I posted a link to the paper. They use, it's called Near Infrared Integral Field Spectrometer.
Oh, is this the one detection of hydrogen sulfide above the clouds? That?
Yeah, the one I just posted.
Okay, perfect. Oh, wait. I might actually be able to do something with this because this is chemistry. Hold on.
Now, if I remember right from the first time reading this, they claim they detected 0.3 parts per million of hydrogen sulfide.
Okay.
Are you familiar with the gas chromatograph spectrometer?
Yeah.
Okay. What is the sensitivity of that?
The sensitivity of what? Of what'd you say? Gas?
The gas chromatograph spectrometer.
I mean, it really depends on what you're doing because you can select it usually, if I'm not mistaken. But
you talked about nuclear resonance imaging. That you've seen.
That usually,
but that's not as precise as a gas chromatograph spectrometer. That doesn't.
No. But NMR usually goes. So it depends on what nucleus you're analyzing, right? So if you're analyzing proton NMR, that you would usually go up to a 20, if I'm not mistaken, 20 ppm. Or if you're doing like carbon NMR, that can usually go to maybe 200.
20 now 20 ppm. They claim they're sub 1.3 from 16 billion miles away.
No, but ppm in this situation doesn't. It's a very different. Wait, let me look at this article.
How many different meanings are parts per million?
No, wait, let me look at this article. It depends. It means different stuff in different contexts.
No, it means parts per million, bro.
It means
it's a ratio of a number. It's not subjective.
But when you're saying ppm in the context of NMR, that is related in the way in which, like, how do I explain this? Like basically, it's a coupling constant. That's what. Have you heard of coupling constants? Vicinal coupling.
Yes, I know what coupling constants are.
Oh, you do? Wait.
I graduated university like 20 years ago, bro. Okay.
Oh, really? Wait,
longer than that, 40 years ago. Holy shit, I'm old. 30 years ago.
What'd you study?
Computer science.
Oh, computer science. Oh, cool. Oh, they taught you that? That's okay. Cool.
Why wouldn't they teach me that? Is there a rule against it?
No. I mean, it's not. They don't usually teach NMR in a CS degree. That's usually.
I know a lot of shit about a lot of shit, bro. You'd be surprised.
Good for you. Okay, wait. Let me look at this. Indicate.
I am an endless store of useless information.
Here we present evidence of nuclear detection.
But gas chromatograph. The reason I know about it, because I did a deep dive research on crime scene investigations. some of the techniques they use. Yeah, so CSI type stuff and how garbage it is. Pretty garbage. But the point is, gas chromatic gas spectrometry, at least the time that this paper was published, had a sensitivity of 3 parts per million. That's when you have access to the sample. They're claiming 10 times an order of magnitude better than that from 16 billion miles away.
Yeah, no, that's what I'm not interested.
Why wouldn't I be skeptical of that? I'd be a fool not to be skeptical.
Wait, let me read it a little bit. I want to see.
You got to understand, there is no fact checking in astronomy.
Wait, let me see their discussion. If we could be sure.
Or astrophysics or anything in that field. It's just like they can literally say fucking anything.
How many citations does this have? Wait, metrics. Sorry. I mean, it's in Nature. It's good. 108. Yeah, sure. This is a good article. Okay. Which is da-da-da.
We need some elevator music.
So analysis to model the observer. Now let's just listen. Did they make an observation, or did they just have a model that said it could be that? To model the observed spectra, we used the Nemesis nonlinear optimal estimator for multivariate spectral analysis, retrieval model, using the correlated K approximation with K tables generated from the monthly published KLMC at 8K went blind, so it's another published paper, right? So,
hold on.
You do chemistry, right?
I'm not here to prove this article wrong.
Do you do chemistry?
Yeah.
Okay, so the techniques you use in chemistry are sound. Okay, the techniques they use in astronomy, astrophysics, cosmology, they are not sound.
Hold on, wait.
Because all they have is observation. Listen, you can actually, in chemistry, you can do the experiment because you physically have samples. Okay? Now imagine you published a chemistry paper and you looked across the room with a telescope at some bubbling fucking liquid on the other side, and then you started saying you know what the composition is and what the chemical reaction was based upon you looking at it, staring at it. That you'd never get published. That is fucking no chemist would ever take you seriously. You'd never get published. You'd probably freaking, I don't even know what. They would laugh. They'd be laughing forever. Haha, he fucking wrote a chemistry paper from a telescope. Right? But they claim, but this is the difference between what you're doing and what astronomy is doing. They claim they know causes. They claim they know the causes of effects. They claim that they know the chemical composition, how old it is, how hot it is, how far away it is. They claim that they can know all these things just by looking at light, which is crazy. That is a crazy claim.
Right.
And who's checking? The same fucking people that are making the crazy claims are checking the crazy claims.
Wait. For fraction, okay.
Like LIGO. You ever heard of LIGO? The gravity wave observatory. Yeah. You ever heard of LIGO, the gravity wave observatory?
LIGO?
LIGO. LIGO.
No, I haven't heard of that, no.
It detects gravity waves. Allegedly detected gravity waves.
I have not heard
They
of that.
claim that instrument can detect a displacement of their little measuring mass that is 1/1000th of a proton diameter. So if a proton in the mass moves 1/1000th of its diameter, they can measure that motion.
Yeah, I mean I'm not shocked with that. I can, yeah.
That's 1/1000th of a proton.
Yeah, that's not. Yeah, we can do that. Yeah.
A proton is 10 to the negative 37 meters.
I don't know the length of it, but yeah, it's really small.
Yeah, it's really small. Yeah, you could say that. Yeah, it's really small. Yeah.
Yeah,
thanks, dude.
Small. Yeah, no, I don't know why you're laughing. It's definitely a small thing, yeah.
Well, they're saying they can measure some subdivision of that. What are they measuring that with?
We can measure a bunch of stuff. Like that's not shocking. I can measure. What can I measure? I can tell you like just again looking at something, shooting light at something very easy to do in practice. I can tell you how stuff is linked to another thing, like something that's like submolecular. You don't see on a microscope. You can't see that shit. But I can tell you that a carbon is bounded to this and that and that. Like I can tell you that just by shooting light.
I can get you to doubt your faith in light giving an accurate measurement right now. Watch. It's very simple. So when you take a laser transit methodology and you apply it to the surface of the Earth over 25 miles of water, you debunk the globe geometry by 2 orders of magnitude, proving the Earth is flat. Because if water's flat and it covers 70% of the Earth, ipso facto, the Earth is flat. Proven by laser measurement methodology.
Laser measurement. What specific laser measurement methodology?
Laser transit. You level a laser, right? Just like you do on a construction site, and then you put a storyboard on the other side and you get the differential, right? And if the Earth is a globe, it's going to be one thing, and if the Earth is flat, it's not going to be that thing. Guess what? It's been done, and it's not a globe.
Right. Do you have a paper for that?
Yeah, I got a documentary and an associated 120-page PDF leading up to the 25-mile shot.
No, man, I can't work with that. Like, I will read a paper happily. I'll happily read a paper that's like well reviewed and like okay.
Well reviewed. What does that mean?
Sorry, peer reviewed. Is that better?
You know, most peer reviewed.
No, but I can look at a paper. Look, the thing is, I can.
Yeah, I'd agree with you, brother. So the first paper I'm going to give you to read that's peer reviewed, it's called the Peer Review Crisis. Once you understand that, then we can move on.
I mean, I'm not going to doubt the peer reviewing system. That it's like central to the research I do. It's like
so you do realize that most citrus fruit. Why don't you know that most peer reviewed research is wrong? Why don't you know that?
Why don't I know that? Because it's not. That's the whole point of it. You make other people read it.
Most of it's wrong. Most of it, like 90% of it.
How can you prove that? I can.
Indio, we got to be gracious. Indio, real quick. Got to be gracious because his field is actually a real science. And so he's thinking that the real science scrutiny that he does in his field applies to all these other pseudoscience fields, which is his error.
No, that's the thing. I can't. Again, I don't know a bunch of stuff about astrophysics. I'm not.
Go on Google, type in most peer-reviewed research wrong, and see what happens.
Is this the thing from PubMed?
Yeah.
Santa Dagas? Okay. This why most published. Okay, so this is an article. How many citations?
All right. So speaking of peer review, a guy, PhD in optics, Dr. John D. He came across this idea about using measurements of the Earth to determine whether it's globe or flat. So he used a dual band laser system and he reproduced the test. He didn't just review it; he reproduced it. And according to him, and he actually published it on YouTube, and you can watch it. He found that after accounting for everything and using his dual band laser, which he did for a reason, which is so that he could get the accurate refraction index because different wavelengths refract at different rates. And he basically concluded, after being a globe earther and applying his physics knowledge to measuring the Earth, that the Earth is indeed flat. It's not a globe after all, because just like the other laser test, the Earth measures flat.
And you said he's you said he's a physicist?
Yeah, PhD, specializing in optics. And not only that, but there's been numerous other tests. People have done it over 35 miles on land, et cetera, et cetera.
I mean, I'd have a
You can do it.
Why do you choose to believe that certain physicists and not every other physicist? Like, don't you think that's cherry picking a little bit?
Because none of those other physicists did any tests.
So what would you consider a test to be then? Like, what would qualify as a test for you?
He just described it to you.
Yeah, okay, that's a type of test, but like it's not a test in general. You have multiple types of other tests. Like why that test specifically is the only valid one?
Oh, because it's a direct measurement of the surface. That's why.
It's what?
It's directly measuring the surface.
Okay, so wait, is it measuring the surface or is it measuring the curvature or is it just like not measuring anything, it's just determining if a curve exists?
Yeah, dude, it's the same type of methodology that you use in building things when you want to make a level surface with a laser.
But like, yeah, but the point
you get the laser.
Yeah, no, I get that.
You level the laser, and then you get the differentials between the parallelness of the beam and the surface. Right? Pretty standard method.
Wait, what is this? Sorry. Right, yeah, no. But I mean, like, but my question is, why do you believe this certain physicist, not every other one? Like, what makes
because they haven't done anything. I already answered that.
But that's my question.
There's no contrary data, brother. Don't you understand? There's no contrary data that anybody's gathered to say, hey, this is wrong.
What do you mean? No, there is, though, because if there wouldn't be any contrary data...
Okay, then show us. Post it in the chat, dude.
No, I can't post anything in the chat. It's not like I...
Of course, because it doesn't exist, dude. 6 years ago, we had a guy come in here with 3 PhDs that said, it stands to reason that because there's more globe earthers than flat earthers, there must be more globe earth laser tests. And as such, that means... And he went to go look. And now it's 6 years ago, and he's never been back. So, listen.
I just really want a paper about this test, specifically, like this globe test. Like, not a YouTube video or a documentary, because I'm not going to watch that. I just want a paper, like an article I can read.
I just posted one. These are the measurement results. Are you under the impression that peer review replicates the research?
No, I didn't say that. I've never said that.
Okay, then what is the point of peer review? What is the point of peer review? What is the point of peer review?
I don't get why you're being aggressive with me. If you're going to talk
what is the point of peer review? Why can't you just answer? What is the point?
I'm not going to speak to you if you're going to be aggressive.
Listen. I want to know why you're appealing to peer review, because it seems very cowardly.
No, it's not. I don't think it's cowardly, but again, I don't want to...
It is cowardly because you don't want to address any evidence by just saying it's not peer reviewed. Should we publish it in an open access journal and then just go put a flag up and say, hey, now we got something peer reviewed? So what? Then you'd say, hey, this isn't the right journal.
Are you going to let me speak now? Is it okay if I speak?
Yeah, you're just trying to make it impossible. You're just trying to make it impossible for us to present any evidence by having an impossible standard that can't be met.
No, I literally didn't say that. Okay, I'll accept a non-peer-reviewed article. If it's an article that's published somewhere...
Would you accept if you did it?
Published.
If I did it?
Define published. Hey, bro, define published.
We didn't define published in a journal, in a scientific journal. Is that good?
Does that make it correct?
I'm not saying it's correct. I'm just saying I want something.
Then what good is the peer review if it doesn't mean it's correct or not? Why are you using that as some gatekeeping device?
I never said that.
Why are you using it as a gatekeeping device?
We're published in a scientific journal.
No, here, let's do peer review.
Need that, dude? I'm going to ask you like for the 10th time. Why is that important?
I'm not going to respond to you if you scream at me. I'm not going to do that.
Dude, then answer. You're not responding when I asked you nicely.
I'm not going to be doing that. I'm sorry.
Hold on, Citrus Fruit. I'm going to take care of this.
Politely to you.
No, hold on, Citrus Fruit. I'm going to handle Indio real quick. I'm going to peer review whether he's yelling at you is justified. I reviewed it. Yes, his yelling is justified. Now that it's peer reviewed and published, you can accept it.
I don't get what you guys are acting like.
Can't you do the peer review?
Anything mean to you?
Yeah, listen.
No,
go ahead, bro.
I'm really open to discussion. Like, I really want to talk to you guys. But if you're going to scream at me, we're not going to go.
Doesn't sound like it.
Yeah, listen, brother. I'm going to ask you now for the 11th time. What is the importance of peer review? Why is it useful? Why does it need to be applied?
If I answer that, do you promise you're going to stop screaming at me?
Okay. I'm going to ask you for the 12th time. Peer review. Why is it important? Why do we need that? Why is it the arbitrary truth?
All right. I never said it's the arbitrary truth. First of all, peer review, yes, can sometimes be wrong. That is a fact. Some articles are peer reviewed, but in those cases, sometimes it just doesn't work. That's why we also look at other parts of an article in order to evaluate its quality. Like when you're looking at an article, the first thing that you look at is you look at the journal that it's published in, right? You look if it's peer reviewed. You look at the number of citations, publishing date, and methods used.
Why?
Because that's the way in which you can assess an article.
Why? Why do we do this?
Sorry, to determine again, if you're going to be aggressive with me, I'm not going to talk. So, can you let me finish? Is that fine?
Yeah, I want you to tell us. I want you to justify why we should. Brother.
That's how I speak.
Brother. Okay. You know what I want, and you're being obtuse on purpose. Okay? It isn't going to work.
Okay, I'm sorry.
You know you're being obtuse. Yeah, we can hear you giggling. Don't mute me. I'm a mod. I'll ban you. Okay.
But I'm not talking to the other guy.
I'm going to ask you again. Why are we using peer review?
I'm sorry.
You're still just talking over me, so you don't have to listen. Is that your plan?
Okay, cool.
I'm going to ask you again.
Article someone sent.
I think this dude muted me.
So I think
he's
someone
going
said
on.
that this fee core thing is published somewhere, right? Is that?
Dude, unmute me, or just stay the way you are.
Hey, Citrus Fruit, we don't take kindly to people muting each other, because then you just talk while the other person's talking. Doesn't work. So unmute Indio, right? And then instead of being obtuse about answering his question, just give him a straightforward answer. And then you solved your problem. You can continue the convo. Plenty of people listening right now that are wondering why, when asked, since you're supposedly the scientist, you can't just give a simple answer why peer review is necessary. And to say that peer review is necessary because the first thing I have to do to legitimize something is see if it's in a peer-reviewed journal, that's just circular reasoning. That's not answering the question. And for goodness sakes, and for the love of God, please just answer the question.
Yeah, we just want he's probably not even listening. We want a justification in case I'm going to assume I'm unmuted. We want a justification for using that as some step in the process. Why should we use it? What does it say about? Yeah, we know you can't talk. So why is it important? Jesus Christ. Now you're unmuted. Am I muted? Did you mute me?
No, you're not.
Yes or no? Okay, so really simply, I'm going to state it kindly, and I'd like you to answer. Why are we using peer review? Why is that an arbiter of the truth? You know, peer review is a new invention. It's only been done since about the 1970s. Prior to that, there was no peer review. They didn't do peer review. Well, it's true.
Okay.
If you want do you want the history of peer review and how it came about into the modern era? It was actually Ghislaine Maxwell's father, his name's Jordan Maxwell, that monopolized all the journals so that he could sell them to the government. And that's how he became a billionaire. He owned Elsevier.
Wait, so
right? So that's a whole nother story. The point is, peer review is a new thing, and what is its utility? I just gave you an article that said most peer-reviewed research is wrong. So if you are going to have some gatekeeping thing where I'm not going to consider it unless it's peer-reviewed, I'd like you to justify that.
No. Again, I didn't say.
Still talking over me. I'm going to ask you what I just said to you, okay?
I won't be treated like a child. I'm sorry. Why are you treating?
Yeah, I'm going to ask you what I just said to you to make sure you just heard me. Well, I won't be interrupted rudely either.
You did that already to me multiple times, though.
I'm not going to be treated like a child, but I'm going to ask like a child. But you did it first.
I'm sorry. I don't.
Grow up, bro. Like, seriously?
I didn't. I'm sorry. If you want.
Why are you laughing?
We can talk.
He's laughing because he's a child. He thought he's going to bullshit his way. You don't have a degree in goddamn anything. Okay.
I'm sorry. Okay.
To be fair, you're supposed to know this stuff because you said you appealed to it in your field, and so everyone's listening is hearing you not just answer the question.
You're a university student that thought you could bullshit your way through this, and you can't. Okay. Listen.
I can answer.
Yeah. So. Okay. So give us a justification
as to why we think peer review is important. Like why we
the justification on why you won't look at the research that we're providing to you because it's not peer reviewed. That justification.
First of all, I didn't say that. I'd happily look at anything that's not peer reviewed if it's an article. I just said I won't look at a fucking documentary because I don't have that time. That was my whole point. 1, 2, peer review is important. Yes, we look.
Why?
Because it's other scientists in your field reviewing your article. Like that's the whole.
That's
thing.
not a why.
It's important though. It's important to have other experts in your field.
That's your claim. Why? You're just restating the same claim. I'm asking you why. The justification.
Because for example, if you went wrong in your work, you can have someone else say, okay, you went wrong there. That's why what you're doing is wrong. Like, it's someone else looking at your work over again and just like saying, okay, sure, that's where you went wrong. That's where you did good. Like, that's it.
And what are they looking for?
They're usually looking at your methods. So your methods specifically, like, what's most important? Is it coherent? Is it in line with your topic? Does it actually prove a point? And then they're also looking at other like minor.
Does it prove a point? Really?
Yeah, does it prove what you set out to prove? Yeah. Like, if you have, does it prove what you're trying to prove?
First of all, science doesn't prove things. Okay.
It does though. Like, that's the whole. Like, that's how a research paper works. You have a title.
So you graduated university, but never took philosophy 101.
Yeah, no, we don't do that where I live. We don't have philosophy classes and stuff.
You don't take philosophy 101? It's pretty much a required course in every university going back probably 20 years.
Every science degree, as far as I know.
Not in France. I did my whole.
Oh, no wonder, dude. Oh my goodness, there explains it all.
Yeah, no, I did.
Not in France, so they don't have philosophy in university in France.
Yeah, no, you don't do philosophy in a STEM degree. You just do STEM courses.
So the starting point of Descartes' skepticism and all that crap, which led to the problem of induction, which plagues every scientific endeavor. Somehow they don't teach that in France. Yeah, I just find that hard to believe.
You can look it up.
No.
I can give you the name of my.
Well, science doesn't prove things. You can Google that too. Just type in "does science prove things?" It doesn't, because it uses induction, which contains the logical fallacy of affirming the consequent. Okay, so it doesn't prove things. It actually, most science, other than natural science, can't actually prove anything because it's theoretical. So you can have a hypothesis.
Not all science is theoretical, though. It's not all theoretical.
You can't eliminate alternate hypotheses, dude. This is the problem.
I mean, you can't say science is theoretical. That's not true, though. You have stuff that is like actually practical. You can look at it and say that happened. Like, if I put a shit ton of ethanol over a bunch of cells, they're all gonna die. I can tell you.
Okay, citrus fruit, real quick, brother, real quick. You're making a classic mistake, and that is the mistake of, I'm a scientist. I'm a real scientist doing real science with real tangible results, samples, and experiments. Therefore, other people who are called scientists are doing the same thing. That's not true. These astronomers and astrophysicists are not doing science, brother. That's what we're trying to tell you. They're making it up.
I don't think you're getting my point. I never said I'm trying to like say their work is good. What they did is correct. What they did is like the complete truth. I never said that. We're just talking about science in general. Like, I'm not specifically trying to defend astrophysicists. I'm not trying to defend their work and say it's good. Like, I never said any of that. Yeah, I guess this has just turned into a whole discussion about.
Okay, so there's two parts of. Okay, so you should know there's two parts of a published paper. There's the experiment, and then there's the explanation part, right? Why you got that result. Now you can mix. You can do your chemistry experiment, right? And you can have no clue why that happened, and you can do it over and over and over and over again. And I agree with you. That's the actual science part. But the part they call science in modern day is the theory on the why that happened, right? The how and the why. And they come up with, mathematical models and, claim, cause, and effect relationships, yada, yada, yada. The peer-reviewed part is only the explanation part. And they'll look at the experiment for sources of error, confounding variables, shit like that, right? Which is the actual only utility of the peer review process, is just like, hey, man, what is something maybe they didn't take into account? And what is the source of error? What are the starting assumptions? These types of things. That's all peer review does. But you don't need somebody else to tell you that. You can evaluate that for yourself.
Not really. Peer review doesn't. It's not. Peer review isn't people calculating like statistic constants on your paper. It's not really what they do.
No, what I said is they'll evaluate the experiment, right? They'll go, what are the sources of error? What are some confounding variables? What are some variables that they left out for some reason, right?
Yeah.
Did they apply the right statistical method for processing the data? Is the data over-processed?
Sure, yeah.
Do they have all these freaking floating parameters that they can just freaking move like little slider bars to fit whatever theory they have into the observation? So this is the stuff they review, right? So this is the stuff they're reviewing, but this is a straightforward measurement. All we're doing is measuring something. Now, anybody can evaluate the methodology of measuring. Hey, what was the equipment they used? What was the distance? What does the goal predict? What was measured? Like, you don't need, it's not a complicated thing. It's simply a measurement.
Right.
Right? You can, like, you know, you go to the doctor's office, anybody in the doctor's office, the receptionist, the nurse, your doctor, can measure your height, right?
Yeah, sorry, wait, I don't think, what's your point? I don't get it.
Because we're just measuring something. We're just measuring the distance that a laser increases or does not increase from the surface of the Earth. Because with distance, the further the laser goes along the surface of the Earth, the farther away from the surface of the Earth it should get.
All right.
Right? Because the Earth's supposed to be curving and the laser's going straight, right? So they should separate.
Can someone send me a link to what you're talking about, like the experiment thing? Maybe someone sent it.
I'll show you. I'll show you a diagram so you can visualize it. Okay, how about that?
Yeah, or maybe that's like article or whatever you're talking about.
I already posted it a while ago.
Can you send it again? Because I can't.
Shit. Wait, so look at this diagram, right?
Right.
See, as a laser goes along the surface of the Earth, it should increase in distance. And all you have to do is measure its height from the surface of the Earth to see if the distance is increasing along the height of the laser. Now, the globe model is going to make certain predictions. For instance, at 40 kilometers, a laser should be, if you start at 2 meters above the surface of water and you shine a laser 40 kilometers, it should be 127 meters off the surface of the Earth. At the other end, 40 kilometers away.
Yeah. Wait, is this?
Does that seem like a lot to you?
Wait, no, sorry. Wait, I think I know what you're talking about. Is this the experiment they did like a while ago, and the guys got proven wrong? Is that it?
No, not Netflix, dude. Come on, man.
Okay, like YouTube's any better? I'm sorry. Wait, no, is this... Wait, I think I found a video of it. The one where they put, like, the flashlight between two, like, boards with circles.
Holy crap. Hey, brother, hey, citrus fruit, real quick. Okay, laser, flashlight. One starts with L, one starts with F. So if you're bringing up something about a flashlight, it's not what we're talking about here.
Great. Thank you. I would have never known.
Okay. Okay. So this was done in the Netherlands, right? At Lake IJsselmeer. It was done, if you read the report, which I just posted.
Okay.
They had meteorological stations at both ends. They took all the weather data. They just did it once. They went back 3 weeks later and did it again. They have 5 measurement results, right? So they did horizontal pans of the laser. They did increasing distances. And the thing is, the globe makes certain predictions on how high the laser should be. The results here are not within the range of what the globe predicts. They're off by 2 orders of magnitude. It's not close. That's why we use this as an example, is because it's not close.
But who is this company, Fecor?
They're a nonprofit.
Okay, and who are they exactly? Like, who's?
Why does that matter? Why does that matter?
It's relevant.
That's a genetic fallacy. That the information is right or wrong based upon who it comes from.
I mean, don't you think that's straight up? But you're contradicting yourself, though. You're saying the articles.
What are you talking about?
You're saying the articles written by physicists are wrong because other physicists in the field.
I never said that. I never said anything like that.
Yeah, that's bogus, brother.
I never said anything like that.
What was said is that some people.
I'm totally convinced now.
Check this out, brother. Check it out, Citrus. We said that some people are wrong because these measurements disprove their claims. Had nothing to do with who they are whatsoever.
No, but I'm sorry, but you're saying the results, like scientists post on like in known journals, you're saying those are fake because they're posted by scientists.
No one said that. Why are you saying that again?
We were talking like a few minutes ago about how the data they found on Uranus is false. And now you're saying that the data posted by a company that's visibly like...
No, I didn't say it was false. I said there's no way it can possibly be true because we know that on Earth, the max precision that we can get from elemental analysis is 3 parts per million. Okay, and they're claiming an order of magnitude greater than that. Okay, which is capped,
what I'm looking at right now. Wait, I'll just show you guys what I'm looking at right now, just so you. Oh, okay. Wait, I can't share screen. Oh, okay, fuck. That's awesome.
Funny how you keep
address the laser, dude.
I can
before you address the laser, Citrus. It's just funny. Hold on, brother. Hold on.
I'm very down to talk.
No, I'm going to point something out. I'm going to point something out, and I want you to reflect on it.
Go ahead.
Everything we have said is about particulars of the tools being used and the scope of their abilities. Where you keep bringing it back to the people. Why is it that you're so focused on the people and not the accuracy of the tools?
Because it's relevant. It's part of the scientific process. Like I can look at your data. I can look at your data and make like a conclusion based on it.
Yeah, but you're trying to look at their biography.
I'm just telling you.
You're trying to look at their biography, though.
The data can be.
Yeah, that's a good one.
You're proposing.
Yeah, brother, you're not talking
a certain conclusion that isn't necessarily true because the data in itself isn't true.
Yeah, but you're not talking about data. That's just a lie. You're talking about their biographical fucking information.
Because it's relevant. If I were to post a study...
No, it's not. Their biographical information changes the test results.
You can't...
What if it's you and me that go and do this, Citrus?
Sorry.
Citrus, what if it's yourself and myself that go out and do this test? Is now it null and void because we're freaking nobodies?
No, if it was between me and you, sure, I'd believe that. But since it's something from the internet, I don't know who made it. I don't know the source. You have to analyze that.
Well, how about instead of poisoning the well, you assess the information first, then get back to us?
Okay, sure. Let's look at the information you're proposing. Let's look at this 121 slide thing. Cool. Okay.
It's in big type. I think you can read it quickly. There's lots of pictures. You can do it.
Yeah, there's a preface and initial data, and then there's 17 tests. So you can just skip to the end of the last test, and then you don't have to read all the previous 16.
Okay, they're using a camera and a telescope. Okay. Cool, closer distance, blah, blah. Measurement procedure, so...
All right, while you're reading that, just read to yourself calmly while I help the audience understand what the scientific method is. So, step one of the scientific method is establish who it is that's conducting the experiment. Until you establish that, you can't go any further.
It doesn't work like that. It's about the validity of stuff you're saying. You're saying they can't prove certain things, like in other papers, because maybe they have a different agenda, because they're paid by someone to do that research and like.
Dude, how long is that straw man bullshit you're gonna make?
It's not.
Nobody said anything. That's the third time.
Okay.
Third time.
So does that mean you don't believe?
Nobody said anything like what you're saying. Not even remotely close. We did not appeal to who they are. We did not. We talked about their data and the instruments they're using and their methodology. Why are you over talking me? We talked about the There we go again. So with the instruments they use, their methodology. What they claim they measured is out of whack with what we know is possible terrestrially by an order of magnitude. They don't actually have a sample, and it's a model. It's a model of what the structure should look like instead of actual. Why are you constantly over talking, dude? What the fuck is your issue?
You've been over talking me multiple times, by the way. I don't get it.
So you're doing it for revenge?
Sorry?
Are you doing it for revenge then?
I'm sorry. What are we talking about?
You're a dishonest fuck, bro.
Track India.
Just go on mute, bro. Just fucking go on mute.
Dude, what we're talking about is that you can't get your head out of the fact that the personalities aren't relevant to the veracity of the data. The data is either true or false. And for some reason, you keep projecting that onto us as if that's what we're doing. But really, you're just admitting your epistemology is based on faith and personalities rather than the veracity of the data. I mean, that's my conclusion. I think that's pretty well founded based on what you keep saying. It's like you can't get away from it for some reason.
It's not a company, dude. You can try that again. It's a nonprofit. It was paid for by donations. Good try, though. So I already told you it was a nonprofit, Citrus Fruit, and so now why are you lying?
Oh, no, I'm done with this conversation. I'm sorry, I'm leaving. I'm just saying, if you guys are going to look at data.
Let me help you.
Look at it.
Let me help you.
Hold on. Listen, out of the kindness of my heart, I'm going to finish his sentence. So what I wanted to teach you guys is that if you're going to look up data, the most important thing you should do is verify who the person is and whether or not he cheated on his wife.
Seems
How come
legit.
How come it doesn't list what they had for breakfast in there? I want to know, because that's important. Because it's an important meal of the day.
Yes, it is the most important meal. And if they didn't have Wheaties and it's a high performance experiment, they probably didn't do it because you got to eat your Wheaties. Oh, do you guys got Wheaties in Australia? Do you even know
Yeah, I
what
don't know if
that
they're the
is?
same thing or not.
Well, they always have athletes on the cover.
Wheat Bix, yeah.
Yeah, we got Wheaties. I always get a kick out of seeing the old Bruce Jenner ones when he was like a decathlon athlete. And he's like all buff, like with a javelin in his hand.
That must be worth a pretty penny.
I know, right? He's probably trying to buy them all and burn them.
You remember that clip where he was manhandling Ben Shapiro?
Oh yeah, that's right.
He was like, if you say that again, you're going to go home in an ambulance. And Ben Shapiro was like, "Oh, how very tolerant and peaceful of your view."
That's so funny, man. I forgot about that. Dude, he's huge too. Even as a woman, he's like a fucking beast.
Yeah.
Dude, like seriously, when I was a kid, dude, I thought that was like the coolest thing. I wasn't like when I was like 4 or 5. Like I wasn't into like professional sports or anything like that. But the Olympics, I thought was cool. And then he was like, the best because he could do it all, right?
Yep.
So, anybody else catch the Shiva debacle?
Only the title.
Oh, dude, it was so bad. I mean, holy Jesus! First of all, McToon's in it, and right there, right off the rip, and he said he was banned from here, which is false. And he said there's a video on my channel showing me being banned. So I went and watched the video, and he clearly clicks the disconnect button. So after muting the entire room, so it's really funny, just a blatant. Anyway, the point is that my God, dude, it is just like an embarrassment that this guy ever took. It isn't academia at all. He's an embarrassment, quite honestly. There's no way to even describe it. It was basically like a 3-on-1 global debate of 3 people telling the flat earther how he's stupid and how they need to do this. We have to do this experiment this other way. It's just so fucking. It's so bad. But
So it said on there.
From go.
What was the title again? It was like flat versus round.
Flat versus round summit.
Summit. Yeah, flat versus round summit, applying the scientific method. So like right there, it's like, okay, how to apply the scientific method to just a measurement of a shape? I mean, good grief, dude. How much stupider could you be?
He said you have to express your hypothesis into a mathematical equation.
What the heck?
Yeah, bro. It's a freaking train wreck, bro. And he used the example of F equals MA.
Holy crap.
Yeah, dude. Dude, that's what I'm trying to tell you, man. It was so much worse than I thought.
So basically, dude, We should retitle this video "Examples of the Dunning-Kruger Effect."
Yeah, and his example was two competing hypotheses: F equals ma versus F equals ma squared, and it more closely fits F equals ma. Well, how did you get those variables? What did you measure to get any of those variables? The values, to know if it fits in the first place. How'd you measure the mass? How'd you measure the force? Acceleration seems straightforward. But then you would need to know what are the other two variables. Well, where'd those come from?
Just read the first comment. These people are retarded.
It was so much worse than what I thought. I was actually in the chat for a while.
It's like the first comment. I caught the live event. It was such a rich exchange, teaching and learning.
He kept saying the flat earthers, he has to teach him like he's in kindergarten. So the person that was the flat earther, I think it was Kevin Samuels, that's his name. He's not a native English speaker. So he's talking like him, but you can tell that he's having trouble speaking because he's not a native English speaker. And Shiva kept saying, do I have to explain it to you like you're in kindergarten? He said that like 6 or 7 times. And that was like very irritating to me because it was obvious he was having troubles not only expressing himself, but understanding what was being said because he doesn't speak English. Which begs the question, why was he involved in that anyway? And where were the other flat earthers? And I thought they were all supposed to fly out and go in a conference room and write it all on a whiteboard. And like everything he said would happen, none of that shit happened. There was 3 Globers, because I'm counting him as a Glober. There was McToon, another anti-flat earther that did radio, so some sort of some sort of radio stuff in the military. And Shiva, the dude that was McToon, just sat there doing nothing. The radio guy kept talking about, well, there's no mirages in radio waves, and if the Earth was flat, there'd be no radar horizon, and so it's basically almost like a debate. It was almost like a flat Earth, one flat earther with broken English versus 3 anti-flat earthers debate, more than actually collaborating to get some frickin' test done. But the radio guy just kept saying shit which is just blatantly wrong. Oh, water doesn't really have an effect on UHF. You could just like Google it, dude. Water is like the only thing that affects VHF, which is crazy, dude, that this guy's saying that shit. Water increases the absorption and attenuation of VHF, and he said the exact opposite of that, and claiming he's an expert in radio. UHF, rather. He said there'd be no radar horizon on the flat Earth. Oh, yeah. None at all. Just go forever. It was bad. It was bad, dude. If you value your like literally, it's like puke in your mouth level bad.
Dude, I posted, why would anyone need the scientific method to simply measure a shape of an object? Perhaps we need a summit on teaching how to measure for children. Holy crap.
Yeah, and they're butchering, like they didn't, what were they saying? They were like, instead of using the term for the imprecision of a measurement, like the uncertainty of a measurement, they were using a completely different word. And Shiva was using it too, and I'm like, how the frick did this guy get into, like, in the university it's called, there's 2 measurement things, right? There's the precision of the measurement, and then there's the uncertainty of the measurement result, which would be a bounded range. They were calling it something completely freaking different. And I'm like, man, but this guy, he's an MIT graduate with freaking 3 degrees or whatever. Like, why doesn't he correct them and tell them, these are anti-flat earthers, mind you, and correct them and tell them they're using like the wrong terminology. Like, it was just, I don't know. I don't even know what to say. It was so much worse than I thought. This guy is like, no matter how bad I think it is, this dude's like going down fast. In my opinion of him, like fast.
He might have to have a special meeting with his employer.
He is his own employer. He's got a lot of grips going, I found out. He's got a lot of like donate to this and donate to that and donate to this other thing. And I'm sure it's a legitimate employment thing in Massachusetts to start a nonprofit, make yourself the head administrator, and pay yourself basically the proceeds of that nonprofit administering the penny that's left.
Yeah. There's one corporate structure, which I don't know if it applies to nonprofit, where you as the owner are entitled to 10%. And then after that, the remaining 90% is then considered the shares. What was one of their ideas?
I think the Globetards want to do another sun observation, which is, I don't even know, like, predict where the sun is based upon some model, but they're so stupid, and I've told McToon this already, that another thing where he starts some shit in an X thread and then bails on it, that they don't use a globe model to predict where the sun is. So that will be quite the litmus test to Shiva's veracity, quite honestly. Because if he doesn't look at the math and see, hey, in the math, there's no globe model, there's no globe in there, then it's not that it's not actually a globe prediction. Then that what this dude was proposing, and he said it wasn't even his idea, it was to get the elevation of an airplane when it's coming down on its glide slope at 20 kilometers away, and making a elevation prediction, flat Earth versus globe prediction, which is convoluted, and they didn't like that one. And the reason they gave is because the radar measures the arc length, or the radar measures the straight line distance, but it's supposed to be the arc length. And so basically, the radio guy was coming up with all these reasons why you can't do it. One of them being the imprecision of the measurement, that it was accurate to it was only accurate to within 0.6 of a kilometer or something. I mean, that was for the distance, but that the difference in drop would be 20 meters. And then he was like, hey, well, you can just do it farther. And then they're like, no. Then Shiva just literally just shut that down. As soon as he said farther, he just shut that shit fucking down right away. And of course, the other guy, and so the whole time she was lecturing this dude, Kevin Samuels, the whole time he was lecturing them. But when the Goldbergs can say any fucking stupid thing they want, and he doesn't say a goddamn word to them, he actually lectured, well, where'd you get that from? You have to give us citations. So in science, we give citations. When the Glober right before him just spouted a whole bunch of nonsense claims, and he did not demand a single fucking citation for any of that shit. Anyway, that's not the point. So they were like, okay, well, you could use UHF in a freaking airplane and get a receiver at some lighthouse far away. And if the Earth's the globe, there'll be a radar horizon where you won't be able to pick up the UHF signal. But on a flat Earth, there'll be no radar horizon. And so then they started arguing about that. Well, we don't. If this is kind of like the seeing too far thing. This is what the Glover said. This is kind of like the seeing too far thing. But there's no mirages in radar. Yeah, there is. Fucking simple Google search. Yeah, there is. They're not visible mirages. They're just not qualitative, but the same effects, right? The reflection, right? So the radio waves will reflect. You'll get multipath interference. All these things, all these problems with UHF that you'd have, that you would have a flat Earth radio horizon. And he even said, he's like, well, sometimes the radio horizon is real far away, and that's ducting. That's ducting around the globe, right? So he already made it so that that no flat Earth observation can disprove the globe, because he can say, well, it's ducting. It's ducting for fucking 500 miles. So, you can't, dude, it's I don't even know what to say. Yeah, kind of have to see it for yourself. I don't recommend it, but it's pathetic.
It sounds like ducting is what he had to do to pass MIT.
This is like, they had two Globers. They had McToon and some guy. He worked in radar, or not radar, but radio transmission in the military, or as a hobbyist or something like that. I can't remember exactly what his background was. He was clearly an anti-flat earther, and clearly knew what he was talking about to a degree, but he was making claims that are just baloney, dude. That you literally can just Google and see that his claims were just baloney. Like I said, the water absorption, the attenuation, the lack of mirages, the no radar horizon on a flat Earth, just all sorts of crap. And then after he did all that of going back and forth, now Shiva's buying this supposedly, as if he probably is buying it. Well, I brought this guy here, and he's an expert in the field, and why don't you just go with his experiment? Why, because they poo-pooed the one he wanted to do with the plane glide slope, and then he's trying to go with he's trying to push his lighthouse experiment, and then she was trying to push that on him, right? Based upon all these other things, but like I said, right at the end, he says, well, sometimes the radar horizon's far, and then you have ducting because of a temperature inversion. Well, you just said you're supposed to be doing an experiment that's a positive flat or globe, and then you just eliminated the globe as being falsifiable by this experiment. By saying, in some instances, there's no radar horizon. Right? And that's ducting. So if you have a no radar horizon, it's not a flat Earth, it's ducting. And if there is a radar horizon, it's not absorption or attenuation, it's a globe. It's so scummy. I don't even know it. I'm sorry. I'm ranting. It was irritating to watch that shit.
Hey, when they were talking about the glide slope, I mean, somebody could have just said, hey, how about we just get the pre-fusion algorithm Adiru rotational attitude data? Yeah, for you Globers out there who don't know what I just said, supposedly there's a system on the plane that measures the reference frame of the plane relative to the Earth and its initial attitude and its flight, and it would prove that it would be rotating or not rotating as it travels in an arc or over a flat, parallel line to the Earth. So supposedly that already exists in the airplane's subsystems, and if you just can get that pre-algorithm, you'd have some data that might be useful. Too bad they hide it and then put an algorithm on it and then make it to where you can't tell what's really going on. And so the end result, the end data of the plane, this is their own language. The plane recognizes it as a static reference shift rather than a dynamic rotation. So that means that the plane is fully capable of flying exactly congruent with flying over a flat Earth. So the data is 100% congruent with a flat Earth and shows absolutely no curvature whatsoever. Man, they should have had Wolfie 6020 on. He would have set him straight. He said, "Hey, it's all in the black box, brother." Yeah, we all know it isn't in there though. That's
Why
the
not just have Will Duffy on? I want to know how McToon fucking weasels his way into everything. Fucking everything, dude. When Witsit went on, when Witsit went on InfoWars, the Harrison guy, that dude Harrison said that McToon was fucking like in his DMs, like blowing his shit up, sending him fucking emails. He like weasels his way into freaking everything.
Yeah. You know what's funny, dude, is remember back when McToon debated Brian's logic? Part of it was, I think they were talking about some of the aircraft data. Supposedly, he was personally invited by Duffy to debate McToon. But yeah, they all work together. And wasn't it Duffy that was on McToon where he lied about not knowing him?
Yep.
Yeah, that's not suspicious.
Maybe they all have the same agent.
Well, I just told you, dude. The dude's a blatant liar, dude. You can go look at that video, look in the chat. He says multiple times that he was banned from the server. He's not banned now. He's never been banned, ever, since the server opened. It said, you can go look at it on the live stream, and it clearly shows him disconnecting from the VC because he couldn't answer a question about where he got the distance to the sun. Meme was asking him, where'd you get the distance from the sun? So what he does is he goes on mute, tells his audience, oh, they measured it with radar, blah, 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 and then he disconnects from the VC. So he muted the VC, our VC that he was in, to monologue to his audience, and then disconnects. And claims he's banned, which is a lie. Never was banned.
All right, listen, I'm back from the future, and McToon has a public announcement that although it may appear that that's what happened, he was actually hacked by the expert Flat Earth hackers to make it look like he was lying. It's funny how you can just make up excuses after the fact to explain anything away, kind of like their stupid globe. Unfalsifiable gibberish.
DJ sent me a DM because Fight the Flat Earth was in that VC or in that text chat that he wants to debate me. I don't think so. I told him maybe I'll debate him. I told him where I am. I said you can come debate me anytime you want. I just don't want him to make any money off of it. I'm not going to make that money. I told them both. I'm like, you're like, I told them both, demonetize your channel if it's not about money. Real simple. Your response, you can't tell us what to do. Okay. Not going to debate me till you demonetize your channel. Or at least demonetize that video if you're going to stream it.
You know what, dude? That's a very, very interesting way to put it. Because there's been other flat earthers who've said, I won't debate you unless I get paid $5,000. But then it turns out that they ended up debating those people. So then I'm kind of scratching my head. Did they get paid for that debate?
Maybe.
Interesting. So Will Duffy's out there offering flat earthers $5,000 to come debate McToon because nobody wants to.
Yeah, he's been he's been on all the platforms trying to get people to debate him. Probably broke. Probably needs money.
Oh, Brenda was out advertising for McToon. Hey, McToon's there, and you can't get no flat earthers to debate him. Is that because you're all scared? Maybe you should come over.
Yeah, he has people that go out all the time. I mean, it's a common thing for him. He sends people out that look for people to debate him. Must be nice to have lackeys.
What's going on, friends?
What's up, Vlad? How are you?
Another day, another dollar.
Is that Canadian or American?
You need to debate Peterson.
Crypto. It's crypto, baby. Fuck all that.
Did I debate Peterson?
Yeah, and he posted on his channel. So, like, what's
times.
the thing? Yeah, so what?
Yeah. I didn't know he was streaming at the time.
Oh, okay, gotcha.
The Blitz PhD guy, I didn't really. I mean, I knew he was going to be streaming, but this is different. That dude makes he's got 1 million TikTok subs or something. Like, it isn't going to make it. It isn't going to make him any money. People like McToon Fight the Flat Earth. They live off that shit. Okay, it's a different situation. Because Blitz PhD, he makes other videos that aren't Flat Earth. What Flat Earth is just part of his stuff. McToon and Fight the Flat Earth, that's their whole thing. If they weren't getting super chats from other globetards, they'd starve to death. I'm trying to help them starve to death.
Yeah, some of them, like I did, some of the episodes that I watched, they got like $1,000 in super chats.
That's what I'm saying, dude. I'm not
do it every weekend.
For that.
That's like four grand a month just off of bitching about flat Earth for a few hours every Saturday.
Yeah, go on there so he can monologue and don't provide evidence, lie, talk shit about you, and make $1,000. I don't think so, dude. Get another fool.
Maybe that's why they're unwilling to actually participate in a definitive test, because then their grift is gone. So if they prove the Earth is a globe, then their grift is gone. If they prove the Earth is flat, then their grift is gone. So either way, they lose.
No, they can milk. They can keep their channel alive for a couple of years, saying about how they were wrong, right, and arguing from the other side, like Jaren is.
Hey, from what I hear, Jarenism's channel got fucking nobody listens to him anymore. Ever since he switched, it's like the Globers are like, oh, this guy's just echo chambering our fucking shit. So the Globers don't listen to that guy. And all the Flat Earthers just said, this guy's a fucking moron. And so Jaren's fucking failing completely. That's what I'm hearing from fucking Geo's channel.
Same with Witsit Gets It.
Yeah, Witsit's also on the fucking spiral downwards. That's why he's on Geo's channel every day now, almost. But friends, how about this winter, eh? I mean, fall. It's still fall, but yeah, it's getting colder. Ooh.
It's global warming.
Dude, I'm outside. I'm in New England outside, fixing my tools in my van, and it's actually quite nice out.
Yeah, well, I'm up here up north in Canada, and it's like close to fucking 1 degree.
I'm in.
Yeah, but wait, is it Celsius? Hold on, are you Celsius degrees over there?
Yeah, Celsius, not Fahrenheit. Celsius, obviously Celsius.
All right. So right above freezing.
Yeah, I mean, it's like maybe 5. I'm just exaggerating because I just stepped out, and when you just step out, it's only 3 degrees outside. My bad, it's 3 degrees. Holy fuck. So it's kind of right. So it feels colder when you just go from warm to cold. But as I'm walking and I'm warming up, it's getting better. It's getting nicer. You know, just the 5 minute of just pure fucking fast pace. You know, speed walking. They get the blood flowing. Friends. What a fucking life we live, eh? You guys, what's happening in New York, eh? Friends, the Muslims are taking over. Is that it? What's going on? Friends, it starts with one, and then it spreads more. But then you ask yourself, what's better? Is it the Muslims or the Jews? Oh, are we recording? My bad. Sorry, I shouldn't be talking like this. I'll go quiet.
Yeah,
Sorry.
quiet.
My bad. But that's a real question, though.
He's a flat earther Jew. I mean, Muslim.
Who? Mamdani?
This new guy. Yeah.
Who cares? Flat Earth isn't a virtue. Doesn't mean you're a good person just because you accept the Earth being flat.
Yeah, none of these people that work in government are good people.
Well, I mean, plenty of them are just doing their jobs as best they can. Like, government is one of the largest employers in the United States. So, you know, you're going to have a myriad of people. You're going to have some dirtbags, some scumbags, some good people, some bad people.
I just don't like the fanaticism, you know, the fanaticism from any fucking side, and then pushing their shit on people. That's what I really don't like, you know. Them screaming in the middle of a fucking Times Square about how everybody should be a fucking Muslim, you know. I saw that video. I was like, yo, this is fucked. Sharia law.
Bro, isn't half your country like India now?
Yeah, buddy, don't get me started, bro. Holy shit. Bro, don't get me started.
This isn't the late night politics hour.
Yeah, this is Speculation Sunday time, baby. It's almost Sunday, friends. Well, it's Sunday somewhere.
Minutes.
Sunday
45
somewhere,
minutes.
buddy. Only where you are, bro.
yeah, but I'm the clock.
Who the fuck made you the clock?
I called it first.
Nah, man. I think.
Listen, you. By the rules of firsties and no takebacks, I'm the clock. I win.
Oh man, take that shit back, bro. I think the time starts in China. Right? Isn't it like on the 0th degree? Somewhere around China in the east?
Dude, I'm in the EST time zone. That stands for Established Standard Time.
No, but isn't it UT Universal Transit Time? Isn't that the better one? Isn't it the universal one?
Listen, I don't go by that UTI time, okay? I'm not into that.
You just haven't had enough fun, that's why.
Oh,
you don't know
did you watch anything about Shiva's summit?
What the fuck is that?
So Dr. Shiva, some dude, got a PhD supposedly from MIT, and he was trying to do this thing where flat earthers and globe earthers would come together and use the scientific method to do an experiment that proves the earth is flat or a globe, which really isn't where you apply science anyway. But anyway, it just happened today. It's been going on for months where he's trying to get flat earthers and globe earthers to show up. But he had really crazy demands from the flat earthers, like they had to dox themselves, essentially. He blocked Indio and some other guys who were trying to communicate with him from us, because they were basically like, hey, we're not gonna dox ourselves. Why can't you just accept our statements, based on the facts rather than our personalities? But anyway, it happened today, and it was a train wreck. McToon was there, like one flat earther was there, and the two other stupid globers were there, doing their stupid globe stuff. And Shiva making an embarrassment of himself, of a MIT education, making MIT look bad.
Right. So there's no conclusive anything. They didn't conclude anything.
No, well, the only thing they were trying to do was to agree on a test that would decide the situation. And I guess the concept was the flat earthers and the globe earthers agree on the test, and then Shiva uses his oversight and financing ability to help fund it so the test can get done. And to make sure that it's on the up and up. Yeah, nothing happened, exactly.
No surprise.
Because Shiva was supposed to be the I'm a scientist and I can make sure they follow the scientific method to make sure everything's on the up and up and above board. So in other words, he just made fun of the flat earther the entire time, like a pedantic a-hole.
That makes sense.
Classic Glober bait and switch. Hey, let's have a summit where we really come to grips on what's going on and, a meeting of the minds, but really I'm just here to make fun of you in public.
Man. Why don't they just come here if they want to talk with us so much? She said, hey, come here, friends. We're recording here, friends. Let's do it, friends.
And this funding method, was it like the Greater Sapiens funding method?
Yeah. Shiva needs a new pair of shoes.
Oh, yeah. Okay, friends. We all know that the Earth is a flat station, extended plane with topography, obviously. Mountains, hills, valleys, lakes, and all that shit. What else is new? Oh wait. That stupid comment that they're like, oh, NASA discovered this one-eye atlas coming. Oh, can you show some fucking pictures? Oh no, we don't got any. Fuckers.
Hey brother, props on the triple entendre joke.
Did I make one? I just didn't notice. Oh,
just trust me. Move on.
3-eye atlas. Yeah. The 3-eye. Now I got it. The 3 eyes. Or 1-eye atlas. What the fuck is it? Is it the 1-eye atlas or a 3-eye atlas?
I mean, I guess the name of it is 3/I Atlas or something like that.
Yeah. Some dumb shit.
You guys.
So when they make the fake AI videos talking about it, the videos go like this: "Oh man, it's coming! The 3-eye divided by Atlas," because there's the sign in there, and the AI is too stupid to know you're just supposed to use it as a pause.
Yeah. Fucking another thing, AI, fucking stupid fucking AI. What a fucking joke, Man, what is, I'm just on the sidelines now. I just love sitting on the sidelines and watching the catastrophe from both sides, Everybody's fucking retarded. It's just, everybody is just fucking retarded. The only one that makes any fucking sense, and this is the worst thing probably, the only one that makes fucking any sense is Nick Fuentes. and he was the Tucker Carlson Nick Fuentes interview. That shit was awesome. And then fucking what's his name? Tucker Carlson with fucking what's that bitch name? Interview after the Nick Fuentes, and how the girl's trying to grill fucking Tucker, and Tucker's like, you know what? You're a dumb bitch. Oh, I love it though. Everybody's fucking infighting. It's crazy. Fuck. The cover-ups, man. The cover-ups, bro. The crazy shit. Everything, bro. This is nuts. It's that one, the fucking left hand washing the right hand, and the left washing the right after that. It's just, fuck me. I'm just waiting for the crypto boom, friends. And make sure that you guys are loading up, because there's going to be a crypto boom and a dump. Oh, yeah.
No, always is.
Well, yeah, man, they always fucking. Oh man, just waiting for that boom, bro. It's the kaboom.
I'm not a trader, I'm a holder. That's why it doesn't matter.
Total.
Yeah, me hodl too. I hodl. No, I'm an accumulator. You know, I buy the dips every time there's a nice dipski. I fucking whatever change I have, I buy in. Literally, fucking this dip, I ran right to the bank. I went up, all the money I could, right to the fucking Bitcoin ATM. Take my money, and that's it. And now I'm holding again. Yeah.
Maybe that's part of the scam. Maybe once it gets everybody in,
friend.
and then dump it.
No. Well, that's the thing. No. It's not. It's like, it's gonna pump after. Like right now is the dip, bro. It's gonna pump and then it's gonna go crashing. Everybody the major institutions want to make a profit. They all bought in at the top. Well, technically at the top right now, right? So every fucking financial institution that's buying crypto, they're still buying like this top, right? This is gonna be a bottom soon, but still.
Yeah, I watch it go up and down, up and down, up and down, up and down. I never trade, I never sell, I never do nothing. I have a fat sack. I'm just waiting for that retirement.
Take some
day.
profit. Just take some profit. And every time, take some profit, bro. Trust me. I took profit. It was the best thing you could do. It makes you feel better because
capital gains, though.
I don't really know how I take profit when I'm ready to retire.
No, man. What I'm saying, you take profit, and then when it dips again, you buy in, and you're gonna double your money, man. You know what I mean? It's like shit. I took profit so that at least I evened out. Like all the money that I ever have put into crypto, I got it all back. You know, now I'm fucking, what do you call it? And just all the crypto that I have is pretty much free. Hello? You know?
Yeah,
and I'm buying more in.
I know.
Right?
I used to do that. I used to do it for a living. Me and you guys probably know him, AV. I think his name is Miggy. To some of you. We used to do this for a living, man. And now I'm burnt out on it. I have a big bag. I'm just going to sit on it until it's time to retire. And if it's never time to retire, then I'll just be fine thinking it was a fun thing to do.
Yeah, but I'm saying, like, when you see peaks, you know, when you see a top, everybody takes profits. So you might as well do it because it's going to dip right after. You know, it's only the most logical thing to do. People that don't take the profits off the tops, they're losing out.
I know.
You don't have to. You don't have to take all of it out, bro. You just take a good chunk that, like maybe fucking 25%, 50%, cover your losses and get some extra on top, and then you're riding free. Free fucking ride.
I realize that. Yeah. I think that it's fun to watch. It's fun to watch.
Well, yeah, no, I mean, I bought Solana at fucking like, what is it, $12 to $20? That's when I started buying Sol. I started buying XRP when it was like fucking really low. That's what I'm saying. I got a lot of fucking free rides. You know what I'm saying right now, I'm riding for free on a lot of fucking coins. It's great. It's amazing. Life's easy, It's easy street. Plus, I work on top of the fucking all that shit. The easy job too, just fucking free food and fucking just chilling at work all day having fun. It's great. Oh, friends, I think I see coyotes.
I think it's
Holy
fun.
Shit. Yo, oh man, I can't turn on the camera, man. I have wild coyotes right in front of me. This is great.
Just make one of your a pet.
Yeah, I need a fucking shotgun. I'll shoot that motherfucker right in the head.
Oh no,
fucking coyotes. No, these fuckers. I have a hot dog at home, and these motherfucker one time almost fucking snatched my hot dog off my lap. I'm sitting there in the park, my baby doggy's sleeping on my lap, and I see this fucking coyote straight up fucking prowling, like stalking up on me. I'm like, holy shit. And I started throwing rocks at it and shit. We have to fucking kill that fucking thing. No, because they snatch up little puppies and eat them. Fucking coyotes.
Where?
In Canada, bro. In the city, on top of that. Yeah, man, in fucking Toronto, they have wild coyotes. Fucking
Canada.
crazy. Yeah.
Give your
Canada.
balls a tug. Canada's awesome. Give your balls a tug.
Oh, man, Canada sucks, bro. Too much fucking communism in this motherfucker. And they didn't want to take more of my taxes. Shit, it's not enough. It ain't enough, bro. They want to take more.
The big coyotes or little coyotes up there?
I mean, they look like fucking baby wolves.
Alright, so
A
you
nice
got
German Shepherd size. Yeah, two of them. Just hey, what's funny is I saw a skunk fucking about to spray them. They ran away. It's funny. A skunk in the middle of the field. They were prowling at it, and it fucking started like rose its tail, and they fucked off. That's funny. But yeah,
Where in Canada are you from?
I'm in Toronto, bro. In Toronto. Right on the Great Lakes. Man, I should show you guys my view right now. I'm right on the lake, you know? And I can see across 30 miles of nice flatness. Oh, I love this fucking view.
That's awesome.
Wait a minute. You're saying you could actually be on topic?
Oh, yeah. I can sometimes. If you need me to be. I mean, who's a glober here? Fuck me, man. If you want me to do globe destroy, I'll fucking, I'm like the final boss of flat Earth, my friend.
Dude, take a photo of your thing and post it, man.
I have plenty of photos, man.
And then after that, take a picture of the lake.
Friends, it's too cold to take out my phone right now. It's too cold to open up my phone. I'm already walking. But I have so many videos on phone. Bro, I have so many videos and pictures of this fucking, the clearest days where I can see, where I put my camera right on the fucking, on the shore where the water's touching my fucking phone. And I can still see the lights across.
Oh, I used to have an aluminum phone case. And in the middle of winter, that was a bad idea.
Oh, yeah?
Oh, holy crap, that takes to chill right into your fingers.
I can imagine.
Take a picture of your lake and post it and say that.
Okay, here, friends. Watch this. I'm in this wicked spot right now. I'm going to take a picture right now, friends, for you guys. You guys are going to like this one. Maybe I get a night view. Maybe panoramic. Oh, yeah.
You don't want a picture of D's nuts?
Don't worry, these nuts are not going to be in the picture. Can I get night mode in here? 50 megapixels, sure. Yo, no way.
What's up? You see too far? Do you?
No. It's there's a little obstruction of light that might fuck this up. But okay, here it is. And what's the live stream voice text? Live stream voice text, friends. This is the current view I'm walking by. Look how, and see that light in the distance on the right side, but past the actual light in front of me, those clouds that are lit up, that's another city across the lake. That's like the ambient light from the city that's going upwards.
If I was to say that we see too far, does that prove? That doesn't necessarily prove the flat Earth, but it does disprove the glober, right? Or am I way off?
Well, I mean, if it ain't curving, then what is it?
Well, I mean, they tell us where it should curve. They tell us where it should curve.
Right.
But if I was to say that it's not curving where you say it's curving. That doesn't
But then
necessarily.
the ball would be bigger though. That's at that point, right? And then all the geography and all the maps would be fucking off, right?
Yeah, that's
'Cause
what
you
I'm
and I
saying.
can both, you and I can both get into a car, set our odometer to 0, and have an approximate distance across a landmass. You know what I mean? We can drive, and we'll have an approximate distance, give or take fucking 15%. I don't give a fuck. You can have a 15% tolerance with this shit. You know? Don't care. It's still good enough to disprove the globe.
Right, I know. The globe. It's been disproven. I'm sick of the globe.
Sure. Then what is it if it ain't a globe?
Well, we don't know. I mean, we know how far we can measure. We can measure a flat Earth. We do measure flat everywhere.
Right.
But
what is it?
We don't know. We don't have the capabilities to measure the whole entire thing.
Well, I mean, we have the ability to see far enough to know that it ain't fucking curving, right?
Right. We have the ability to know that it's not a globe. Right. We do disprove the globe every day, right? Every day.
So if it's not curving, then what is it?
Well, yeah, no. I would say it's flat. I would
right.
always say it's flat.
I mean, it is a dichotomy at this point. It can't be a fucking trichotomy.
Well,
Give me a third option.
It's just like proving that the ones who told us that it was a globe, that's actually not true. So we've proven that. We've come to the conclusion that you guys have been lying to us. But what is it? I mean, it's flat for sure. We can measure it flat, but that's about all the further we can go, right?
Well, I mean, okay. So let's say infrared photography that can show you like fucking long distances over thousands of miles, right? If you're in a high altitude plane, the horizon's still flat, where that horizon should be fucking doing some weird shit from that altitude, but it's not. It's just always rising eye level, right? Almost eye level, depending on the atmospheric conditions, whatever. You know what I mean?
Yeah, I did. I can get on board with that.
Right. So we can approximate like a lot of things. You know, with a certain degree of error, we can still assume, right? It ain't curving at that point either. Because if it was curving at that point, it would be very obvious. It'd be very fucking obvious at that point, especially if you were really high up there. So even though they say, "Oh, it shouldn't be curving," but we see the curve while we're on the fucking beach as the boat is going over the fucking horizon, bottom first, right? So if they say that that's a possibility, right? Then it should then raising elevation should fucking exponentially fucking show that curvature the higher you go, right?
Very good. Yeah, no, that's
straight up another coyote, my friends. Yo, man, am I gonna get hunted by coyotes? This is crazy. I gotta pick up a stick now. Fuck me.
Are they big enough?
Motherfucker.
Are those coyotes big enough to kill you, or are they?
I don't know. Maybe
you kick them in the head, right?
Friend, I'm 6'5". I'll fucking rape this coyote.
Right on. That was the question. I don't know.
Yeah, don't worry. These coyotes are afraid of me more than I'm afraid of them.
The coyotes
here,
down
watch.
here the coyotes in
You're not
America they're a little smaller than your coyotes. So, I mean, I'd just kick them in the face.
Oh shit! What a shit photo. Can I get a nicer photo? Shit! Night mode friends. Night mode friends. Oh, it's moving. It's on the prowl.
I just wanted to say to everybody in the room, I've learned a lot from you guys, like way more than you know, and you guys articulate everything so nice.
Yeah, we're sorry to hear that.
It's made me such a great flat earther.
Well, you're welcome, buddy.
Yeah,
Here, friends, watch this. Friends, watch this. This is crazy. Look at this fucking. This is a shit photo just now. But, man, I pressed the wrong button. Come on, don't do this to me now. Shit. Okay, here. Bam, bam. Okay. 3 photos. Look at these shits. Right in front of me, motherfucker.
You walking around with hot dogs or something?
Sheesh. Somebody called a coyote police.
I just hope it doesn't come from the back of me and grab my leg, because I'm gonna really fuck it up. I'm gonna fucking rip its head off. Grab it by its tail and fucking. No, I'm gonna grab by its tail and fucking smash its head in the ground. That's what I'm gonna fucking do. There ain't no kicking. I'm gonna make sure it dies. I'm not a fan of coyotes, like I expressed myself. These fuckers hunt down baby doggies, and I have a baby doggy and almost got fucking snatched. I hate coyotes now. Fucking wild shits. And the thing is the city of Toronto ain't doing shit about it. It's like, bro, relocate the fuckers. Grab the whole herd and fucking relocate them. Or fucking assassinate them all. No, they'll go to a fucking farm full of ostriches, kill them, fucking shoot them, and fucking let the ostriches watch the deaths of the other ostriches, so it's like a whole fucking chaotic catastrophe. But no, let's not fucking touch the coyotes. Motherfuckers.
What?
You didn't know? You guys didn't hear that shit? They went into an ostrich farm just because they pretended there's an avian flu and decided, oh, we got to kill all the fucking ostriches, and they fucking shot them all.
Yeah, I did hear that. I did hear that.
Fucking crazy, bro. Crazy.
They have to do that. Keep the propaganda going.
Right, to keep the propaganda going. I know. Cocksuckers, bro.
Something we can't do anything about, you know. We can yell about it. We do yell about it. But I mean, the Earth is still flat. I mean, or it's not a globe, at least.
It's fucking avian flu. Okay, what the fuck? Okay, so if there's an avian flu, so let the birds die off on their own naturally. Let's just do that. You know, why not just let these fucking birds, if they're gonna die eventually, let them fucking die. Why are you killing all of them? Huh?
Flatter, dude.
Hey, what's up, Jizzbo? Nobody knows your old name, man. Only a few.
Y'all remember me.
Yeah, I remember.
I heard you.
I was driving. I heard
happened.
This was my first name ever on social media. My first like official handle where I didn't use my real name, and it was always Sheepdog, but it was like different variations of Sheepdog. And then after I got my account back on Twitter, I was like, you know what? I'm just going to be a legend.
Just do it. Love it. Anyway, Speculation Sunday, man. I think we started it. You and I, baby.
We did.
Let's do it.
We did.
That was
it's a good break from the monotony, and then when there's low traffic or whatever, it's cool to have a little bit of stuff.
Sunday's good for that, you know.
But it's just speculation. It's not like it's actually what's really going on because you can't prove any of it.
Exactly. It's like I heard Australia tried to launch a rocket into space and it failed. Is that speculation? I don't know. That's what I heard. Anyway,
that's funny.
That was yesterday. I heard that.
Hey, did you see what just happened in politics? In the politics server? Donald Trump tweeted out that this server is the #1 server on Discord. You wouldn't by any chance happen to know what the #1 room is in the server, do you?
I could guess.
Oh my god.
I could guess. Can I speculate? Can I speculate on that and answer that?
It's not us. Out and split ourselves up a bit. There's other servers, and I mean, you can't be #1 for fucking ever. We had like a year, and the main VC should be the main attraction of the politics server. We overtook them for well over a year, so I mean, it's good. It's all good.
We're just guests here, man, riding on their
exactly.
coattails.
I know. Like, why are we the dominant thing in their play? Yeah, I know.
I appreciate them letting us in here. It's been great.
Exactly.
Yeah.
We'll probably get up there again, but right now, yeah, it's there's other topics that people are more focused on.
It's summertime. A lot of people are outside. They're roaming around. They're doing things. Back in the winter, we'll probably be #1 again.
Yeah, we're 2 right now. This is the worst we ever do. Is 2. So
That's not bad. I'll take it.
Even Rocky lost the fight.
What was that rocket launch? What? I didn't hear it. Okay. So yeah, you guys.
Hey, there's a southern part of the world too, you know.
Oh, I heard you failed your rocket launch upside down. It's because you're upside down.
Sorry about that.
Are you sad?
Yeah, I was hoping, you know, one day I might get in one of those things.
I was hoping. You got to hope harder next time, man. You got to hope harder. All right. Anybody think they're living on a stationary plane, not shooting through outer space, millions of miles an hour?
Yes, we are not.
Okay. I appreciate the confirmation. Checking out. Just doing a little survey. Just checking.
That's fascinating, Claire. You said the numbers will go back up during the wintertime, right?
Yeah, numbers always go up in the wintertime because people are locked in. It's freezing cold. They don't want to go outside.
Yeah, that makes sense.
It happens all the time. Every year. I've watched it year after year. Like the numbers go through the roof during like January, February. It's like, where all these people come from? Oh, shit.
Catch me later with that. This year I'm going tropical for the weather.
There is a damn south.
Heretic's going to go south. That sounds good.
Yeah, that's it. I've had it.
Why are you attributing all this traffic to the northern regions? Oh, yeah, it's when they're outside. That's when Discord goes quiet, right? Forget about us in the south, right?
Hey, there's like 10% of you. You're a minority.
I think Canada and Australia are the same place.
But you got Africa and South America.
Did you guys catch Bong in here the other night? Was he in?
Bong was in here? Mr. Bruce Lee?
Dude.
It was a big hit.
That guy's a legend, OG, man. Anyway, it's good to hear his voice. It's like, damn. He brought up a good point, man. He goes like, do you think that God created this place to make it a big giant illusion? Like big curvature, and there's no curvature, but it really does curve, and then the motion, and God really just wanted to play a big trick on everybody. Say it's nothing like you feel or sense or see. It's nothing like that. It's totally opposite of that.
Indio said that. That was what Indio said. If Bong said it, he was just copying what Indio's been saying for a few weeks now.
Indio might have said
it was.
I kind of feel like that's a version of the same sort of thing they do, though, where they place their faith in governments and institutions. Like, would they lie? I kind of feel like it's that. I don't know. I mean, maybe that sounds like sacrilege, but I don't know who made this place.
What if God is the trick?
The whole place is a big, giant magic trick, to fool you on where you think you live. I mean,
listen. Enlighten me.
Can you tell us the experiment to determine the cause? I don't want a story. I want an experiment.
I don't care what you want.
Science is empirical, right? So no matter what you say your explanation is, ultimately you're going to have some experiment to back it up.
Yeah, gravity is a field.
Oh, Jesus Christ. Fields are abstractions. They don't exist in nature.
Only stupid people would say that.
Oh, okay, you can put him back on mute. You're just going to say
you're
intelligent. Yeah, I'm coward because, only stupid people. I'm afraid of you insulting me. Oh my God.
Well, that was quick. Don't mute him, guys.
Now remember, this guy teaches children and allegedly has a PhD in physics. And that's his response. Gravity is a field. I say fields are abstractions. I asked for an experiment. Fields are not experiments. Fields are abstractions. There's no doubt about it. 100%. They don't exist in nature. There's no little bunch of little points and vectors and things floating around in the world. They don't exist in nature.
Can we unmute Professor Phil? Because I want to listen.
Why?
What he's
You're just going to insult us. Why would we do that?
It's okay. It's okay. Like I want to listen to his opinion.
It's okay for him to insult us? I don't think so.
Hey, he might explain, but if gravity isn't real and
no one said that.
Theory, then we can easily debunk him. And
no one said that. No one said if gravity isn't real. No one said that.
It isn't real. What are you talking about?
Okay. Nobody said gravity isn't real.
Gravity doesn't exist. What is it? Like
what is well, tell us what
a dumb concept is this?
Okay. So things fall.
Gravity has come through Hollywood.
Gravity? Okay. What is gravity? What is it? Tell me what it is.
From what I know, mass pull other mass. Like what? A magnet pull other magnet. It makes sense. Like,
no, we don't want a magnet. We don't want a magnet. We want what's gravity, dude? You can't define something by describing something else.
Okay.
That's an analogy.
So gravity is a force. Okay, gravity is a force that attracts that occurs in two bodies. And if we have body A and we have body B. Also, so body A will attract body A will. What? Body A will try to apply a force on body B, and body will try to apply a force on body A. So this is only the gravity. Earth core exert gravity on us. The Earth's core.
That's the scale.
How do I? You don't want to listen. Some points.
No, you don't even got your own rhetoric correct. But we're okay. So fine. Body A attracts body B, and that's
our Earth core. He's writing, use more caps lock and gravity will be proven.
Okay, just so we can have a laugh, Indio, we read down side chat. Instead of making claims, ask questions. And then you scroll down a bit further, gravity is a field. From the same person. Instead of making claims, ask questions, Professor Filtard.
Obviously, it doesn't make sense, but I'm still interested on how gravity, not gravity, but how things come to the ground, like how things.
That's the problem. They don't know why down. Unknown. Scientists don't know it. Professor Phil doesn't know it. Even though he'll make all these wild claims, he will have no scientific experiment to back his claims.
Yeah, so this is the problem.
Have you studied your school basic formulas? Like, do you know gravity formula?
Yeah. Formula isn't it? Look, you can go all day long and play jump rope in your head. Ultimately, science is determined by experiments, right? Right?
Oh man.
Is that correct? No matter what my theory is, I have to do the experiment, right?
Okay.
Is that correct? Is that correct?
Do you know the experiment of a ship that travels through sea?
Dude, don't ask me a question. I asked you a question. Please answer. If I have a theory,
do you know the experiment of a ship? Okay, give me your theory.
If I have a theory or a hypothesis or some claim, to call it science, you have to do the experiment to confirm it, right?
Okay. So have you done your experiment on your flat Earth? Yes, it is. Yes.
Jesus. Okay. So science is empirical. So things fall because two things are attracted to each other. Okay. What experiment shows that?
What experiment shows that your Earth is flat?
Why are you asking me a question?
Because you're asking me a question.
You know it's.
I can prove it. But...
And it's rude to answer a question with a question. That's rude. You're being rude.
Okay.
Say I don't know, or I can't answer, or you could do what Phil did. Only a stupid person would say that. You'd say that.
If you don't know the answer, you are allowed to say, I don't know. We are not going to judge you for not knowing something. At some stage, every person
I know the answer, man. I know the answer. Like, we have moon, we have our gravitational pull. Moon is around Earth. Earth is revolving around the sun. How you can
How does that determine? Like, you don't observe the Earth revolve around the sun, and you don't observe the Earth or the moon pull the Earth.
So you have also
you don't
not observed the Earth is flat.
Oh yeah, you can.
Okay, explain me how you have seen your Earth is
flat. Go to the ocean. Go to the ocean.
Oh fuck, man! Have you ever?
Get in a balloon.
Okay, wait. I'm gonna send you a video, and everyone will watch this. Okay, wait.
Okay, back to my question. Don't we have any theory for like?
I'm detecting a fundamental attribution error.
Wait. I'm asking the question. So we flat earthers don't have a theory for like what causes everything to come to the ground. Is it like? Well,
I don't know if your mic is bad, but I can barely understand you.
Okay.
Your mic is very. You're talking very softly, and like your mic is kind of like.
India, just so you know, the one that's underneath you, Kafir and Kushagra, have been talking between themselves. So one of them's trying to talk the other one because his Indian's better than his English.
Oh, okay. That's fine.
Okay. Send you a link.
I didn't even come in here to talk. I came in here to listen, man. But you guys are like
India,
a train wreck.
India, we should have a look at this train wreck in the side chat. There are numerous experiments that show mass attracts mass. I thought gravity was a field.
Hello.
I'm just going to jump between answers because I don't know myself. Well done, Professor Phil. Well done.
My God. Man. I think you're going senile, Phil. You're worse. How do you get worse at this?
hey, wait. Isn't force and field are related? Not exactly the same, but related. In electromagnetism, we do understand learn about the field and force and how do they work with each other. So,
hello, guys.
I mean, according to him,
are you trying to sell me something?
What are you guys talking about?
I think they're having their own side chat.
Yeah, we might need to move on if this is what it's going to be. It's like listening to nails on a chalkboard.
You guys believe in the Antarctica? Do you guys think it's exists?
What does that mean?
The continent.
Does it exist?
Yeah.
As a continent? I don't know.
Do you think it exists as a place?
Yeah, there's a place on Earth that people go to that they call Antarctica. You get in a plane, they go, we're going to Antarctica. And you're like, okay. And they land on some ice, and you're like, this is Antarctica.
Okay, why does the sun appear 24/7?
Who cares?
Just answer me.
How would I know why? Why would I know what causes the sun to do anything? How would I know that?
There's a documentary about it, which is live 24/7.
Yeah, and
And the sun is appearing. It's still appearing 24/7. So to
and
the land, to the
yeah,
floors,
and
it doesn't matter,
okay,
right?
okay. So we see the sun 24/7, and
It debunks everything you guys believe in.
Hang on, no, it doesn't.
How so? Can you tell us how so?
Because if the sun is moving all around the world, how the sun is still exists in the Antarctica and appear 24/7?
Okay. If the sun is moving all around the world, how does the sun still exist 24/7 in Antarctica? How does that disprove or disprove anything? So your question is not a statement.
No, it's actually.
You said it debunks flat Earth. I asked how, and then you asked the question.
So you're just jumping over my question.
No, I asked you how, and you asked the question. It's not telling me how. You're asking for a question.
How what?
Do you not understand your own statements? You asked me how does the sun do X? Well, so I asked you how does it debunk the flat Earth?
Global to me.
You didn't explain anything. You asked a question.
I said if the Earth is global and there is a place called Antarctica and there is a sun which appears 24/7, then it makes it global, not a flirt Earth.
It makes it global. Yeah. How does it make it global?
Because it circulates around the sun.
I thought the Earth is spinning. What happened to that?
Now let's not jump over this discussion. Let's talk about why the sun appears in Antarctica. Can you explain to me why it appears in Antarctica 24/7?
I can make up any explanation. Any other
go
ones?
Ahead. Tell me anything, bro.
Okay, I'll tell you something. Hey, Canna, if the Earth is flat, if the Earth is flat, can the sun set? Yes or no?
Yes, it is. But it cannot set in one area and not other areas. So if the sun set, let's say.
So how can it? Hold on. How can it set on a flat surface? How can it set on a flat surface? If it's flat, can the sun set? Yes or no?
No, it can't.
Excellent. So the sun can't set on a flat surface. That's
I don't think he understands what you just did to him.
What I'm just about to do to
him. Bro, the sun set every single time. What are you talking about? It's set every day.
You just said a second ago the sun can't set on a flat surface. If that's true, they witnessed the sun not setting. Ergo, flat surface.
Honk honk.
What?
لا لا ما زال متوضيناش إذا كنا متوضيناش.
Why? Okay, then why it doesn't set?
هو كان متوضى كده.
He can't decide if he wants the sun setting or not. He's kind of caught between a rock and a hard place right now.
Okay, if you guys believe in the flat Earth, why the sun does not set in Antarctica? Just give
we
me
don't
a slight
care.
answer.
Canna, listen carefully. We are 24/7 flat Earth, not 24/7 sun staring. Okay? The ground is measured with no curvature, so we don't really care, or I don't really care.
Oh yeah, you
what
don't
the
care
sun
about
does.
Antarctica. You don't believe
We don't. Canna, it doesn't prove the shape of the ground. The sun could do a figure eight, a double loop, or it could even spin backwards. It doesn't prove the shape of the ground. For some reason, you seem to believe it does. I don't know why. Doesn't worry me.
Then why it's set?
The ground,
why it's set in your country?
The ground
why it's set
is
in your
still
country and doesn't set in
measured
Antarctica?
flat. So your questions of why sun does something, not relevant.
If the sun, if the Earth,
not relevant,
all of it flat, it's
not relevant.
Fully relevant. It is.
No, it's not.
Relevant.
I just explained to you the sun is not the ground. You seem to believe that the sun. Let's Canna, just hold up a second. For some reason in your mind, you thinking sun does something, therefore round. This is not true. The sun could do lots of things. The sun does not cause the shape of the ground.
Sun also can cook a very great cake.
That's complete of bullshit, bro. The reason why it cannot be flat because the sun must.
It's measured flat. We've already covered that.
Okay, no, it doesn't matter. You didn't measure it, by the way. Let's say the
anything.
Let's say the Earth is flat, right? If the Earth is flat, the sun has to move from a city to a different city to all over the Earth, right? It has to be because you can't have one.
What's wrong with that?
Light and the other country would not light.
So let me get this straight. You've got a problem with the sun moving.
Do you agree with me, yes or no?
You've got a problem with the sun moving. It was lunchtime today at 12 o'clock, lunchtime today. It was sunny, believe it or not. And guess what? It's dark now.
Right?
So the sun has moved.
Yeah, so it's moving. The sun is moving, not the Earth is moving, right? Do you understand it?
Correct. I don't feel the Earth moving, dude.
Yeah,
we don't feel the Earth move.
Exactly. The sun is moving around the Earth.
Now
right?
you get it.
Oh,
you got it, dude. Welcome to the
flat Earth.
Why is it always appear in the Antarctica? Why is it always appear in Antarctica?
Have you been to Antarctica?
Yeah, why does it appear 24/7?
Have you been to Antarctica to validate this?
No, I haven't.
Yes or no?
I have.
Excellent. So how do you know? You haven't measured it.
Live stream. I have seen live stream.
Kenna, you made the claim. Kenna,
I have seen a live stream. I don't have to go.
How do you know?
No, you have not.
Have you been there?
Kenna, how do you know it?
I have seen a live stream.
You are lying. There are no.
You've also seen Santa Claus, Bigfoot.
Whatever we say will never be a proof, and whatever they say will everything will make sense.
What is this audio chaos?
Okay, real simple. Canner, there's never been a live stream of the 24-hour sun. There's a video of it, but there's not a live stream. You made that up. Okay? The people that went there said they were going to live stream it, but they didn't have the bandwidth to live stream it. So please stop lying and making shit up. Okay? Thank you.
Yeah, you guys mute me for that, right?
Mute you for lying? Yes. You're lucky we don't kick you out.
I'm not lying. There is a live stream, bro. You can
post the live.
watch it by yourself.
Post it. Post the 24-hour sun live stream right now.
You muted me in chat as well. I'm muted both in chat and
DM it.
Stream,
DM it then. DM it then.
Okay, I'm gonna DM it.
Yeah, my DMs are open. DM the live stream link right now.
Indio's DMs are open. I complain about crazy Globers all the time in his DMs.
Doesn't mean I'm going to answer you.
Nope.
So you're denying that there's a trip 24/7?
No, I'm not. I don't have to deny it. I'm waiting for the evidence.
What do you mean deny? If you believe in something,
you've got to prove it.
You gotta be certain. Yes or no? You got to be certain.
Stop talking.
You haven't presented anything to deny.
Exactly.
You have not presented anything.
Kenna, we don't have to. You're the one making claim of 24-hour sun. You prove it.
I have to prove it. You gotta prove it by yourself. You gotta go there and see it by yourself.
I haven't mentioned it. It's not my burden.
Is that what you did?
You're
then
the
why
one.
Why not go there and why not?
Why not you go there?
I'm certain it is. Why do I have to go there?
Why have to go there?
Because there was a live stream.
It wasn't live.
So how do you know it was live stream?
Because I watched it.
Because you watched it. So let me get this straight. If I get right now and put a movie on, is that live stream, even though the movie's 10-year-old?
It's a live stream because...
How do you know it's live stream? That's what I'm trying to get from you.
When I watch the live stream...
Canna, stop talking. Please stop for a second.
Let me answer.
I don't want to hear it. Just stop for a second, please. You keep telling us... I haven't finished. Please just wait. Right, you keep telling us it's live stream because you watched it. So that doesn't prove that something's live stream. And I'll give you an example. On the YouTube.
But it doesn't stop you.
Why are you talking? Please.
Okay.
On the YouTube, they tell us live stream for ISS footage. How do you know it's live stream? How do you know it's not pre-recorded and then put there for your pleasure? How can you tell the difference between something that's actually happening right now and something that's pre-recorded? How can you tell the difference?
Because I watch it my own eyes. I saw.
Oh my fucking Godfather!
Air. I watch it.
No,
Okay.
You.
If you watched a pre-recorded film, how can you tell difference? Canna, two choices. One, live stream. Two, pre-recorded. You now watch them. How do you tell difference?
Yeah, Canner, what you're talking about, Dave, look, Dave McKeegan's premiere video of a recording. So a premiere on YouTube is a live stream of a recording.
It's a live stream, yeah.
Of a recording.
What are you talking about?
You don't know how YouTube works for YouTube Premiere? You know how
It's
YouTube
live
Premiere
stream
works?
full of freaking. Okay, you want to see it? You want to see the live stream?
It's like watching a VHS tape.
Look at that, bro.
Hello.
Look,
Bro,
I
even
could, right now, I could take a cartoon.
Four
I could
flat
take Bugs
earthers
Bunny.
went there, and they said it's not like it's not fucking the sun appears
So
24
so
hours.
that's awesome, Canner. Want to know what the person that set the whole thing up, the Glober, said? He said nothing. The sun
So you're
doesn't prove
denying
the
it.
shape of the
You're
earth.
denying it then.
Why are you interrupting me again? Will Duffy, the guy that
You
set
never
that
gave
up.
me the chance to talk.
Why are you interrupting me again? You're gonna be fucking muted. You do it one more time.
I don't care.
Yeah. So really simply, Will Duffy, the guy that set that up, said the sun doesn't prove the
that
shape
up.
of the earth. So you have to interrupt me again, right when I say that. 3 times now. Will Duffy, the guy that set that up, said the sun doesn't prove the shape of the earth. The guy that went there, who set up the whole thing.
Said what?
He said,
Mhm.
why are we talking about the sun? It doesn't prove anything about the shape of the earth.
It does.
The guy that set up the whole... Oh, how?
Because it doesn't make sense if it's a flat earth. Right?
That's an argument from incredulity.
So you guys deny
I don't know how
that
it
there's
makes
a live
sense.
stream
So
in Antarctica, right?
Yeah,
I know
there wasn't.
Let's not change the
I
topic.
know there wasn't. I know there wasn't.
There wasn't a live stream. How do you know?
No, it wasn't a live stream. They Canner, for the last fucking time, they did not have the bandwidth to live stream. You know what bandwidth is?
Indio, my brother. Tell me one thing, okay?
It's still in YouTube. It's
How
still
the
in
fuck
YouTube,
moon
by the
and
way.
earth
The
It
live stream
wasn't a live stream from Antarctica. It was uploaded days later. Look at the date.
It wasn't.
Look at the date.
Bro, it's streamed.
Look at the date. What's the
How do
date
you
say?
know?
Look at the date. What's the
Look.
date say it was streamed?
Well, I'm checking.
Yeah, check.
Well, live stream at that moment, bro. It's not like it streams day before or something.
Indio, tell me how do you experience your weight if there's no gravitational pull? How do you experience the weight of an object that you hold on to?
There's a gravitational
How the
push.
moon and
Shut up,
how the
dude.
moon and Earth
It
works
was-
together
it was
if there is no
streamed-
gravitational pull at
It was
all.
streamed live on December 16th, 2024.
December 16th. What days were they there again?
Maybe December 15th.
So not live streamed.
It is live streamed. Let me tell you why it's a live stream.
So they live streamed it into time, forward into time?
No. I'll tell you why. They streamed after the midnight, and that day, that was after literally the day they were before. It was just after 3 hours when the day ended. So that was the live stream at midnight, because you thought that, oh, that was after they came back and whatever. No, it wasn't. They stood there for at least 4 days. So that makes it, that was a stream while they were there, bro. It wasn't, because it doesn't make sense, because there was a guy who was there having a phone with the chat, and he was looking on the screen. How that would make it fucking days after, bro? That doesn't make sense.
Okay. They did live stream from Antarctica, but they did not live stream the 24-hour sun. What don't you understand?
They have cameras with 24 photos. But it's I believe it's posted somewhere, but I can't.
You believe. No one cares what you believe. I know the facts. They even said it.
We
They didn't
also
lie.
don't care that you believe that Earth is flat.
So
That's not a belief, buddy.
You have the right. You have the right
You
to
have
say.
one choice. You have one choice to debunk all of this. What it was is go there by yourself and see the sun. But
yet you haven't been there to validate any of your claims.
Well, let me say thing. If the sun sets, then okay, I will just look down and I will say, okay, you have the right to say whatever you want.
So if the sun sets in Antarctica, it's not a globe. Is that what you're saying?
It would give you a beneficial doubt, yeah.
Yeah. So no matter what, it's still a globe, right? No matter what. No matter what we see, no matter what the sun does.
I'm saying if you're saying the live stream is not true, or if
let's just walk you through this your logic,
yourself and debunk it by yourself.
Yeah, why? It doesn't debunk anything. It doesn't prove anything one way or the other.
It does prove the Earth is globe. It does prove the Earth is globe.
How?
There are many other things that prove the Earth
I'm going to ask you again how. I'm going to ask you again how.
Because if the Earth is rotating over the sun, it makes it the one place which.
Okay, that has nothing to do with the Earth being a globe or not.
It does.
It could be rotating and not. Or look, bro. It could be a freaking. You interrupt me one more time. I swear to fucking God, dude. Shut your fucking pie hole. It doesn't make you right by talking over. Okay, so the Earth could be.
So he believes that God exists, but he don't believe that.
Dude, you freaking clowns, man. You started to get on my nerves. So, Canner, let's say the Earth is a freaking a minibus, and it's orbiting and rotating. It's orbiting and rotating.
Mm-hmm.
Okay. Would you still see a 24-hour sun from the rear bumper?
Earth is a minibus.
Can you talk again? I was not paying attention at all.
No, because your conclusion was if the Earth is rotating and orbiting, then it has to be a globe, and that's just nonsense. Could be anything.
Yeah, because I can prove that with a video. Can you actually let me
So you're just going on mute because you're not going to actually engage.
Indio, shout out to you, brother. Earth is a minibus. That was awesome.
It's a VW bus. Me and Dr. Phil are going to get in the back and smoke some weed.
Oh, so you can get high enough to see the curve.
It's flipping over left, right, and center. Which way is up? I don't know. And the moon keeps turning like wheels on a bus.
Okay, so what about the triggered Indian or whatever he is?
Bro.
He spoke up. He's like, oh, that must be me. I'm the one.
I'm the triggered one.
I'm the one. Oh, bro.
So funny.
At least they're tracking with the conversation.
I was going to say, Professor Phil looks like another guy that confuses the map for the territory. You know, he's invoking coordinate reference systems as proof of the territory.
Oh, sporadic. Have you ever played with Professor Phil?
Oh, yeah. Yeah, under different names in the past.
Ah, that's all right then. I was going to say, if you've never met him, oh wow, this.
Oh, when I was brand new, he sent me a CGI stage 2 deployment of a satellite computer render and told me it was real.
They are just morons, man. They don't understand anything. They just yap, and they just do some weed, and they just say that there is something bad.
So
they have no sense at all.
Weren't you asking how do I experience
I'm talking about Indio and.
Yo, Indio, set this guy on pressure. Ask him about pressure. I'm curious.
No, I want to get back to his gravity thing.
What you're asking?
I'm still waiting for the I'm still waiting for the experiment, dude. The experiment.
Like
Where's that?
whatever I'm giving the point, they say that your point is invalid, and they're just yapping something
Here's
that
what they say.
Doesn't really exist at all.
When you say doesn't exist, what are you talking about? See, this is just narrative spinning nonsense.
My logic is nothing to them, and
you don't know what logic is. You
something
couldn't
that
make a deductive syllogism if your life depended on it.
shove it in their ass.
Look, you're either hot mic or you're ignoring me. Kushiga. Yeah, he muted me. So he can go on mute.
Okay.
No, he was probably talking to someone else. His wife just railed him.
I disconnected him.
Oh.
Sometimes send these guys to different chat rooms when they're in the middle of spiraling. I probably shouldn't do that.
That'd be cool. That would be cool to like move them into like the vegan room while they're going freaking gravity.
Yeah, I've done that.
Why?
Because people talk when they shouldn't be and they rudely interrupt others. So if you're not a part of the conversation, it might be wise to press your mute button and mute yourself from talking, my friend.
I'm dying because Indio kicked someone out because the guy muted him. That was awesome. G status right there.
Yeah, the art to selecting the right room.
If you go over's ideas were so good, how come you resist any interrogation of them? You just absolutely resist it. We try to ask you questions about what you even mean, and you can't say what you even mean. You can't like form coherent statements about what you think is supposed to be some foregone conclusion. That's maybe something's wrong if that's the situation.
Kushagra, please mute yourself or someone will do it for you.
Dude, stop strangling that cat.
Someone's hot micing hard. Oh, look, Professor Phil, still waiting for any flat earther to explain how on any version of flat earth the distance along the equator between two longitudes is greater than the distance along any other latitude, both north and south of the equator between the same longitudes. Of course they can't. Oh,
I got this one. Listen, your so-called like measurements, what you think is an actual distance between these locations is just a calculated distance on the coordinate reference grid. So you need an actual measurement. And the way to do it is to step away from your circular reasoning. Don't use latitude and longitude to validate latitude and longitude. So try doing planar surveying, independent of any latitude and longitude coordinate grid. Try using a planar grid. Do actual measurements, and then compare the results. You might end up with papers like the one from the U.S. Naval Postgraduate School I have here on local tangent planes, local planar coordinate systems being more accurate than geodetic-based global coordinate systems. Right? So this isn't some crazy idea. Like for military precision, they're not screwing around with calculating distances on a spherical Earth. When they need precision, they go absolutely flat and planar. The reason is because it matches reality closer. Yeah, that's circular. Your GPS receiver, again, is going to be taking all that data from GPS signals and producing a coordinate references. Guess what? You can take your receiver and you can program any coordinate reference system you like. Flat, globe, tiny little moon, whatever the case you want, dinosaur nugget, and it's still going to work. Right? So if GPS was globe exclusive, Phil, how come they also claim that they use the same GPS network to do a lunar coordinate reference datum? Same signals, different receiver, different computations for an object that's presumably 1/5 the size of the globe. So it's not globe exclusive at all. Maybe you don't know what you're talking about. Yeah, it's not the same sphere as your globe sphere. It's different dimensions. So how come GPS, the same one, works on the freaking moon? It's because it's coordinate system independent. Sorry, Phil, that's the harsh reality of the world you live in. Coordinate systems are not reality. Yeah, go look up Lugre, L-U-G-R-E. Pretty hilarious. You know, and surveyors will also use differential GPS and a state plane coordinate grid, which is flat. And you even have differences among your own global coordinate reference grids, right? You got NAD 27, NAD 83, WGS 84, blah, 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 and on, and they're not all the same. Coordinate systems are arbitrary. Just pick one and use it consistently, and you won't have any issues. So yeah, guess what? I have no problem as a flat earther using GPS to drive my car around. Let's not even get into what ECEF is before your receiver translate that into Latin long, because that's planar.
Were you here when Phil said, pretty much said fields are not abstractions?
Yeah, I was just tuning in.
Freaking
wow,
unbelievable. I'll get one at Walmart.
It's a sphere of influence, man.
A sphere of influence.
Yeah, it's like saying vectors and rays and all this other stuff are absolutely real. Metric tensors are real, dude. Coordinate systems are real, dude. These guys have, like, reification bad.
They're a bunch of Neoplatonists.
Yeah, truth.
They think the shadows are people. They think the shadows of the wall are people. We'll try to talk to them. Buy them lunch.
You can use your GPS system to get your actual distance on Earth. How'd you verify that? How did you verify that? What makes you so sure that it's actual and not calculated?
Oh, I feel like busting into a song. I've been everywhere, man. Sorry.
I got $5 to ask you a question. No, I just got $5. Instead of answering your question, he's going to ask you a question.
Yeah, that's how it goes. Or he's going to go engage with somebody in text chat and ignore it. That's the second or third time I brought it up here, and he's just like sidestepping, just insisting that he's right. It's like yesterday, that guy, Josh Ingersoll, he goes by on here and posts his LinkedIn page everywhere. Says he said like last week he was a propulsion engineer. And then today he was something else. Or yesterday.
That's the one that doesn't like me.
Yeah, he posted a picture of Jupiter that he said was real.
Can you verify what he actually does, or
no? I mean,
so he could just be working in some institution. He could be working in some institution doing literally anything, sweeping the floor, mopping, cleaning the bathrooms.
He said it was something to do with, what was it, Amazon or one of those big delivery places, and his job was putting antennas or designing antennas so that they can send data from satellites from here and there.
So he said he's a satellite driver, okay? So I said, okay, great, you got access to Telum? He said, yeah, I do. I said, great. So is it raw Telum or is it processed? He said, well, I used two-line elements. So for those in the audience, that's basically Keplerian orbital elements that have been reduced to 2 lines in text, so it's easier to work with. And I'm like, okay. I said, I was trying to goad him. I'm like, that's actually derived from a model. And he said, LMAO, no, it's not derived from a model. And I'm like, yes, it absolutely is. KOE is a model, and it's built off of receivers. It's built off of ground stations that are doing azimuth and altitude tracking of satellites using radar and using optics. And they post their positions in spherical coordinates in latitude and longitude, as well as their observations of where they think the satellites are. And then they send this all to ground station processing. Ground station processing aggregates all the data and computes Keplerian orbital elements and spits them out and tells the satellites that's where they are. And then the satellites then beam that back down. That's absolutely model-based. And it's spherical-based. It's circular. They're stuck in this do loop of hell. I asked him a question about like how to deal with tumbling and stuff, and because I knew he didn't have access to raw Telum based off his response, and he goes into story mode, and he's like, yeah, so that satellites almost always tumble after deployment, and you don't know which way is down facing, and I'm like, okay, well, have you seen that data? Have you seen the Nadir vector getting all warbly barbly after deployment? And he just went on story mode, like talking as if somebody else he knows did it. He didn't have the actual experience. And then he started yawning, right? At some point in the conversation, just started yawning like incessantly and uncontrollably, like acting like he's too cool and acting all bored and stuff, and then flippantly evading questions and trying to obfuscate answers with obscurantism. And then he said, I'm going to go to Earth Awakenings. It's much more entertaining over there. I mean, and that was it. I'm like, man, that was disappointing. Like, I started off in a conversation with him in good faith. I'm like, hey, look, man, here's the issue. We have all these inertial guidance systems, navigation systems, from boats to trucks to airplanes and even satellites. And we're looking for this missing rotational vector. It should show up as some kind of gyroscopic deviation from a horizontal reference plane, whether in orbit or whether from, an airplane that does its pre-flight calibrations at the runway and takes off and starts flying around a globe. It's going to have to rotate so that the belly's always facing the ground of Earth, if Earth is a globe. I want to capture that angular momentum, that angular displacement. And I can't see that in any of the telemetry that we're getting from airplanes or any inertial navigation system from boats, trucks. So the next place to look is in satellites. Do you have access to this? Do you have something like public that you can show us? I'm not asking him to divulge anything. Well, I mean, he works for Amazon. So basically public satellite data, public Telum. Do you have something that you can show us, that missing rotational vector that could help establish that Earth even might be a globe here, because it's been freaking frustrating not being able to come across it. And then he's like, yeah, I got access to that. Basically, what he's got access to is a computer screen that calculates or that produces pre-calculated KOE on it. You know, so he doesn't have access to like the health and wellness of the satellite subsystems. That's probably proprietary, but whatever. I don't want anything that nobody's not allowed to give us. And if they can't give it to us, great. I mean, I'll move on. But I mean, there's so many public satellite systems out there. Like, why can't this be made available? And if it is, where is it? I mean, don't like news stations have their own satellites? Just, you know, send us a copy of some telling from that. Raw, let's see it. But every time we get like another satellite expert, they don't have the goods. I'm looking at you, Phil. Yeah, he's just chanting, GPS gives us accurate distances. Well, how do you know it's accurate? Like, what if I swapped out a lunar datum and didn't tell you? You're going to claim that it's accurate for the globe. Yeah, that's a funny part. Like, I could swap out the datum and not tell you, and I bet you dollars to dog nuts that you're not going to be able to tell the difference, and you're going to claim that it's accurate, and then the big reveal is, oh, well, guess what? I just swapped it out, revealing that it's arbitrary, and you have no way to assess its accuracy. You're just making baseless claims, and what gets me is you're teaching students all this stuff. Have some humility, professor. When you step in here, there are no sacred cows. Wait, that might be insensitive given the wide audience we have. Yes, there are sacred cows in your tradition, but not in mine. Do self-professed Satanists have sacred cows? He knows because he tested it. He took GPS and he took a map and he said GPS on this map confirms the map on that map. The map matches the map. Therefore, the map matches the Earth. Womp womp. You know, a lot of this technology hubris regarding GPS is a result of people believing that it's like an open source system when it's absolutely 100% not. The presentation layer is open source for the end user, yes. But the backhaul data, you're not seeing what's being uploaded to those satellites. Whatever and wherever they are, whatever technology it happens to be, you're not seeing the backhaul. No, sir, no way. Satellites themselves don't know where the F they are either. They don't. They don't know where they have to be told where they are by the ground. And then they just relay where they're told they are to everybody listening. Just gigantic beacons like repeaters. It's not as mysterious as people like to think. He measured his position on the ground. Oh, great. What was the margin of error? Like, you measure what, like maybe 300 feet from your front yard to backyard using ground-based differential GPS? Yeah, we know these games that are being played. Yeah, we know differential GPS uses ground emitters and doesn't use sky emitters from satellites. So if that's what you're using to localize and enrich your location data, then that's what you're using. You're not using satellites up in this outer space. DGPS, listen, like in the 2000s, there was a company actually called Skyhook, which was a nod to the old satellite retrieval operations that took place during the Cold War. And Skyhook was basically flying airplanes all over the world, geotagging emitters, whether they're radio stations or whether they're home Wi-Fi routers. And then they built this gigantic network, and then they delivered that to the public to use to enrich GPS systems. And so if you need like millimeter precision or whatever you're doing on like a construction site, you set up your little theodolite with differential GPS, and you're using locally based emitters to triangulate your position. And you can also display that in any coordinate system you want. You can actually extrapolate that out to a pretend globe, a pretend ice cream cone, or pretend dinosaur nugget coordinate system. Did I just glitch out?
No, you're good.
All right, it's all these bait and switch games, you know? And it's almost like they hope we don't catch them at it. It's almost perverse. It's almost like Dexter or something. Or it's like some voyeur, like some criminal that commits a crime and wants to see if the cops can figure out his god-awful mess and catch him. And so he lingers around the crime scene, even offering tips and snickering behind the scenes. That's what a lot of these Globies remind me of. And we catch them every single time. That's the fun part. It's easy. It's easy when you know what to look for. You know how. They've only got so many tricks in their little bag.
Bro. Why is everyone silent?
I was just rambling, dude, and I took a breath. Like, I've been rambling and monologuing for the past 5 minutes. I took a breath, and you pop in, you're like, why is everyone silent? Dude, come on. Why don't you go to our YouTube chat, our channel on YouTube, and rewind the tape? You can listen to me carrying on about GPS systems. "30 kilometers away, great. How did you get where you were when you set up your surveying network? Did you use latitude and longitude in the beginning? If so, womp womp, circular reasoning, Phil. Why don't you show us what you did?" So we can point out that you used pre-calculated distances via coordinate reference system, and you used the same coordinate reference scheme in GPS to self-confirm it. Isn't that how this works? Just circular logic? Loop-de-loop on this merry-go-round to hell? Yep, so show me the planar surveying independent of lat and long coordinates. Show me like a state plane coordinate survey, and let's see how that matches up to GPS. Maybe we can use the British National Grid System, a nice little 2,500 kilometer square distance with Great Britain smack dab in the middle. Does not line up with latitude and longitude at all. So you could use something like that to assist, and we can see how it works out. I've always wondered if you took something like that and just kept going with it, how you could actually use it to survey the Earth flat and what it would actually look like, or at least closer to actually what it would look like. It's not a ball. funny is like you Google like British National Grid System, they only show you a few of the grid squares. There are 25 of them that are all lettered A through Z, right? And they'll only show you like the ones immediately around on Great Britain. They won't show you like the corners and too many depictions, but it goes out a ways. Great. Gonna get going. I might be back in an hour, very likely. So if anybody cares, I'll be back yakking and yammering then. You set up a datum. Well, there's your first problem. You set up a datum. A datum is a model. Hello, model reification fallacy. So, I mean, it's great that you have all this math and physics background, Dr. Phil, but you don't really think about what you're doing philosophically. I mean, you should probably take some courses on the philosophy of mathematics and read up on what underdeterminism is. All the circular semiotic fails are just delicious appetizers for someone like me.
Oh, keep trying, Phil. Would you stop being a flat earther if I showed you data and proved that the GPS is accurate? Well, it still doesn't give you any curvature of the ground, so you can show us whatever GPS you like. You can even get the word GPS tattooed on your arm. Like, for all the good it's going to do. You need curvature first, Phil. The GPS proves the Earth is a globe and curved. So why is it, Phil, when we go out into the real world, instead of arguing with clowns like yourself on Discord, why is it we don't measure any curvature?
Oi. Oi. Todos.
Phil, you've repeated yourself 3 times now. You don't have to keep posting the same thing up. Nice one, Clippy. That's mad. Oh, nice well poisoned, Phil. Please try harder. So what you're saying is, Phil, nah, I've got nothing. Because I can assure you now, if you had actual, reliable, verifiable proof of curvature, you'd have come strutting into the channel in politics months and months ago. You'd have dropped it on the front desk like a bomb, and you would have sat back with grinning like an idiot. We know you've got nothing, you're just a pretender clown.
So, just in case, PSA, the missing curvature is still missing.
What is this?
I'm not sure who was here, but one day we were sort of getting inundated with that. Just this is all they would do. That's how bad their argument was.
Look at this. Phil's still trying to ask if he brings evidence, will it change our mind? Instead of just bringing evidence and changing our minds. Why do we have to get your permission first, Phil? Grow a set of furries, put your evidence on the table. Or maybe I should put it in my lingo. Shit or get off the pot.
Yeah, because there's a lineup for the pot. So, Muhammad, you're going to talk about a guy with Sticks and Shadows 2500 or whatever many years ago and disregard any other current knowledge or observations. That's interesting.
What's this bullshit? Why can't you be fair income and... Oh, that went through a bit quicker than I thought it was going to. See you, Phil. I agree. If I prove... Well, you haven't proven anything. That's your problem, Phil. You'll work it out. Anyways, enjoy your day. Well, ladies and gentlemen, since Phil's gone and he didn't put forward his evidence, and I was just patiently waiting for that, I'm going to have to go to bed myself. So, all you legends, have yourselves an awesome day, and I'll be around tomorrow to annoy some of yous. Peace, guys.
Cheers, Matrix.
Hello? Anyone here?
Welcome to the room. What say you?
What? Hello? Hello? That's Christian.
Sorry, I couldn't quite get that. You were sort of breaking up, crackling up a little bit.
He's having a conversation with somebody. You could wait your turn especially if you want to interject with some nonsense like that.
Yeah, that's not good. So that's how I know. We look for the curvature and measure the curvature from one point to the next point.
I have a little theory that I developed a couple years ago, and I should have kept better score, but as more and more time goes on, what I'm finding is that the most of these people are unable to get out. They're unable to leave their house. They are, challenged in some way. Whether it's physical mobility, whether it's a vision impairment, whether it's something that keeps them from actually being able to go out into the real world. So the way they entertain themselves is to more or less force us to entertain them, because they know that we don't like to mute and we don't like to kick people out. So we give them a very, very long leash, and they will sit around and abuse as much of that as possible because they're just sitting lonely in their house. They've got nobody else to talk to. They've been kicked out of the other kinds of rooms. And so when they leave here, they go to another room, then they go to another room, then they go to another room, and they barely even remember having been here before. So when they come back, they're talking about the same stuff over and over because they've literally gone 1,000,000 miles without having to back up their wheelchair.
Yeah, it's pretty crazy. I mean, like, you have the average Glober who comes in here is just like either trolling lightly or, generally trolling lightly. And so it's up to us to kind of disarm that. And once you get through that tough exterior, then you kind of generally get to a gooey bit, a nice conversation. And it's rare to get a nice conversation right off the bat, like, because they all come in with preconceived ideas. But we do get a disproportionately large number of people who just obsess, get like compulsive over this and us. Like, we personally offend them for existing. And that's just weird. They just keep making it weird.
Yeah. Here's kind of the way that I take it is when all you remember is your 7th or 8th grade astronomy lessons, and you didn't really go to college, and you had your teacher who might have had a master's degree, might have not had a master's degree, might have just very likely just had a bachelor degree in some sort of liberal arts education, then so they're teaching from the textbook. But then once you get out of that level and you get to high school level, and you get out of that level and you get to college level, I find that most of those people are quite up front when they're teaching that, well, this is to the best of our knowledge, this is what such and such theorized here, blah, blah, blah. And this is what our model shows. And that those who come around here are not going to be those type, because that type there that's educated into the subject and actually knows the subject is going to know for sure that we're right on when we start calling apart, okay, well, let's talk about how did you figure the distance to the sun. Well, let's pull out that study and let's read the limitations of that study and what else there could be. They're not going to waste their time on that. And then the true believers, that had their 6th, 7th grade astronomy lessons, oh, well, they did a radio bounce to Venus, and then they did some mathemagic, and bam, bip, bop, boop, here we are. And ultimately, the end of all of that translates to the what I like to refer to the Discord effect. The people who actually know the topic are not going to come here and actually discuss it with us. So therefore, we're left with the trolls and imbeciles.
Yeah, I think the problem also lies in a lot of us have a lot of self-education because we value education and love learning, and so a lot of us have watched like a bunch of physics lectures and different things, and even though we saw that in school, we watched it again to refresh, and you watch it from different people talking about it in different ways, and different teachers are better or worse at portraying the subject matter, understanding the subject matter, and giving the caveats that like this is as far as we know, and the further you go, the deeper you go into science, really, or like the farthest reaches of theoretical science, the more you know they don't know shit.
Yeah, and
I would like to say that,
oh, sorry.
I'll be super quick. Yeah, I would like to say that I've been to a few Glober RAN servers, and when I bring up the argument that it's gas pressure being high and low temperature holding down the oceans, the only thing they can do is ignore the law of cause and effect, which is the law of nature, or a law of logic as far as I'm concerned, and they appeal to math, and they describe it as gravity. So whenever I do that to them, I'm like, why are you in a category error? Why can't you stay focused? Don't you understand cause and effect? And they got nothing, absolutely nothing.
100% right, Hank. 100%.
That's just the way it is. Things will never be the same.
Yeah, and I think that's the problem is, sometimes when you pick your medium, you pick your message, and here it's all based upon those who are unable to actually get out and correspond with people in real life, and which is different than us because we go out, we do our own observations, we meet with each other, and we go to places shockingly like libraries and bookstores and other places, and so we're stuck with the other side who's on here for hour after hour after hour, day after day after day, obviously meaning that they stay stuck here for days at a time, and they're not actually getting out to the places, and so they're not actually learning. So all they can do is just kind of obfuscate and play shell games and just lose over and over, and then they do what I affectionately refer to as behavior earthing. Like the clown, I don't remember what his name was. It was on here this morning. He was getting angry because everybody's talking over him, but the truth was he was trying to moderate. He would freely interrupt everybody else, and then he would start yelling because somebody interrupted him, and like he just was too dumb to see that. Hey, look, this is the place, you're not a moderator, so maybe you'll have a more fruitful conversation if you realize you're the guest here and that this is a round table. So it's
Has anybody spoken to Kexage?
Say that again?
I was just making sure somebody made contact with some of the new people. Kexage. You new here, brother? Have you talked to anybody?
No, I'm completely new. I'm just looking into it.
Welcome aboard.
Okay.
Thank you.
Have you been in this particular channel before?
No, never. I'm completely new to this Discord channel.
Okay. Do you have any questions?
No, I just like to listen, it's rarely to meet other flat earthers,
Right. Are you a flat earther yourself?
Yes, I am.
Okay. Cool. Yeah, well, if you have any questions, don't be afraid to ask.
Yeah, it's a free debate here, right?
I mean, yeah, open mic, yeah.
Okay.
But yeah, what makes you think, or what's the best evidence, or the top 3 evidences that convinced you that the Earth is flat?
The curvature calculation. That gravity is a fraud. You know, it's. And yeah, religion. I mean, every religion believed in a flat Earth, and yeah, the NASA pictures, moon landing, all of that. It's retarded.
Okay, so you said first and foremost, you test the claim and there's no curvature. So did you actually go out and test it?
No.
Okay. And then religion is your second foundation for your belief. And the third foundation is the possibility of them counterfeiting images from space of the Earth as an object in space. Is that right?
Yeah. That there's no actual truth. Truth, yeah. Evidence.
No way to verify whether it's okay, your English is fine. If you need us to slow down, just ask us to slow down, but I can understand you good.
No, it's fine. Thank you. Keep on talking, I just want to listen.
So yeah, I would recommend that you get out there and take some observations and try to get some measurements and see if you can measure that curve, and I'm going to pass them out.
I don't think I can measure it.
You can, actually, but yeah, you don't need to pass the mic. I was just going to be like, hey, Olivia joined us, maybe we can talk to her, but then she jumped out.
Oh, you're not all flat earthers over here?
Oh, we are, but we like talking to Globers.
Oh, yeah.
But we can keep talking to you because you're new, and it's good.
What are your favorite truths about flat Earth?
My favorite truth?
Yeah.
It's basically logic, I would suppose. Like, flat Earth brought me to logic. Like, I didn't know any logic before flat Earth. I had, heard about logic and tiny bit exposed to it in school, but not enough to actually be able to identify logical fallacies or anything like that. So flat Earth kind of drew me to that as I was listening to the globe believers trying to argue for the globe. I was like, this doesn't sound right, and looked into logic, and other people called out fallacies, and I looked it up, and over time, it gives you so much being able to discern if someone's making a logical argument or not, because you don't have to just accept it because it sounds good or it feels good. You can be like, oh, that doesn't sound logical, because it isn't. And you can actually be right, instead of most people who use the term it doesn't sound logical, is because they don't feel like it doesn't feel like it fits with my thing. But that's not logic.
Right. Yeah, what got you into flat Earth in the first place? Because it's very against modern science and the things they teach in school.
Well, it's not against modern science at all. It's actually
general.
No, it's not against science at all. For me, it was 2014. I saw a video about flat Earth, and I thought, I'll have a laugh at this. And then I watched it, and I was like, this is difficult. He's making a bunch of points that are interesting, but I'm pretty sure I have my excuses for all of these things. And I was like, gravity, refraction, these things would probably solve this somehow. And then I went to my friends, because like I'm a kind of a jack of all trades. I love learning everything, so I study everything a little bit. But my friends went deeper into their fields, and so one of them is an astrophysicist, and another one is a robotic engineer. And so I got them to try to supply me with the evidences or the experiments for the globe, and then I was just playing devil's advocate, because I watched those videos from Eric Dubay, and I knew how he would, because I watched the video, I understood his argument and how he would like not accept unmeasured assumptions or anything like that. So I just called out assumption, asked enough questions, because unwittingly I was using the Socratic method, because I was like, I don't know enough, these are my experts. And so I got them to tell me, but because I was asking them both the same questions at the same time, they would give me different responses. And so I would like use their responses against each other and tell them like, well, the astrophysicist says this, and they got so mad at each other that they were calling each other retarded. And at that point, like, I was like, oh shit, my belief doesn't seem on very solid grounds. I can poke all these holes and I don't know shit. And then my experts are just fighting amongst themselves, and they haven't actually refuted anything I've said. And the more I looked into the supposed experiments, the more I realized, whoa, those aren't actually experiments. This is a logical fallacy. Well, this one is assuming all these things. Where did they measure that? And so I kept digging further and further and further. And the more you dig, the further you get, the less foundational it is. There's no connection really to reality, other than like back in the day, the flat earthers tried to prove the globe, but we proved them wrong. But you have now two opposing views, like one says he proved it, the other guy says he didn't prove it, and then everybody's forgot about it, and we're just assuming that the shadows on the ground with sticks prove the earth, with boats disappearing over the horizon. Well, we can make things disappear bottom up over flat surfaces. Sticks and shadows work with the flat earth or a globe earth, depending on how far away the sun is and how the light splays out from the sun. And we can show that the light splays out from the sun so that the shadows splay outwards from the object, like with trees, or for instance. And so we're seeing the light splaying outwards from that point source in the sky, but they're telling us it's all coming down parallel. But at the same time, it's also not coming down parallel to create the eclipses and all that shit. So they have so many internal contradictions that I couldn't just accept. So my belief just died. And at that point, I really, like 2015, start of 2015, I became a flat earther.
How old were you? I mean, it's a long time ago. It's about 10 years, huh?
Yeah, I think I was 30 years old.
Oh, okay. I'm 19, so I don't know. Am I young for a flat earther?
Not really. We skew a little bit older, but I've met 18, 17-year-old flat earthers. They are rarer, but I mean, it's cool. I mean, it's understandable because you just come out of schooling, you just been, like, according to, like, teachers admitting, like, they use brainwashing techniques, propaganda to teach the globe, for instance. Like, they don't provide the evidence for the claims. They just tell you, this is what you should believe. You gotta write this, otherwise you get failed. So it's a problem, but yeah.
If I could jump in just for a minute, I would say that, before you turn on the TV, before you put the mobile over the crib and you put all the programming in front of them with the media, like magazines and books, I would say that all children are flat earthers because nobody experiences the earth as an object floating in space. They all experience it.
AI always brings this up because they've done a study on this, and he can provide you with the study if you ask AI Ardent, where they tested young children and just to see their worldview before it got like influenced by the parents, and all of them were like, it's flat, stationary, because that's how we all experience it. So they need to be programmed by the Globers so super early to be able to hold this view and then conform everything into that picture.
Yeah, and if I remember correctly in this study, it's kind of funny that at a certain point in their life, they hold two worldviews at the same time. One of them is the globe Earth they see on the computer screen or on the TV or in the media, and the second one, what they experience outside. So this is dialetheism, and this doesn't really stop until, now this is me speaking after, okay, let me stop right there. After the holding the two views, so this is no longer the study, this is me talking. So this doesn't really stop until you lose the belief in the globe, because everybody knows we experience a flat stationary plane. It's a topographical plane, like I'm staring at a shitload of mountains right now, but it's a plane.
Yeah, I mean, I think it's the strongest argument, and I mean, you can debate with everybody. You can't really rationalize. If they don't want to change their opinion, they won't do it, you know? And just the fear of going outwards with your opinions away from the mainstream is like holding this globe model together, I think. I mean, I've destroyed like friends of mine in the flat earth debate, but they still won't change because they're like, yeah, science says, and they don't want to move away from this mainstream opinion.
Well, science doesn't delegate the outcomes of geometrical questions. So the shape of something is not a scientific question. And I don't know how, but somehow they've conflated the two to make you buy it, right? Like if you go type in flat earth on YouTube and try to find like a pro flat earth video, once you actually find one, like 99 videos later, you might find one. Go ahead and click on that video and then click on the Wikipedia, and it says that it's been scientifically disproven. So how do you scientifically prove the shape of something? That doesn't make any sense.
Yeah, I mean, it's less about the shape, it's more about the idea and the concept about it. God created us, we're the middle of the universe. And they don't get this. They really think it's only about the shape, that we're on the globe or... No,
yeah,
it's center.
Yeah, well, like, there's... all the ancient religions have flat earth as its basis, and so we don't promote any religion or use religious arguments here. We just destroy them with the science and the logic, and then they just keep running away. The prime example I would make you listen to is Heretic. I wish I had that recording. I need AI to give it to me if he recorded it, because I meant to record it, but then I need to talk to Helio. But either way, I need to find that recording because it's such a master class in how to deal with the Glober, and everyone just needs to hear it, especially new people, because the normal globe believer tactic is just to twist and turn instead of actually substantiating their belief system. And so they go on this defensive twist where they don't want to listen or don't want to hear what you're saying. And so it's hard to sometimes communicate this or not get sucked into the you need to prove everything bullshit. We are not the ones giving them a new cosmology. We're just the ones who prove that their cosmology is false. Have you ever gone to 24/7 Flat Earth Discord?
Who, me?
Yeah.
No, I'm completely new. I'm normally not into Discord and just came up with the idea and wanted to see what's up.
Yeah, I'd recommend somebody send him our server link, otherwise I'll dig it up. And that's our home server, and it has a bunch of channels on the side with like endless amounts of information and evidence and logic that you could use if you ever get into an argument. And then I really recommend just listening. We also have YouTube. We're on Rumble and YouTube generally. We have a lot of great speakers. I'm not the best one, but we have a lot of great ones, and yeah, I would just recommend listening in and hearing how the conversations goes, because when you're dealing with a unhinged sophist, you need to be able to defend yourself. You need to be able to know how to counteract the logical fallacies or keep it on point. So that, like, they make a claim, the Earth is curved. You can make an internal critique of that claim, asking how can you prove that? And then they keep going, and they want to go to something else. But you're in the internal critique of their claim. Don't let them run away from the claim. Break it down until they can't get anywhere, because they will paint themselves into a corner because they have no proof. The Earth is measured flat. It's experienced flat. That's how it's always been and always will be.
Yeah, of course. And I mean, most of the people, most of the globers, they don't even know their own model. It's funny to me. They stay there and defend it all day, but they don't know shit. Just education from school, but never actually looked for their own information.
Yeah, they have the cherry-picked information from school, but they've never actually looked and seen, are there any anomalies? Does this work perfectly? But no, they just believe it works perfectly, and then the anomalies are actually a big problem for the models. You need to account for those. And what they generally do is, with all the anomalies, they just make up new things to fit the holes, like dark matter and dark energy. Like now, our world's supposed to be like 98% undetectable? And that's nonsense.
They're called globetrotters for a reason, right?
Yeah, that's why we like the referring to them as GTs.
Can you cuss on the server? Like use swear words?
If you must.
Try not to. Just like, you don't know who's listening. There might be like family friendly. We got all kinds.
Yeah, I'm the worst.
Earlier you said something that I got to ask. You said the universe. Are you under the impression that space, outer space, that idea that is real?
No. No.
Oh, okay. All right.
I mean, it's not that I'm new to the flat Earth topic. It's just I'm new to the server and like-minded people.
Sure.
Yeah, I'm looking through the info about 1 year maybe. I watched. Do you guys know John Zerker? Watch a lot of him. Eric DeMay, of course.
Zerker,
yeah, Wits It Gets It. I like discuss.
Witsit came from our 24/7 server. However, he divorced kind of our empiricist basis, where he went off into his ether claims, and we don't make claims like that. We try to stay clear of that, because that way you have flawless defense when all you're claiming is verifiable things that anybody can go out and check, and it's like scientifically like obvious. And so we can provide citations, we can provide anything we want for all our arguments. Meanwhile, the Globers are stuck like fumbling and can't do anything. So, like, there are multiple camps of flat earthers. We're kind of like the empirical front-facing side, where we try to talk to like normal new people and have just a conversation and tell them about the evidence, whereas like there's other groups all over which kind of specialize in different things, or have maybe there's some with different ideas which they believe, and they collect around those ideas. So there's pockets of flat earthers all over, but we're one of the biggest flat earth groups. 24/7 Flat Earth Discord 2.0.
Yeah, and there's even, slightly different, I don't want to say camps, but more like sects in here. Like some flat earthers in here like to start out with curvature, axial rotation, and gas pressure without a container, whereas I go curvature, rotation, and how do you have gravity, right? And I like to attack gravity. It's my favorite thing, because they think sometimes when the Globers come in here that gravity is like the most settled science, because when they drop their cell phone, it goes down, right? Well, that's the difference between big G and little g. Why does it go down? We all agree that the cell phone goes down, right? So is it because mass attracting mass? Is it because... So we have to ask, what do you mean by gravity? Shout out to QE. Oh, is it because the bending and warping of space-time? Or is it because the buoyant force isn't strong enough to hold up your cell phone, or it is strong enough to hold up a hot air balloon?
Yeah, right. Gravity is a great topic, I think, to start with, because it's just stupid. They don't even realize, because they don't teach it, that it's a theory. Like, you can just Google it. I was shocked when I first found out about it, that gravity isn't actually proven scientifically. It's still a theory.
So education without demonstration is indoctrination. You don't teach a kid how to fish by handing him a book about theoretically hooking worms. Like, you demonstrate to the child how to fish. And they can't demonstrate what's making things go up and down. But I can. And they can't accept the cause and effect relationship. And that's why I don't even use the word science anymore, because they like to dance around that subject. I just say, do you believe in the laws of nature, the laws of logic? So if I manipulate the gas pressure, the ocean's not going to stick to the surface anymore. Can you do the same? Well, you got to hold my presumed causes as your control variables. Don't manipulate buoyancy and density. Don't manipulate any kind of gas pressure or temperature. And can you make the water go up and down like I can? And they always, got some kind of excuse, ad hominem, or category error.
Yeah, I like to play them this little clip.
What is gravity?
You have no idea. Okay, next question.
I don't know. Nobody in the entire world knows why that falls. So what is pushing this? Here. Why does that fall? Newton didn't know. We can describe it pretty accurately, but no one knows why.
We can describe gravity. We can say what it does to other things. We can measure it, predict with it.
I don't need a computer to get a kid interested in that. To spend a week playing with gravity and trying to understand it and come up with reasons why. So what is pushing this?
I don't know.
Nobody knows why. So Newton simply threw his hands up and said, I don't know. So I'm going to invent something called gravitational pull.
Yikes.
I need that. I need it so bad. Because, you know, they're describing things mathematically, whereas I got a mechanism, like demonstration. So what they got is totally different than what I got.
Yeah, I mean, just look at water. It's stupid to say it's gravity and objects pulling other objects. I mean, when a boat sinks, everything. That's how they explain gravity, right? A boat sinks and everything is getting with the boat down. But then you couldn't have like a weather balloon or, I don't know, something else flying. Stupid.
You know, this may be a bit off topic, but I've been watching a bunch of Ancient Aliens with my wife just for the archaeology and the amazing things that our ancestors did. And we're looking at all this stuff, and you know, we're honestly asking ourselves, like, how did they get them rocks in the mountains, bro? How did they do that? And I kind of think I know. I think they had Baghdad batteries, and they could crack the water and get the hydrogen and put it in hemp balloons. And, you know, what's a multi-ton stone with enough hemp balloons on it? And remember, hemp is the diamond of fibers. You know, all of a sudden that stone doesn't weigh as much anymore. Then the logs moving the stones becomes a lot more reasonable.
So, wait, can you explain it again?
If you add enough balloons to the stones don't weigh tons anymore.
Oh, okay, yeah. Makes sense. I mean, which kind of flat earth do you believe in? Do you believe like in this society thing, or that there's more land in the further, yeah, you know, behind the Arctic Circle? Like, yeah, what's your model?
Yeah, we don't promote any beliefs, so we don't have any models. We just have evidence against the globe and measurements of the ground or the surface being flat.
Yeah, models is what has got us into this vicious circle of belief. So Thomas Kuhn, he came up with this thing called the Kuhn cycle. I think it's Kuhn, Kuhn, Thomas Kuhn. So he's like one of the great philosophers of science. He's a big deal in my opinion. And like science goes through this cycle of, you know, like updating models. And the problem is that people get stuck with a belief. Well, we don't want to have any more beliefs. Like, we only want to be empiricists. So yeah, write that down. We are want to be empiricists. So no models, no beliefs. What can you demonstrate? Now, I said it was off topic, and I was speculating about the balloons made of hemp with hydrogen from the Baghdad batteries, but it's a plausible thing to say. I don't think it's Sunday, but it's a plausible thing to say. So that's as far as we, you know, get on speculation. We usually limit it to Sunday.
Got it.
Sorry, I've been sick for a few days. I'm better now, but Man, it was a rough week. But yeah, no models.
Just hating on the globe.
No, it's not hate. Like, if you were raised in a world where there's this mass formation psychosis, and someone offered you the ability to ask questions that you didn't know that you could ask, because you believed that everything was settled science, and settled science is like a married bachelor, right? There's no such thing. It doesn't exist. So we're just saying, hey, did you know that you could go out and test this 8 inches per mile squared claim, this radius claim of 3,959 miles? It's like, oh, you didn't know you could do that? Yeah, you can go outside and test it yourself, and then you can prove the globe. Or you might find the same results that we got, and, you know, it's not the scientific method, but peer review is really good, because once you go out and do some observations yourself, you don't have to believe anybody. So we're brainwashing people to think for themselves and question authority. And I don't think that's a bad thing. Think for yourself, question authority, go make your own observations and or experiments or measurements. Because if you go back 5 years, you know, people were trusting the science, and that era is over. Well, that era is over too, yeah. Both ways.
I mean, I think what I've seen like now, it's getting way more popular, the whole flat Earth thing. Amongst my age.
Well, we don't know how popular it's getting, because once it became the #1 search inquiry on Google, they shut it down. And we can't see what it is now because they've altered the algorithms the way that it works. But at one time, it was the #1 thing.
Yeah, we were one of the biggest servers on Discord early on, and because we were heading to the #1 slot, they capped our server, and so, like, whenever new people join, old people who haven't been active for a long time get removed to keep our numbers down.
Yeah, so I'm in touch with a fellow whose name is Peter. And Peter is from Richmond, Kentucky, but he travels all over the Midwest to various colleges and flat smacks people. And he says that far more than not, his reactions to the people who approach him are far more positive than they are negative. He says that most of the people are genuinely interested, but he says there's a good number of people who will come up to him and said, I thought I was the only one. And he's, the 3 years that I've known him, the more and more that he shares that same story. And he's retired, so all through the spring and fall he's out doing this. And anyway, it's quite fascinating, the stories that he tells from it.
So every time I get a new job, go ahead, I'm sorry.
I was just going to add to that, like, I found out I have an uncle I've never met, and turns out he's a flat earther.
I got a very similar story. I don't get new jobs very often, but in the past 5 years, I've had 2 new jobs. So 2 jobs in 5 years. And, you know, it took me a while with this one because I don't know the culture here. So I'm just kind of being quiet and listening because I'm not from here. But at the job I worked at first, I met flat earthers in the wild. And then after a couple months of being here, I heard 2 people talking about the moon landing. And I started finishing their sentences and quoting from the documentary they were talking about. And I was like, are y'all flat earthers or y'all trolling me right now? And they were like, we're flat earthers. So we don't know what the numbers are. And anytime someone says, well, your cell phone works, doesn't it? Don't you trust the experts? Have you looked at what they're selling as food these days? And that's a topic we can't really talk about, but, you know, I don't trust nobody. I don't even trust myself to, like, follow through with my New Year's resolution. So how am I going to trust somebody else? I think everything that they claim to be true should be verifiable. And according to Karl Popper, if it's not falsifiable, it's not science. And how many things people say, the stuff that comes out of their mouth, is completely unfalsifiable. Like dark matter, dark energy, that's 96% of the standard model of cosmology, the lambda-CDM model. After you learn that 96% of your model is not directly detectable, there's something wrong with you if you don't question that.
Yeah, I mean, most people are just buying it because it comes from a teacher, or I don't know, Neil deGrasse Tyson. Then they stop questioning it because they studied and they dedicated their life to it. I don't know, it's just retarded. If you look at every like elite guy, Freemason or stuff like that, they all believe it. It's just stupid for me to just buy into it. What people say, like, look at the vaccines or climate change.
So is there any more new people in the chat?
Inviting to stat in here, by the way, says who. That was good you had done that, because I was just lollygagging along with Drace and others. I didn't realize any new person had come along, so glad you had prompted for the new person to introduce himself. And Kek Zeg, if I'm not sure I'm saying your name right, welcome aboard. Sure has been my pleasure getting to meet you tonight.
Yeah, thank you. It's my pleasure. I'm just tired. That's why I'm behaving. That's why I'm not listening right, It's late.
Oh, you're fine. Germany. It's late. I'm sure, yeah, I was going to say, I'm sure it's, let's see, you're UTC +1?
Yeah, I don't actually know, but, Germany.
Yeah. Yeah, so you're, it's 9 here, so add, I think 5 hours to you then, so 9, 6, so 3, so about 0300.
Yeah, right. 0300, yeah. About that.
Yeah, so you must be tired. You definitely get a pass.
Kinda. We got a free day tomorrow. It's like a fest,
So about 11 to 12 hours from now, there should be people back in here, and there should be people in the politics server. We have a room over there. But if you're able, then that slot might be a little better for you on most days, I'm guessing, because there seem to be more Europeans around that time.
All right. You're all Americans here, right? Or Canadian?
Not all.
Yeah.
I used to call myself a Texan, but I don't know what I am now. I guess I'm a sojourner. I'm just passing through.
I mean, now I saw Jedi talking. I gotta add this.
Jedi, I'm one step closer to you doing that TikTok dance. I have the Android emulator running now.
Yeah, you can fuck off with your crazy ideas.
I gotta say, Flat Earth made me sad because I'm a huge Star Wars fan. I'm like,
oh, don't worry about it, man.
It's not real. I don't know.
But it's you can still away. You won't ever go in there. It's fine.
No, I still love Star Wars, but you know, it's you always had this this hope. You know, when you're a globe, you always had this hope because the universe is endless. It's like, oh, Anakin is somewhere. You could just play with your fantasy.
Yeah.
Well, all Flat Earth does is removes the psychosis. You can still enjoy your fantasies. I mean, I still play Elder Scroll video games. I don't think that you can be a spell sword in real life, but doesn't mean I can't enjoy it.
Just try to make a joke.
Yeah, are you German?
Yeah.
Yeah.
And you're trying to make a joke? That's funny.
Yeah, we're serious over here.
You know, I think you guys will get your sense of humor back when you can learn to take yourself a little more serious. The German Empire was pretty impressive.
Yeah.
I mean, the technology, right? Come on.
No, yeah, of course, everything. We built a lot. The cars, Gutenberg, you know, the book print. Germany did a lot for like science and evolution of humanity.
Blowing things up. Yeah.
Yeah, I can hear
Where I live is pretty much one of the hearts of your Germany away from Germany. So I would say a good majority of the people around here, their name is definitely a German name.
Mm-hmm.
And there's actually a surprising number of German speakers here.
Mm-hmm.
Where you at, if you don't mind?
Indiana.
Okay.
So you're Mexican then?
Mexican, yeah, pretty much. Well, actually, now it's Guatemalan and Honduran.
Are we allowed to make Trump jokes?
Most of us are not political.
Yeah, we try to avoid politics here. Yeah, I know. Yeah, but we try to avoid politics here.
Okay.
Yeah, but we do like to laugh at our government. It's like wrestling, you know? It's the same exact thing. As far as most of us are concerned, I think I'm speaking for everybody.
Yeah, I just have to sometimes get something off my chest, you know, to laugh.
So, my son here, he rode his bike off the concrete portion to the gravel portion of our driveway, and the training wheels are holding the wheel up just enough, and as he pedaled, it pushed the rocks away, and he's pedaling as if it were like a stationary exercise bike, but he's on a bike that should be going somewhere, but yet, just like the government, it's going nowhere.
Gravity's fault.
Every time the government says they're going to shut themselves down, we're just like, are you not joking this time? Can it be permanent, please?
The 5 scariest words in history. I'm here from the government, and I'm from the government, and I'm here to help. Or how many ever number that is.
You could just say anything and it would be funny with this accent. I love it.
Americans do sound funny, don't they?
Yeah, I mean, it's a typical American. I know, that's how we grew up. Like, that's how we imagine American people. How they talk.
Well, very good. I'm glad to entertain. You know, I realize that a lot of us Americans have a lot in common with the Austrians.
What, for example?
So the Austrians have a term that they love to refer to Germans as Pifka, which, you know, because, you know, like, it's a subtle dig of the proper, you know, well-spoken, well-behaved German. And so, you know, when I very first heard that, I'm like, holy crap, that's exactly describing where I'm from, and I've never had a word to describe those people until now, and it's exactly it. Everything is perfectly put in place. Everything has a routine, and everything is all said and done. The grammar is, you know, been beat into them like their German grandparents would have beat it into them. And so even in English, they have perfect diction and perfect grammar. And so it's... So I realize we both have that observation in common.
Right, yeah.
Americans? What kind of Americans are you talking about? Like, I'm used to the F you, I won't do what they told me.
No, I'm talking about the Germans that are... you know, like, you know, like, especially when I was a kid, some of those were second-generation Germans. But, you know, then some of those were third-generation Germans. But now you have quite a few third- and fourth-generation Germans who still have, you know, they still have that German excellence in engineering and diction and grammar. So one of the stories that I tell is the county that I grew up in, they actually had a lot of German prisoners of war. And there was also the Tuskegee Airmen here. And, you know, they were black military pilots, or what the Germans referred to them as the Schwarzvogelmensch. And... interesting enough, the German prisoners of war here, they would, when they were brought here to the Air Corps base, they were pretty much just told, okay, here's where you go to work, you be here during these hours, you report here on this day. And a lot of those people would go stay with their cousins and such locally. And the Tuskegee Airmen, they couldn't go to town. They couldn't go to anywhere, so they would be stuck, and you know, stuck on base, things like that. And then they had that famous mutiny they had here. So it's one of the most interesting cases in the world that prisoners of war from the enemy had more freedoms than the black aviators here.
Yeah, when a lot of people talk about, Germany, what it was doing during that time, it turns out that, a lot of that stuff was going on here, just in different ways. So the Japanese had concentration camps in America under a Democratic president, by the way. And, the Cherokee had the Trail of Tears under a Democratic president also. So a lot of that eugenics. Go ahead.
And I was just going to add in real quick, and don't forget the Lutheran churches around here would have to have they would have to register with the government when they were having services, and military officers would come and monitor for sedition. And but continue on about the eugenics.
Yeah, I would say that, before World War II, we were doing the eugenics thing, maybe not us, like my family line. But, as Americans, there was a lot of eugenics in the culture. And all you have to do is look at Margaret Sanger and Planned Parenthood, but I digress.
No, you're not digressing. There's a book called The State Boys Rebellion. So eugenics was in full swing here in the United States until the 1970s. So you can say without a doubt that eugenics was ended in Germany 30 years before the U.S. The way these, if you let me learn to talk. When you get some time to put a new book into your queue, that book by Michael D'Antonio, The State Boys Rebellion, it's an absolute eye opener of things that happened, up to about 1978, 1979, in what they called the state schools here in the U.S. They would literally take boys as young as like 6 and 7 and give them an IQ test, and they were supposed to differentiate the words timid and tame and things of that nature, and they were ordered to be into state schools and lobotomized and all sorts of stuff. And Michael D'Antonio does a good job of explaining some of the unexplained statistics there.
Back to the German people. I kind of have this theory: if the German people, if everybody would just leave them alone, I think they'd be all right.
Yeah, kind of. Right now, not. But early in the day, we're really dependent of the EU and France, and we don't even have our own electricity.
Yeah, but you have the ability to produce and trade for that electricity.
Yeah, that's right. I mean, I agree, like, Germany is the heart of Europe.
You know, I remember when they first started talking about the EU and how Germany would pay for the lion's share of it and such. And I'm like, oh boy, we've been here before.
Do what? I didn't understand.
Oh yeah, because World War I ended and it was not fair.
Paying for for the war.
Can you imagine without a government if some just rando came up to you and said, hey, let's go fight and die in trench warfare in Europe? Like, the Americans would be like, wait a minute, you want me to leave my wife and my fish and my deer and my children and my crops to go fight and die in Germany for what? Oh, for the banks. Hell no, bro. Hell no. Hell no. We ain't doing that.
You know, I'll tell you.
Even that is propaganda, you know.
I'll tell you another thing that a lot of people don't realize is a direct predecessor to the American involvement in the growing war, which is Orson Welles' broadcast War of the Worlds.
Do you what?
Yeah.
How are those related?
Okay, so here's the interesting thing. 10 years ago, you could find through the Google machine all kinds of citations and interesting articles talking about that. The Google machine now has decided that you shouldn't see that and hides those results from you. So I want you to think back to 1939 a moment. And the way radio works. So radio primarily from the networks, these shows were broadcast live from a studio in New York. And they went over really crappy phone lines where they were repeated and hooked in through all kinds of different phone, direct circuit links to radio stations across the country. But you didn't have, like, those going to every little town like you would have, say, one in Chicago. So people in Kentucky, well, they would be tuning into that mammoth WLS in Chicago, listening to War of the Worlds, not knowing that it was a show. So what happened then is, so as people are turning in, and you're hearing every lightning strike between Chicago and, say, southern Kentucky, and you're hearing, the Germans have hit the cathedral. The cathedral, that once big, magnificent building, has now been, it's now to shambles. Now over here in California, they have leveled the Golden Gate Bridge. It's just gone. And then you would hear again, and the Germans have demolished the White House. Well, today we laugh at it and say, oh, well, they were talking about Martians. But what they were hearing in these small towns all across the country was the Germans have attacked. That's what it sounded like. They sure in the hell didn't know what a Martian was. They didn't believe in Martians, but they thought they were hearing Germans through the bad strikes. And at the end of all of that, what you end up with is that it was the most masterful piece of propaganda in human history, because the people in the cities that could hear it playing knew that it was some kind of science fiction banter, but the people out in the edges where you would be actually getting your draftees from, those out in the country who wouldn't have the money to pay off the draft and whatever else. Now their families tell them, "Oh well, son, you got your country's calling you. No, we didn't want this. We didn't want, but you know what? Your country's calling you. We got to go." And so the sentiment changed from 39 to 41 because of that broadcast.
Wow, that's crazy. I never heard that before. I did hear quite a bit of lies coming out of Britain and the likes, trying to drag us into World War II, and I know they were drafting.
Hey,
sorry, bro. Y'all should have just let them go get their Germans, whatever they were being genocided.
No, you're right. You are right. A lot of German royal family.
How many times did Hitler sue for peace? It was a ridiculous amount, right? And I'm not, don't get me wrong, I'm not pro-government. So you can't say that I'm pro-Hitler either. That's government.
Yeah.
But he did sue for peace quite a few times. And, check me if I'm wrong, but wasn't the swastika basically a peace symbol?
It's a Hindu symbol of some sort, yeah. But it's not an evil symbol, it's a peace symbol. It represent many different things, that swastika.
Right. So the Native Americans...
The spiral in the sky north, the 4 different positions of the seasons of where the Big Dipper or the plough is around the North Star Polaris. So it looks a bit like that.
Right. Yeah, don't construe any of that stuff as me taking sides or anything like that. I'm just pro-peace, and, the pen is mightier than the sword, and I just don't like bloodshed. So, call me crazy.
I mean, for me, it's just ridiculous. In Germany, you can't really talk about this. It's like, I'm lucky I'm in a more racist or right-leaning town. Not racist, right-leaning. But even here, it's hard to find people who are actually open to a discussion, or like even saying like, "Oh, he built an autobahn," like Kanye. It's people look really, really fucked at you. It's like bringing up Flat Earth. They immediately cut off and stop talking.
It turns out that intelligence isn't measured by your ability to repeat what you're told. It's actually measured by your open-mindedness and ability to learn.
Yeah, man, most people believe the Earth is a globe. Like, IQ can't be that high.
They're advising on where you should go and how you should get there to attempt to make this observation. I don't know. Maybe they're just trying to rip people off.
I bet you it's as high, a super on top of a mountain as high up as they could possibly get in California, in order to view 2,500 miles over a curve. Because that's the same thing. Because that's like the same thing as doing the 1 foot observer height over 1.22 miles. Is that you can make it look like
you want to do that. You want to get a higher vantage point, right?
So like right. So if you do like 2,500 miles. Just to look at something specifically over a curve, you would make it look like it's flat. It looks like it's flat because you're so high up, and you can see from that point that we play around with our. That's how, because we have only two eyes. We just do it to fuck with ourselves.
You would want, bro. You would want to mitigate, right? Things getting in the way, like waves, and then sand dunes, and then buildings and trees, right? For fuck's sake!
Because of the curve, like we wouldn't need that if it was flat.
What about normal things potentially get in the way despite the curve? Like waves and sand dunes and trees and buildings.
Yeah, if that's the case, the horizon has.
Bro.
Yeah, because like when you're in a forest, the horizon is just trees and shit, not water. Just look at a Bob Ross painting. It's got mountains and fucking.
Fuck, even a boat out there could potentially obstruct your view of it, ruin your shot. So whether flat or curved, you're still going to want to get a higher vantage point. You're just going to claim that, it will also aid in mitigating some of the curvature, but you're going to have to go ahead and demonstrate that fucking exists.
But he thinks that things can't be obstructed by a flat surface or even objects on that surface.
Right. Exactly. Yeah. Exactly. Yeah. This is also ignoring those aspects.
Yep.
Considerations.
Above eye level and then at eye level, right? You can see the white squares, and then you can't see the white squares. And that's what he's not understanding, is that it's all perspective. And the fact that you, as a human being, are closer to the ground, things are going to appear to disappear bottom up on the ground. And that doesn't require curvature.
Yeah, but that's only because we're limited to being on the ground.
You son of a bitch. That's a lie. We're limited to being on the ground. We don't have airplanes. We don't have hot air balloons. We don't have means of getting off the fucking ground. I hate you.
That's my point. But that was my point to begin with, is that once you go higher up, you can see more far enough to see curvature.
No, you can't. No, you cannot.
Get high enough, you can.
No, you
what curvature? Right? What curvature?
What curvature?
You can make it look like it's flat all the time by just getting really high up and then picking a spot. Because it's hundreds, it's thousands, hundreds of thousands of miles.
I'm talking about the curvature that doesn't seem to be there.
But it's there though. It's right there.
But it's there, but we can't see it. It's not. But it's there.
Trust me, bro. Trust me, bro. It's there. It look like it.
Trust me, bro.
That's a circular argument. I can't see it because I can't see it.
Doing.
It's not there because I can't see it. It's like impermanence.
No, you're doing Ipsy Dixie. You're just saying it's there. Trust me, bro.
You can see. We're talking.
That's like the ultimate gaslight. Is you were totally taught that your senses are lying to you, and now you believe that your senses are lying to you. That's like total brainwash. Total brainwash.
I literally said it. I did literally say that our own vision can bamboozle us. That was my point. You guys are the ones who are saying that just because something looks a certain way, it exists that way. But
Wait,
so
no,
like
we haven't
all
said
just,
that yet.
our eyes are all bamboozling. Oh, that's great. Okay, all right.
We haven't said that. We've just been talking about observations of Hawaii from California, bro.
it's the same thing. Like, that's why we need a level to know if a frame is actually level. Like, you can't use your eyeballs to see if something is perfectly level. You can only guess. So you're guessing. You're guessing that because the Earth, the horizon is so flat that
you have an inbuilt sensor for level, bro.
You don't have.
You can stand on something and get a sense of level. I mean,
you do not have laser. You do not have laser focus. Like that. That requires.
You have an inbuilt leveling system, right? It indicates to you when you're offset from horizontal and vertical. Bro, yeah, it does. Yeah, you get this inbuilt fucking natural system. It's cool, eh? Like, it's like your own gyroscope.
The bipedal mammals that can only see with barely at all. Like, we're pretty good with sight, but you can't see like a laser. Just determine whether or not something is curved. I wouldn't use my naked eye. I would use a laser. Because we are not that superior.
Yeah, bro, I don't even know what you're talking about, because we were talking about observations, long-distance observations, specifically of Hawaii from California.
Rather, for like an observation, let's say you want somebody's got to remove a tumor out of your brain. Would you rather that person use their naked eye to be precise, or would you rather them use a laser focused lens that's...
Bro, I'm not talking about deducing anything from it. You were the one saying, yeah, but the curvature.
I'm saying that
you were putting out all these these requirements, or we should be able to see this or that. I just pointed out, like, hey, they're saying that's possible, and you'll say, yeah, but the curvature, and yeah, this and that, yeah, but this and that, right? It's like I'm just going along with you. You said, about seeing Hawaii from California. Oh, it turns out you possibly can, and here's some advice on how to achieve that. Right, and then go and make that observation. Oh, yeah, but the curvature this and the light this and the light that, right, bro? Like, you're arguing with yourself at this point.
Can you link that? Can you link that claim that you can see Hawaii from California, please?
I don't know. I can't validate that it's true. I'm just saying that they're telling you can attempt to make that observation. And I posted it in the side chat at 50 past the hour. The thumbnail says, with over 2,500 miles separating California and Hawaii, seeing the tropical islands from the mainland might seem like an impossible feat. But is it actually possible to spot Hawaii's iconic volcanoes and sandy beaches from? It goes on.
Okay. And
you read the article, says that it
says the curvature of the Earth.
Some of it.
The surface is not flat, but instead curves gently. This means
I never made a claim about it.
But your link says that you can't see it. So the vast
you can, right?
May see. Let's just start using powerful telescopes. One way to catch a glimpse of Hawaii from California is by using a telescope.
Yeah, I wasn't presenting it as any kind of evidence for anything. I was just meeting your criteria.
So on a clear day, you can only see the very tippy tops of. You would have to look with a powerful telescope and see with massive mountains. You have to look at the tippy top of the mountains that can reach above the natural curvature of the Earth. Because it's 2,500 miles, so it's a very specific amount. So once you get to the right position with the right equipment, like a laser, you could bounce the laser off of the tip of the mountain from another mountain.
Yeah, I'm just presenting it to you. You in this article are adding extra to it, right? You just said something about being able to make that observation, and I posted something that claims it's potentially possible. And probably people have even done it, right?
Everything.
I'm not saying why. I'm just presenting it to you that you made a criteria, and this meets it
because you can't see it.
Now you're adding in stuff. Yeah, but you got to get high. Yeah, but the curvature this. Yeah, but the refraction that.
So it's not visible most of the time because of the curve. So I am correct in saying that.
No, that's just Ipsy Dixit. That's just a declaration of fact. Like, you're just saying it's true, right? How do you know?
So you can see it. So like, yeah, right. And like I said, the higher you go, the more able you are to see over a curve, which is what creates
what curve?
The whole time.
What curve?
Regardless
What
of
curve?
like what you're looking
What
at,
curve?
the whole
What
time,
curve?
because the
What
curve is the
curve?
right on the globe. The globe curve.
What curve are you talking about, bro?
The globe curve.
Yeah, where's that? How do you know that's true?
Directly underneath you.
You're just stating it's true, bro. You're not you're not demonstrating it to be true. You're just stating it is true.
That's right. Like the sun rises from the east and sets in the west. Those are true statements.
Yeah. When God, when globers state the fucking obvious.
I'm Globe Jesus.
Yeah, and that makes the Earth a globe. Why?
So it's a fact.
That means
reality.
Yeah. Oh, bro.
I told you I'm Globe Jesus. I can answer every question you have. I know
just with an Ipsy Dixit declaration, right? It's just
Alan, you're fucking stupid, dude. Where do you get this? Where do you get this curve from? How was this curve measured or calculated in the first place?
You get it from gravity and mass.
Okay, what's that?
Earth is a massive.
It's right, Jesus. He's right.
Okay, watch this. Right? So you drop something. You drop something, and it falls at an acceleration of approximately 9.8 meters per second squared. Right?
You have it. It's in the. So if you look in the title where it says 24/7 flat Earth, right before the 24, there's a little drawing of a globe of the Earth.
No, dude.
Round.
No, how about you?
And so,
no, dude, you're gonna answer my question. I'm putting on you. You're being a fucking troll. Right? You got 9.8 meters per second squared acceleration downwards. How do you know what causes that?
Because we know how gravity works.
How?
Okay.
The Earth's mass.
Okay, how'd you get that?
We measured it. And
okay, how?
A bunch of geeks did it.
How?
Yeah, how?
With math and physics and science and instruments.
Okay, so meaning you would have needed the measurement of a ball in the first place, which you just said you needed because, to get gravity, but now you need it for the other thing, and you need dude, you're in a fucking circular reasoning fucking spaghetti ball here.
How do you...
it couldn't be more vague, right?
Okay, well, I'm open to measuring a ball how you would measure a ball.
I'm asking you, how was it done?
It was done with math and science.
Supposedly we know. Right? Supposedly
math and science, duh.
It's already been done and established, right? How was that done?
Well, it was done by taking the radius of the curve and calculating it.
How did you
what radius? What curve? That's the thing you're trying to fucking prove, you idiot.
A radius of a curve. Did you just say a radius of a curve?
I'm confused.
I'm sorry.
Radius of a curve, bro.
You take you would measure the curvature, and then you would
with gravity. With gravity.
Yo, yeah, you got
measuring gravity.
Well, the gravity is
gravity because curve, because gravity, because curve, because gravity.
Yeah, bro. You got to step up your game.
About what I'm talking about. That's fine.
Yeah, bro.
Okay, so you still haven't established how you know any of these prerequisites to then go and use them in everything else that you're asserting.
Correct. That's how you establish a point.
Okay, so you don't have the prerequisites.
So I do have. What do you mean? We do have the prerequisites. That's like 2025.
You just tried to make a point on all that, and you failed miserably. Okay, I asked you how was this measured. You couldn't do it.
I can do it. I'm answering you.
Math and science, bro.
How is it done? Twonger, shut your mouth. How is it done?
What do you mean? How is it? Define. What do you mean it?
How was the curve measured, or how was the circumference measured, or how was the radius measured? All these things, that your position relies on, as opposed to asserting them to be there without confirmation. How were they confirmed to actually be there?
The answer is trigonometry. That's how we measure curves.
Okay, go ahead.
So we take triangles.
Oh god.
So I mean, like in terms, again, this is like we're getting into the wonkiness of it, of like the physical.
And we're going to do it. We're going to actually do it, right? So you can actually prove your point.
Are we going back to India?
So
everybody,
do you know what trigonometry is?
Pack your bags. We're going to India.
Okay, so that's mathematical calculations.
Yep.
And we can use triangles on the surface of anything. We can take the trigonometrical survey of any surface and determine
what was done
determine the exact geometric shape of that surface.
Okay, how was it done for the surface of
you like completely ignored what I just said. We said trigonometry measures curvature, correct?
No, I heard you speak in abstract or in generalities. I'm asking you for the specific method, sir.
That is
how is it employed?
The method that we use. We use trig to measure.
No, those are the tools. Okay, what was done with those tools?
You gotta be clear on the questions. I'm answering them accurately. So the tools we use are the theodolite and then map.
No. What I meant to say was those are the mathematical tools, right?
Yeah.
That we use, that we employ in some method, right? Dude.
We use a compass and we use a theodolite.
Okay. So
Compass is a flatter tool.
Okay, so what did they do?
Tool.
Walk me through the steps so I can replicate it, or that somebody could replicate it.
Here, no, all you got to do is look up, just Google great trigonometrical survey.
No, I'm going to ask you to, you're going to explain it so everyone can hear your point.
Okay. So they measure with a theodolite the elevation the relative elevation of 3 points on the surface of the Earth.
Okay. And then what? What can you conclude with that?
And then using the tool of trigonometry, so you got the specific numbers with the 3 points, you can determine the elevation between those 3 points relative to a horizontal plane.
Very good. Okay, so where are those numbers, sir?
What are those numbers? So that's a ridiculous question because we don't need
I asked you specifically, fuckface, for what they did to determine these facts that you're spewing.
Again, these are facts. There's a difference between facts and like the fact of what they do versus.
You're not going to do this, dude. You're not going to do this. What did they do? Go get an example of this having been done that solidified this whole point of yours. Go get it, put it in the chat, and after that, you'll be unmuted. I'm fucking sick of this. Been listening to you ramble on for fucking like 2 hours. Christ almighty. Something's really wrong with you, man.
Something's wrong with you.
Go get it put in the chat or shut the fuck up. I'm sick of this. Why he wasn't muted a long time ago is beyond me. Fucking poisoning the fucking VC with his nonsense. Circle jerk fucking skating around. I'm sick of it. No wonder you were gone for a long time.
It's
for all I know, someone booed you out. I wonder why. God damn it, guys. Hurry up, Talon.
You think he's really doing it?
Of course not. Or if he is, he'll prove me wrong there. Until then, it's done. Fucking hogging the mic with nothing. Christ.
Right. He's not a scientist, but he knows one. Asians. Am I right, guys?
Did I mishear that, or did he say he could prove curvature with gravity?
He started with that, and then I asked him how, and somehow he got to trigonometry, and then I asked him, okay, what was done, And he said, "Oh, they just use trigonometry."
How can you ask him? Bro, how can you ask him how without bursting in laughter? What does
I mean,
gravity
I
say
was
for
laughing in the background. I was kind of laughing in the background, right? And then he fucking went non sequitur on us and changed the subject because obviously they're not did. They can be, but not in this way, not in the way we were talking. And then I asked him for specifics, and he couldn't do it. So I said, "Shut the fuck up. You're gonna go get the specifics, get what was done already, right? Some data that was published that some people had already done." Employing the method that you're spewing out of your asshole, okay, and then we'll look at it. Until then, he's gonna sit on mute, and that's it. Fucking figure skating in this room for like 3 hours, man. I'm sick of it.
Right.
So now it's just going to be a quiet Discord. Boring.
You know, I'd rather that. I don't know about you, bud, but I'd rather that than listen to Talon fucking diarrhea of the mouth any longer.
Me too, bro. Me too.
Christ almighty.
Same.
Or Robert from Utah. Rather have silence than listen to Robert from Utah.
But it's like it's gravity, guys.
Go ahead. Maybe you can make the point better than Talon.
Well, yeah, what's your gravity, and then you know it does everything.
Okay, so what are you talking about? You're talking about the acceleration, 9.8 meters per second squared, approximately.
I'm talking about gravity does everything.
Okay, how? Which type of gravity are you talking about?
By existing.
Okay, how do you know that there's a standalone force called gravity caused by something that's doing anything?
Because it does everything. That's
okay,
how I know it's there.
Okay, explain.
Or like it just does everything.
Okay, so you drop a thing, it falls down 9.8 meters per second squared approximately. Right?
Yeah.
Okay, then what? What does that tell you other than you dropped a thing and it accelerated at that rate?
Well, that gravity is amazing.
How do you even know it's there, sir?
Because if it
how do you know that there's a standalone force called gravity, and what you're witnessing is not the outcome of other factors, right, coalescing together to create that effect? How do you make that? How do you make that distinction?
But again, it's because if it does everything, right, without
but you still have to substantiate that there is an it there in the first place, as opposed to this phenomena that you're witnessing being caused by other things that are already known that work in conjunction with each other to create that effect. You have still yet to establish that.
I mean, if it's not gravity that does everything, then what is? You know?
Okay, and that's not my job, sir. That's for you to prove. This is your point.
What?
What? Okay, you're gonna go on mute too, because you're equally, if not more, retarded than Talon, and I'm sick of your voice already.
I'm sure.
Fuck it. If anyone wants to take it up with any of these two clowns, by all means, go for it. But as of yet, it's been nothing but horse shit. Finally, some fucking peace, man. God. Helen, I just saw it in the in your DM there. Put it in the text chat so everyone else can see it, please. Oh, I missed that part. Thank you. I'll share it then. All right, just put the Talon's evidence in the chat if everyone wants to take a few minutes. Kathos, if you've seen this already, do you want to continue the conversation with Talon? No? Okay. Has anybody else seen this before? Who'd be willing to talk about it? I have not, so it would take me time to look into it.
I actually want this Bob Smith to join the VC or get tech suppressed because he's already starting to spiral out in the side chat, trying to say I cited stuff from a religious text, and I haven't done that. As a matter of fact, earlier today I said that I don't need any religious book to debunk the very tale Magic Mind Marble. So Let's see if we can get this guy in the VC.
Jenna, in the meantime, have you seen this, what's it called there? This great trigonometric survey?
I haven't seen it. I haven't seen it, but as I'm looking through it, it would just suggest that a whole bunch of triangles are being used on the surface of Earth for practical mapping.
Right on. Okay, let's have Talon explain himself a bit. Go for it, sir. Whoops. Go for it. What the fuck?
Hello. I'm ready.
Go for it. All right.
So that's the measuring the curve, so to speak, with measuring the exact shape, because previous measurements and calculations only are able to get like the small portion of the curvature, whereas a great trigonometrical survey will give you the exact curve across the entire continent of, in this case, India. So they used India to grid out the trigonometric elevation of the Earth, and they were able to not only measure the curvature, but they measured the change in curvature from the on the axis of the globe. So the closer they got to the equator, the more the Earth was curving. So they knew that it wasn't a perfect sphere through those calculations and measurements.
So where were they getting their elevations from?
So the entire continent of India. If you zoom into that picture of the map, it shows every little triangle that they took, and so they did lines of grids of trigonometric surveys over the surface of the Earth as far as they could. So that way they had data from every inch of the over the north by south and east and west as far as they could go. They had to go every. Because they had to go across, so they had to put a triangle down on every part of the curve of the globe, so that way they could calculate it. The curve exactly.
Oh, there it is, guys. Triangles. They got to put triangles down everywhere, right?
Right. You measure the 3 points. That's what surveying is.
There goes. No. So I don't. Maybe I just wasn't listening, or you just absolutely, completely avoided answering. But where are they getting these land elevations from?
From the surface, they would take 3 points.
From the surface of what?
On the planet, on Earth, because you can look in the map. When you look at the actual zoomed in picture.
All right. So you just post up some shit and you can't even fucking tell us about it.
No, I just told you they're measuring it across the surface, from point to point.
What? The surface of what?
The Earth, India. They do it. They do each continent.
Never mind, Talon.
You have to look up the North American one. There's a European one. They do it on all the continents. It just took years. It takes like 5 years to do the whole continent.
How are you getting elevation of the entire continent? Like all the different points, all the different elevation points, right?
Yeah, that's trigonometry.
That's coming from the land itself? No.
They take a chain. No, I know what you're talking about. They start at sea level on one side of the continent, and they have a chain. I know what you're talking about now. So yeah, are you talking about the baseline, right? Like from where? How do they start? Where do they start the elevation? So they took like this perfect kilometer long. I don't know the exact numbers, but they take a chain and they measure that distance from sea level to their first. To their first measurement from the elevation from sea level, and then they base everything else that they measure from that single point on land, because they're right at sea level and it's perfectly level to the ocean, and so from there they can determine the elevation of every other point on the continent.
So we're taking these from horizontal baselines then?
Yeah, the chain is perfectly horizontal from that distance, and then that's the reference point that they use. So everything. The elevation is relative.
It doesn't exist on the globe, Alan. Fucking horizontal. We're back to this again.
What's the water? It's level. the water's level and horizontal across the surface, and so they use that as the baseline. So the elevation, because we know that land above water is has more elevation than the minimum level for water. So that's why it's a good baseline to start.
Talon, I swear to God, if I were to put you in a round room and tell you to go to the corner, you would run in fucking circles.
What? I mean, I guess I'll get bored after a while. But why are you trapping me in a room?
No, I'm just saying, because you go in these fucking circles, it comes right back around to where it was before. So they're taking it from horizontal. They're treating it as horizontal. There's a horizontal baseline. Treat it as horizontal and level. Right? So we're back to square one. We're back to where we were when I came into this call.
But everybody agrees that that's how you would determine the elevation relative to sea level, to a horizontal baseline.
Yeah,
like
that
the rest
would be
of the
treating
planet,
the Earth as
so, like, you
flat,
go from there,
Talon. Yeah, that would be treating the Earth as flat. Yeah, horizontal.
No, the Earth would appear whatever, it would calculate the measurements would show whatever shape it is.
Oh, it would calculate. Oh, Freudian slip there. Yeah, there's no fucking measurements of curves. Stop.
It's not flat if you go from triangle to triangle, each triangle's dipping a little bit, and there's a drop over distance. That's not flat.
So there's this flat baseline, and then this flat baseline is basically like this. What do they call it? The giant.
No, it's just one baseline. It's a matter of because it's a matter because once you go north to south, you only have a 2 dimensions from north to south. So then you have to go east to west, and then when you measure all the drop over distance from east to west, and you go across the entire continent, you find a nice gentle curve. But then it's
so you're kind of describing to me like a polyhedron Earth, dude. That's silly.
Well, no, that's the thing is the measurements are a polygon, but the actual surface of the Earth isn't. So you would So again, yeah, you have to calculate out the polygons that are leaving a little gap between each point. But like the triangle, at no point are the triangles perfectly horizontal for thousands of miles. That never ever happens anywhere on Earth where there's a flat horizontal baseline. There's no point where it's always for thousands of miles a horizontal baseline. It curves every time.
So it's horizontal, but it's curving.
No, each triangle like over the survey is horizontal relative to the baseline.
Yeah, exactly. Kathos seems like they corrected. Kathos exactly has a point in the chat. Seems like they corrected the data to what they wanted to see, to what they wanted it to be.
Right, because the Earth is not a series of polygons. It is a smooth curve. So like you have to calculate out all the straight lines. So like when you're going from because that's basically the only way to go from a set of horizontal polygons that are all horizontal by themselves, but then they form a polygon, which is a curved globe. And you want to know exactly the curvature, you would correct for the curve with the radius. You would correct that information with a calculation to find the proper curvature. Because we don't live on a polygon.
Talon, have you had the triangle test?
We did establish that trigonometry and triangles are the method that we use to measure curvature, because there's no there's no ruler that you can put on a curve and tell us the degree of curvature. I mean, maybe what is that, the compass? Like you need a compass for that. But even then, like if it's not matching that, you have to use a compass to even get the trigonometric measurements to calculate the curve, radius, and circumference and stuff.
So that figure I just posted, which of the figures below are not triangles?
Are they 3 points connected?
No, there are two that are not. No.
A and C are, and B maybe. B's got a curved side, but it's got 3 sides on points, 3 points, so it's a weird.
Yeah, B could be a triangle. Yeah, B could be a triangle if you don't assume that the image is not a 2-dimensional plane.
And even
fail this IQ test. You flunked. It was like flunking blocks. All right, which you can only pick 2. And there is a right answer and a wrong answer. You can pick the wrong two, or you can pick the right two, or you can pick one right one and one wrong one.
Right, I said D is not a triangle. I said D, not a
Okay,
triangle.
and there's also D and B are not triangles. Is that what you said?
What? No, I said D is not a triangle. B has got 3 sides and is a triangle.
Well, then you would fail the test.
It's got a curved.
No, it's B and D are not triangles.
Why isn't B a triangle?
Because you need to go look up the definition of a triangle, sir.
Triangle. Sorry, I didn't mean to mock you. 3
straight lines that connect. That's the definition of a triangle, and B is not 3 straight lines that connect.
I don't think it has to be straight lines, though. I think.
No, that's the definition of triangle.
All right, let's see what a triangle is with a curved line.
I was going to say that's the definition of a 2-dimensional triangle.
What do you call a triangle with a single concave side? It's called the Starfleet.
It's called a triangle because there are 3 angles. So you can't have like a curved line.
You can have a hyperbolic triangle. So a triangle with 3 curved sides that curve inward would be a hyperbolic triangle. It's a curvilinear triangle. So in a simple way, it's a triangle, but a triangle with 3 straight sides is a geometric triangle. So you can have curved lines in a triangle because it just has to have 3 sides.
Ooh, yeah, this is interesting. Yeah, a curvilinear triangle is a triangle. Is not a triangle in the traditional Euclidean sense, but the term is used in mathematics, particularly in topology and geometry. Interesting. Yeah, so if we're working in more than 3-dimensional space.
Yeah, because the thing is
it's just straight out not a triangle.
Yeah,
those children would have got the answer wrong if they'd said B is a triangle in their test. No specifications were made about it being this type of triangle or that type of triangle, according to some different type of geometry. Those children simply would have got that answer incorrect.
It's called common denominator.
I was going to say, we're not children, though.
No, but here's the problem, right? Here's the problem. If you take one of these special, quote-unquote, types of triangles, right, and actually, in order to actually measure the angles of the sides, you have to map it to some sort of other space of sorts in order to actually make the lines straight, so you can actually measure the lines. Or you take a tangent to the point where both of these lines, one of the straight ones and one of the curved ones, actually meet, so as to create an actual straight line in order to actually make the angle, so you can measure it. Okay, so the whole point is, at its base, in simple terms, these are not triangles because you can't get 3 angles directly from them. You have to do some manipulation or mapping or shit like that.
No, exactly. You failed a child's test. You failed a children's test.
No, but you're basing that on a different definition of triangle.
You've been exposed.
Let's be clear here. What did the question ask you?
Is it triangle?
Which ones are triangles? Which ones are not?
A triangle. Right? A triangle is in its simplest form 3 sides.
Did it ask you which ones are triangles or hyperbolic triangles?
It actually says which ones are not triangles, and so D is the only answer because the other 3 are forms of triangle.
No, dude.
It's what it says. Look, it says not triangle.
No,
not triangle. It says not triangle. Read it.
Right. So B. Well, that's the whole point. So B is not a triangle either. It's a
B
hyperbolic
is a form
triangle.
of a triangle.
It's
a shitty triangle.
We asked
a shitty triangle is still a triangle.
No, we didn't. No, dude. We asked you for triangles specifically. We didn't prefix it with anything fancy. There was no caveat.
Yes, not triangle is the actual question. So we're not talking about which
B is not a triangle.
Type of specific, not specific at all.
B is not a triangle because it doesn't have straight lines. It would be a hyperbolic triangle, not a triangle.
That's different. That's not what it answers.
It's not saying. It's not saying which ones are not.
It doesn't say which ones are exactly triangles. It says which ones are not triangles, and that's only D.
Bingo.
B is not a triangle either. It's a hyperbolic triangle.
is a type of triangle.
It's a type of triangle. That's like saying that
Dude,
pink is light red. Pink is a shade of red.
Dude, hyperbolic triangles are not natively triangles because they don't have three fucking angles.
Just gonna pitch in here. Just gonna pitch in here quickly.
Like I said
You're
before,
saying
you have
saying
to-
it's
you
not a
have to-
triangle by calling it a
Yeah, you have-
triangle.
No, dude.
You're saying a hyperbolic triangle is not a triangle when you're literally saying it's a triangle. It's a shape with three sides and three angles. That is by definition a triangle.
You're an idiot, dude. How do you get an angle from a curved line without any manipulation?
You're in a non-Euclidean space where the curved line is straight. Like Jesus Christ.
Okay, so what space? Okay, well, how about this? Right? Then therefore you have to presume that this form is in a non-Euclidean space in the first place. Did it specify that, sir? Or is it in
you don't, because it's saying it's not a triangle.
Or is it already natively in Euclidean space and has a curved line?
That's an assumption you're making.
Yeah, well, that's the whole point. So it didn't specify anything, right? And when that happens, it's assumed or taken at face value that it's in regular Euclidean space.
No,
right?
We don't. We can just take it the simplest form.
Okay,
we're just
so you have
answering
to-
it in the most.
Okay, so you have to assume. You have to assume, therefore, that basically anything is almost a triangle in any form or space after manipulating it, you get a triangle. That's what you're taking then. So therefore, for all we know,
if there was four sides, it wouldn't be a triangle.
For all we know, right? With that logic, for all we know, fucking A is a triangle too, because there's a fourth dimension that one of those lines is warping into, and you can't see it. But once you manipulate it back into Euclidean space and kind of correct for it a bit, then you have a triangle again.
Okay.
Yep.
You can make that claim.
Dude, the whole point is fucking stupid then. No, dude, I'm not. No, of course not.
Welcome.
You're introducing caveats that were not there.
No, we're not. You are.
Yeah, no, you are.
You're the one who's saying which ones are triangles. Again, you asked the second question. The second question is which ones are triangles. It's a separate question.
It's not going to happen. It's not going to happen like this. You're assuming
it's not going to happen like this. It's as simple as this. The correct answer was D. The correct answer was B and D. You got it wrong. Simple. It's as simple as that.
That is incorrect.
No, it's not. No, they're not. The correct answer is B and D are not triangles. Sorry.
For elementary school students. Yes.
No, I don't care. I don't care what else you add. You got it wrong. You failed.
Okay.
You failed the triangle test. You don't know what a triangle is.
Yeah, dude, it's an elementary
I would really call that a triangle.
And you're unwilling to learn what one is, too.
Yeah, dude,
the more you dive into any topic, you find that everything is shades of gray, right? There's no object like right or wrong. The more you learn about the topic.
You got it wrong, bro. Get over it and move the fuck on.
Yeah, no, Josh, like you're not in this. Shut the fuck up. Okay, Colin, you failed the fucking test. Period. End of story. All right, you thought too far ahead. You thought you looked into it more than you had to. It was an elementary question, required an elementary answer, and you fucked up.
I didn't though. You're the one who had to ask. You're the one who moved the goalposts after we determined that B is generally a triangle.
The goalposts were laid in the question. Read the question again, please.
Which of the figures below are not triangles?
Mm-hmm. Right.
Okay. D. It's not a triangle. We all agree that D is not a triangle because it's not. It doesn't have 3 points. It's just a line that's bent twice. Okay.
Right.
So C is a triangle because it's got 3 points that are all connected. Correct. On 3 lines.
And all the lines shit. And all the lines
not triangle.
And
the simplest form of a triangle.
You motherfucker. You fucking piece of shit.
Yep, you're fucking cooked. You're cooked. You're exposed. I exposed you with the triangle test.
No,
you're
he's a fucking retard. He's thinking too far ahead. Can't listen to basic questions and answer with basic answers.
Well, look, the Board of Education states the correct answer. They've at least approved of the correct answer, right? Because this would have been presented at some point, and maybe even still, to students in a classroom, right? And there's a correct answer. Now, if they say that B is not a triangle, right, that's the answer they're looking for. That's the correct answer. When they, after the student answers the question and they compare it with the correct answer, they're going to find that if they didn't answer B, they were incorrect. If they answered B, they were correct. And it also tells you why B is not a triangle. It tells you why. I wonder if Talon knows why B is not a triangle.
You can unmute him if you want to talk to him.
You can tell us why B is a triangle.
So I can agree that B is not a true triangle because it has to have 3 angles. But in terms of just having 3 points, I'm determining that as far as what are triangles and what are not triangles, I'm applying judgment to A, B, and C equally. So in that respect, they all have 3 sides and 3 points. And so it's just an indirect triangle versus a Euclidean triangle, which is a geometric shape. That's the one that has 3 angles. And you'd have to do something, and you'd have to treat B as a different type of triangle, that you wouldn't use the same math as a regular triangle.
Yep. Thanks for your concession, dude.
Again, I said that a curvilinear triangle is still a triangle. So geometrically speaking, it's a different form of triangle.
So not a triangle unless you manipulate it, right?
Exactly. It said that in the definition of what he gave us earlier, that it is not a triangle. It says it right there, not a triangle in the traditional sense, if I remember correctly.
Why isn't B a triangle?
Again, that is a reductive.
All right. Why doesn't B have 3 angles?
What kind of triangle are you talking about? Euclidean?
Why doesn't B have 3 angles? I'm going to ask you three. You're going to get 3 attempts to answer it. If you don't, you're staying on mute.
It does have 3 angles.
Right, you're staying on mute. Because the correct answer is B is not a triangle, and it gives a reason. So the Board of Education approved the correct answer as being B, not a triangle, because it doesn't have 3 straight sides. And also, it doesn't have 3 angles as a consequence. And it doesn't have 3 angles because one of the lines is curved, therefore it only has 1 angle that you could measure in that shape. That was the correct answer. That's what you should have said to me. Not go on with all your bullshit about different types of triangles that aren't triangles because they don't qualify as the definition of one. But you still want to call them triangles. It's dumb. You can't even get the basic right, and you want to talk about advanced geometry. You can't even get the basic fucking shit right. I don't know, Mansky. Maybe you should take over for him. If you answer the triangle test correctly, then maybe you can fill his place and represent his argument for him about the trigonometry used in India.
They need some money, man.
We're up against NASA, exactly. It's an easy win for Flat Earth.
But you're losing though. You're losing though. I'm rooting for you. I'm rooting for you.
Why? What was the winning argument? What was the winning argument against us?
No. I just mean the fact that obviously.
No. I don't mean that the Globe is actually presenting a winning argument. Yeah, of course, because they've already lost.
No. I was just talking about how like you guys have done these measurements that I clearly haven't. So you've won this argument. But I mean the greater battle.
In general, no, that's the case. That's not with you we're talking about. No one has ever measured curvature, and we've measured no curvature. So I mean, it's
but I'm saying isn't the fight really to convince the world?
There's no fight. There's no fight.
No. It's to convince you that you can trust your own eyes, that the world actually is the way it appears, and it's not a product of your imagination. That the Earth
So this fight
that the Earth looks flat because it actually is flat, not because it's a ball that's too big to see, but because it actually is flat. I know it's hard to believe. It's so crazy.
No, it's not. It's not.
And also,
It really
hold on, to
isn't.
add to Indio's point, it's also to point out that you do have hands. Okay? You should understand.
I do. That for me, that's the leading theory. But if someone could prove to me that I was in the Matrix and they could prove it to me, then I'd be like, oh, I was wrong. Then maybe I'm.
Well, I mean, they could be a product of your imagination too, right?
Hands are downgraded from biology to the leading theory.
Everything is the leading theory, yeah, man. In science,
that's no way to say. That's not science. That's not science. Science is not. Oh, we don't know if we have hands. Come on, dude, stop it.
We believe we do. You could be in the Matrix right now.
We have hands. No, believing you have hands is not science. Stop it, dude.
Right. So you could be in the Matrix. You could be in the Matrix, bro.
You could be in the exactly.
Earth is flat, right? Yeah, you could be in the Matrix where the Earth is flat, bro. See how that works?
Take the red pill.
What red pill?
That's crazy. This is crazy.
No, but you guys completely reject like the philosophy of science that like we can't be certain. Really?
You mean no? You're talking about a particular part of the philosophy of science, meaning inference, inductive science. That's garbage. It's total garbage.
Dude, you are fucking retarded. You have no idea what you're saying.
Faggot,
black ass faggot.
Whoa, they're freaking out.
God's watching you, bro. God's watching you, man.
I think they're talking about the Blitzian model.
So Xavier, here's the problem with inductive science. You can't actually say you know anything.
Exactly.
And this is where you are right now. You're saying, I'm not sure if I have hands.
Yeah, I believe I do, but I'm open to being proven wrong. Is the whole point? Yeah.
Don't you understand that what would you call it? That presupposition, that presupposed worldview, is doomed to failure because we actually do know things. Okay, so check it out. What's your favorite color?
Blue, sapphire blue.
Are you sure? Are you sure it's your favorite color?
No, I'm not. But that's my leading theory. That's my
It's your favorite color, right? So there's some things you do know about yourself, right?
Well, I said that's my leading theory, but and it wasn't always. In fact, it was only until recently. Only until recently did I realize that royal blue wasn't my favorite, and I prefer sapphire blue. It just has like this extra kind of like. Aura about it,
This is where it all falls apart for you 99%ers. So you're 99%. You're only 99% sure that you have hands, right? 99.99999%, right? You're not completely sure.
Something like that.
Okay. Are you sure of that? Are you?
Gone out and gone seeking empirical evidence for. It's just something they take as a given because they probably never heard proper flat Earth arguments. They've never seen the long distance observations. They've never questioned the globe. When they go to their advanced university classes, right, to get these very specific degrees about a specific area of a topic, they're just basically regurgitating the information from the textbooks, memorizing it, and then parroting it down onto their exams to get the results, not questioning the core foundations of that information, if you know what I mean.
Yeah. I imagine they did some kind of experiments to see like how gravity functions of Earth, and it functions the way it is because of the curvature of the Earth.
Or they referred to someone else's experiments, which is more realistic.
Yeah, they also make a bunch of assumptions, right? They already presume certain things. So when they're talking about gravity, they'll be like, look, this we've got a vacuum chamber here, and we drop some things in the vacuum chamber. They roughly fall at the same rate due to gravity, right? And that's proof of gravity. It's kind of like circular reasoning in a way, or begging the question, because they're saying the cause of this effect that we're observing is gravity, but there actually is no scientific experiment that proves that gravity is actually the cause of the effect. They're only able to see an effect, right? Even scientists at the high levels will say that. They'll say, we have no idea what gravity is. Where does gravity come from? We have no idea. We just, it has to be there to have this globe Earth heliocentric model that we live in. So we know it must be there because we know that the Earth's a globe.
It seems to me like there can't be anything that you can know 100% for certainty.
Well, this is what we can do. This is what we can. Yes, sorry, Shaggy. One thing, I'll go on mute in a second. So, things we can know is things that we can physically measure, right? Things that we can repeat the measurements over and over again. So, if the Earth's a globe, then there would have to be certain characteristics within nature that would have to be present. Okay, so they tell us that over 70% of the globe is covered in water. So that's a great place to test for curvature, because due to gravity, the water would have to be curving at a specific rate. So if we go find a 10-mile body of water anywhere on the Earth, ocean, lake, whatever, okay, we can calculate over this 10-mile distance, there would have to be approximately 66 foot of curvature based off the globe math, okay, the radius value. So we can go and start conducting different tests, because along with the Earth curvature comes byproducts of the Earth curvature, such as a geometric horizon and obstruction of things in the distance. So if you set up an optical device like a camera or a telescope at a certain height, say it's 1 foot above the surface of the water, and you're looking across to a distance marker 10 miles away. Okay, so you've got an oil platform out in the ocean or a long lake where you've got the shoreline 10 miles away in the distance. From 1 foot observer height, the horizon, right, the geometric cutoff point of the globe would be at 1.2 miles away. And then you can calculate how much the target in the distance should be hidden behind the curvature of the Earth. Okay, so you can determine that, say, the shoreline on the other side of the lake would be hidden by about 50 foot. Okay, that's like a 5-story building. Now we go out and conduct tests using high-powered lasers, high-powered zoom cameras, infrared cameras. It's been done over and over again, and we can zoom in across from 1 foot observer height. We don't see that horizon at 1.2 miles where it would have to be, and we can see the shoreline on the other side of the lake. Okay, then we go and repeat it, and repeat it, and repeat it. Go to a 20-mile lake, go to a 30-mile lake. Use different spectrum laser beams and just keep repeating, and we can't find any curvature.
What's the largest body of water in the world?
Probably, I don't know, the ocean. The ocean's like the Pacific Ocean and whatnot. But we don't need that much distance. When you have too much distance, we start having to deal with all kinds of crazy optical effects due to pockets of different temperatures and things like that. And then you've got the visibility, because the air is not perfectly transparent. It's semi-transparent because we've got dust and pollution and gas and fog and mist and all kinds of things in the air. So it has a limitation on how far you can see through it. So under optimal conditions, like perfect conditions, it would be 200 miles or 300 kilometers. I think it's that, or 300 miles, one of the two. That's like just technically under perfect conditions. Usually if you go check the weather report, like what's the visibility rating where I'm at, like where I'm at here, it's about 15 kilometers, so 10 miles or something like that. So it's really not that far. That's the maximum distance you can see. Anything that goes beyond that's just going to kind of fade off into the atmosphere. Kind of like when you stand up on a big mountain and you can look out over mountain ranges. Yeah. Each one that's further away gets more opaque.
Yes.
Yeah, so it's that, and also things in the distance get smaller as they move away from you. So you've got the angular resolution limitation to worry about then. So, I mean, if you've got a cruise ship, say there's a cruise ship in front of you and you're standing at the beach and it starts to sail away from you, it's going to get smaller and smaller and smaller until it gets below 0.02 degrees in size, right? Angular size. And then the human eye can't resolve it anymore. Okay, you can pull out a zoom camera and zoom it back in again, but eventually it's going to fade off into the into the opacity, the opaqueness of the air.
So you said that we can't really see the curvature because there's pollution, there's like if you go very far, it will be difficult for you to see, and even with cameras, it's not as accurate.
Not really. We could see if there was curvature there, we can see like more than enough distance to be able to detect that curvature, right? So over 20 miles, there should be 266 foot of curvature.
What about using the satellite?
Well, now you're going into the realm of things that you can't validate. Okay, so satellites don't have like photo cameras on them, for starters, and you can't validate. Like, you'll have to trust the satellite information. It's not something you can go validate. What's easy for you?
GPS?
GPS is just, you're just getting information from a ground tower onto your phone. Okay, and you're not able to determine exactly whether that's like where that's coming from. If someone wants to say that's coming from a satellite that's in outer space, you're not ever going to be able to verify that information. Okay, it's just converting that information that you're getting on your phone into a coordinate system, into a particular coordinate system. Okay, you could transfer that data into any coordinate system, and it's going to work. It's going to get you where you need to go. It's not reliant on the Earth being a globe.
Okay, so let's assume that the Earth is flat. Okay, what's the edge of the Earth? Like, which part or country that lies?
I should have covered that first. So when people think about flat Earth, usually they have like a complete misconception of what flat earthers are claiming. People think of the globe Earth version of outer space, right? Like the space vacuum, and then you've got all the round planets and balls of gas like stars and whatnot floating around in the vacuum, and then the Earth is one of those. Okay, and then they, in their mind, they kind of swap out the globe for a flat disk or a flat planet. That's not what flat earthers are claiming. That would be ridiculous if that's what we were claiming. You got to erase the heliocentric model from your brain to think about this new way of looking at it. Okay, so you could think of the Earth more like the floor or the foundation of the system that we live in. Okay, so the Earth isn't moving, right? The Earth is like a topographical plane, right? Like we have hills and valleys and mountains, but most of the surface is covered in water, which is measured flat across the surface. And then we would be within an enclosed system, just like all the ancient cultures depicted. So a stationary Earth within an enclosed system. Yeah.
Yeah. What does that mean?
Well, have a look at what Shaggy posted in the side chat, right? That's not what flat earthers are claiming. But when you Google flat Earth and hit images, it's going to come up with a bunch of images like this. Okay, to try to, this is like propaganda to make flat Earth seem ridiculous and stupid, because if this is what we were claiming, that wouldn't work. That would mean that we were idiots, basically. So what we mean by flat Earth is like flat or smooth or bumpy, that kind of thing, is the description of a surface area. So in this context, we mean the surface of the Earth, primarily the surface of large bodies of water, isn't curving over distance as it would have to if the Earth were a globe. We're not claiming to know the shape of the Earth or where the Earth ends or anything like that. We're talking about what we can empirically test. Okay, so flat Earth is completely different to what it means to say globe Earth, right? Because that's a shape claim and whatnot. It comes along with a whole heliocentric model. But we're not claiming that. We're not claiming to have a counter response to every single claim the globe side makes. We're saying, look, we're testing the globe. We're testing what we all kind of blindly believed from a young age. And it doesn't match up when we test it in reality. And we're repeating the tests over and over again. And this is not, it's not something that's just random people going out and doing. We've had PhDs go out to try to debunk flat Earth, right? PhDs in optics using extremely expensive, high-powered laser equipment, different spectrum laser beams, infrared photography, all sorts of different things. And a lot of these people have been forced to become flat earthers in the process because they couldn't find any sign of curvature whatsoever. So there's tons of stuff. This is all documented. We can present all of these long distance observations and laser tests that we're talking about. And the good thing about this is it doesn't require you to believe it, right? Anyone can go out and actually repeat these tests themselves.
It's interesting. I mean, I definitely heard some people in the past, like maybe 300 years ago, who believed the Earth to be flat, and our solar system is different. All the other planets circle around Earth instead of the sun. And
yeah, man. Well, if you'd like us to, present some observations like what DJ just stated about long distance observations, then we can present you with them.
I can give you a quick example of one if you want to see one.
Sure, of course.
Can you see the side chat?
Wait, yeah, I can see it.
Yeah, okay, I'll just... okay, so what I'm going to post in the side chat, it's an observation that was done in the United Kingdom by a guy named Dr. John Dee. He's a PhD, and he actually went out originally to try to debunk flat earthers. So he does a bunch of long distance observations using super zoom cameras, and he does long distance laser tests with different spectrums of light, trying to basically do the same thing, shoot the laser across the surface of the water to hit a target on the other side. So this is one of his observations. So this is just some clips and screenshots pulled from his video. His video is really comprehensive, but it's an hour and a half long. So I'll post the video after as well.
Yeah.
Yeah, I'll send that as well. But just to give you a breakdown quickly. So here's a GIF, right? So what he's done here, he's gone to the ocean on a really, really calm day where there's no waves and really good weather conditions with good visibility. And he set his camera up on a tripod, just 3.5 foot above the surface of the water. And he's looking out into the ocean. Okay, so if you were just looking out into the ocean and you didn't have any kind of distance markers, you would have no idea how far you're seeing.
Yes.
Okay, so he's gone to a place where there's a wind farm out in the ocean. It's called Rampion Wind Farm. Okay, and it has this section of the wind farm that he's zooming into. It has 6 windmills. The windmill on the left, when he zooms in, is 8 miles away. And the windmill on the right is 11.2 miles away.
And what's the building behind them?
The building, it's not a building, it's actually a boat. Yeah, there's actually a boat out there, which he tracked on the ship tracking radar that's 14 miles away. But you shouldn't be able to see the boat at all. It should be way behind the curvature of the Earth. But don't worry about the boat just at the moment, because the wind farms are the main focus at the moment. So now, if you go onto Google and you type in Earth curvature calculator, there's tons and tons of different calculators. They're all going to give you the same result. And what they do is they're going to calculate how far away the horizon should be from a certain observer height and how much things in the distance should be obstructed behind the horizon. Okay, so you can do the math yourself if you want, but that's just an easier way of doing it. So here's a screenshot from just one of the random Earth curvature calculators. Okay, so the distance website. So the distance to the object, 11.2 miles, right? So that's the windmill tower on the right. Okay, so I put that in, and then I put in the eye height level, 3.5 foot. And then it calculates the distance to the horizon, okay? So the distance to the horizon would be 2.29 miles. Okay, that's the key thing to note, because that's what this test is testing for, that geometric horizon. Okay, so here's a diagram he made from his video, just to illustrate like what.
Can you also send the link?
Yeah, I will send the link. Okay, so as soon as I finish doing this little presentation, I'll drop the full link in. But it's an hour and a half video, right? He goes into everything in extreme detail. You can go check that out after if you want to double check what I'm saying. But I'm just giving you just a basic breakdown of it.
Yeah, it is definitely interesting.
Yeah, so look, a man standing on a sphere would observe the physical geometric horizon at a certain distance, which on this diagram is represented by the red and yellow circle. Okay, so you shouldn't be able to see any water past the geometric horizon cutoff point. Okay, and that
just
distance
like 7
would
kilometers.
Well, it's based off the height of the observer. So if you do it from 1 foot height, that cutoff point would be 1.2 miles. If you do it from 6 foot height, then the cutoff point would be 3 miles, and so on. Okay, so it's going to go further away as you go higher in height. But from this height, it's 3.5 foot. So the cutoff point, right, the geometric horizon line, should be at, what would it say, 2.29 miles. Okay, so you shouldn't be able to see any water beyond that point. And then the bottom of the windmills should be cut off behind that horizon. And the bottom 52 feet of the 11.2 mile windmill tower should be cut off. Okay, so here's a close-up of the windmills that you can see in the observation, just so you can see what they look like close up. Okay, so he did this at low tide, because when it's low tide, you can see that little black section at the bottom where it's corroded the paint off. Okay, so here is a screenshot just from the observation, just for comparison. So yeah, we can see the base of the windmills touching the water, and then we can see the water carrying on past the windmills, and you can actually see that boat 14 miles away as well. So we're not seeing the curvature that would have to be there if the Earth were a globe, right? Remember, over 10 miles, you should have 66 foot of curvature. So based off the 3.5 foot observation height, the geometric horizon should be at 2.3 miles away. And then the bottom 52 feet should be missing off the furthest oil platform. And I think about 30 foot off the closest oil platform. But we're not seeing these geometric features that would have to be there if the Earth were a globe. Okay, so he goes out and he does this observation on different days as well, different weather conditions, different observer heights, different locations as well. And then we've got people that have done these in different places all over the world, whether it be on a frozen lake in Canada or a lake in, all different places, right? United States, California coastline, Great Salt Lake in Utah. We've got even longer observations than this, where we could see like 20 miles across a lake and see the shoreline on the other side of the lake, where there should be hundreds of feet of curvature obstructing that shoreline. So this is where we're coming from. It's like just going out and actually testing the globe mathematics, and we can't find any curvature. And then that gets us to the next question, is right, so surely someone throughout all of history has gone out and surely there would be tons of observations that would counter these observations and match up with the globe. And that's where it starts to get interesting, because you're not going to find a single one. What you're going to find is calculations based off assumptions. And that's essentially what you're going to realize over time, if you look into it, that's what the globe is, right? It was a theorized way of depicting the Earth based off the celestial sphere originally. And then they assumed that because of the way that we view the celestial bodies, then the Earth must also be like that. And they basically inverted the celestial sphere into the terrestrial sphere. That's a whole other conversation. I don't want to get too confusing. But basically, look, this is what it comes down to. We can't find any motion of the Earth, right? So the Earth is meant to be spinning at 1,040 miles per hour at the equator. And then at the same time, it's orbiting around the sun at 66,000 miles per hour. And then it's also going in a different direction, chasing the sun at 480,000 miles per hour. And then it goes even higher from there, right? Then the whole system's going sideways, orbiting around the great attractor at 1.3 million miles per hour. It adds up to millions of miles per hour of movement that they say that the Earth is making constantly. Okay, so that can't be validated, and then we can't validate that there's any curvature. Okay, so no motion, no curvature, and then the third one would be that we have gas pressure. And then that's a whole different conversation as well.
I was going to say that. Let's not go into gas pressure just yet.
No. Just throwing it out there. But yeah, that's a whole nother conversation that you'd have to go to in detail, to go into gas laws and thermodynamics and all that kind of thing.
I guess to be fair, you have to acknowledge that everything is almost everything holds some kind of assumption. Like you can't not have any assumptions.
Yeah, but we can test those assumptions. If someone's assuming that the Earth is a ball, then we go test and we can't find any evidence of that ball existing at all. Then, you know, we can kind of like dismiss that assumption in a sense.
Yeah. We appreciate your honesty, man.
Mm-hmm.
Yeah. It's a lot. It's a lot of information. And
yeah. I'll post that full video. I forgot. If you want to check it out later, because he does go in, because he's got a PhD in optics, so he goes into all of the extremely technical details about, you know, the atmosphere and whatnot.
What prompted you to research or investigate this kind of issue or discrepancy, I guess you could say?
Yeah, it was someone that I respected a lot. Started telling me about it. You know, I thought that they'd lost their mind, but I knew that they were a very, very intelligent, like, critical thinker. And they recommended some videos to watch. You know, I still thought that they'd lost their mind, but out of respect for them, I decided, okay, I'm going to go watch these videos that he's like, just check them out, see what you think, you know, critically analyze them. And I was like, damn, there's a lot of good points being made, right? It's kind of like similar to the points that I'm making now when it comes to being able to see too far and lack of empirical evidence of the primary claims of the globe and that kind of thing. And from there, yeah, I started sort of researching and actually learning more about the globe, because most people, you know, they just kind of believe that the Earth's a globe and they know a little bit, but they don't know much of the technical information. So I did a whole bunch of research into that. And then I started looking for evidence. I was trying to prove the globe and prove this guy wrong. And then I couldn't do that. So then I'm like, damn, I'm going to have to go out and start doing some observations myself now. And luckily, like, I lived on a giant lake in Australia called Lake Macquarie, and I had a boat, and I bought a camera, and I did stacks of different observations. And we had like a 20-kilometer stretch of water across the lake, and yeah, I could confirm that I could never find any sign of curvature whatsoever. I could set the camera up basically at any height and zoom across the lake and see the white sand shoreline on the other side. And and then, you know, after that, it's just, there's unlimited research to do. Like, it's just, there's so much to learn. You know, you start getting into how optics work and how the human eye works and how light moves through a medium and how temperature can affect different things that you're looking at in the distance. You need to learn all about miraging and gas pressure and all sorts of different things, right? So that's kind of how I got into it. Here's the video in the side chat. He's got some other good stuff on his channel as well, like the laser tests I was talking about. This, you know, that's another great way of doing it. Like, we've literally had teams of field engineers go out with a $30,000 laser, and instead of doing the observation, they're actually shooting the laser beam directly across the surface of the water and trying to hit a target on the other side of the body of water, like, say, I think they were doing them up to about 40 kilometers, where there should be many hundreds of feet of curvature. Okay, so if you shoot that laser beam horizontally, if the Earth were a globe, the people at the target distance should see the laser beam right up in the air, hundreds of feet up in the air, because of the, you know, the drop over distance.
Right.
But the laser beams are hitting the targets every single time. Okay, so say you shoot the laser beam from 5 foot height, and then you have a target at 5 foot height on the other side. It's hitting the target at 5 foot height. And then, so they have an hour-long documentary and a 180-page PDF document where they go over all of the technical details and all of the specifications of the laser and all of that sort of thing, right, to present their experiment or test, whatever you want to call it. So yeah, tons of this stuff's been done.
Is it possible that the distance was not long enough, so that's why you don't see it above the ground?
Well, no, because with the globe you have a radius value, right, which is 3959 miles. Okay, so it's slightly bigger around the equator than it is pole to pole. But it's such a small difference that when they're calculating drop over distance, they just use the average, which is the 3959 mile radius. So you can calculate, right? You can go on a ChatGPT, anything like that, and say, look, how much curvature would there be over 40 kilometers? Okay, it's a geometric calculation. It's not something that can be, argued over. It's just based off the geometry of the globe. That's why we're doing it over large bodies of water, because they call it mean sea level, right? Because it's level. It's a level surface. So look, I'll put it into the calculator right now. Okay, 40 kilometers. Eye height level 5 foot. And right, so yeah, over 40 kilometers, there would be 395 foot of drop over that distance. So 395 foot, that's like a 40-story skyscraper building, 39-story skyscraper building. Huge amount of drop over distance over that distance.
Yeah, and one thing we want you to know is we don't want you to come here and just believe us out of faith.
Yeah.
Sorry.
I will research this.
Yeah,
Definitely.
we want you to read, because, like your previous question, what made you look into this harder is because you owe it to yourself to know, the realm you live on. If there's a possibility of a lie, wouldn't you like to debunk that? Like, if there's any slight possibility, wouldn't you like to go, hang on, I want to know the truth. So, like, dig into this, man. Like, look harder and go, these flat earthers could be lying. I'm going to prove them wrong. You try and prove us wrong. Go ahead. We challenge you. Yeah, man.
What do you think the value of knowing this, what you know, that the earth is flat, like, did it serve any kind of value to you? Was it valuable to know the earth is flat?
It was. I think it's valuable. I think knowing where you live is pretty important. And I think I think it's important to wake up that critical thinking ability that we all have, because I think in these modern times, people have kind of been put into a mindset where they put aside that critical thinking ability, and they've been taught to just believe that they're not scientists. I'm not a scientist. I'm not smart enough. I'll just trust in what I get told at school. And they've basically made it that if you go against any of the core fundamentals, then you're a science denier, you're a tinfoil hat wearing conspiracy theorist, blah, blah, blah. And they've made it very unpopular for people to go against the grain or against the mainstream. So I think it's very important to know where we live. It goes extremely deep as well once you start digging into, it's a big difference whether you live in a, on a space ball flying through space, right? Where they teach this is what they teach in the mainstream accident, right? The Big Bang happened, right? The heliocentric model was basically banged into existence, and then we have evolution, right? And basically what it stems down to is that we're here by accident, and we're on a big baseball inside a vacuum, hurtling through space at 1.5 million miles an hour. We're tiny little specks on this baseball on a universal scale, right? Like tiny little specks of nothing, here by accident, lost in space, going nowhere for no reason at all, on a temporary Earth, right? That could at any moment just get killed by a giant asteroid like the dinosaurs, and one day the sun's going to burn out, and right, that's kind of what we're told is our existence. Whereas if it's much different if it's a flat Earth system, completely different, right? It would lead way to there being some kind of specific designer. I'm not saying that's God or anything like that. I'm not, I don't bring religion or anything like that into this, but it's just a completely different way of looking at this whole place that we're in. I don't know. I think it's important to know where we live. But it's different. Like, it's more meaningful for some people and less meaningful for other people. It's not going to completely change your life. You still have to go to work and do all of those kinds of things. But it definitely steers the way that you think and the way that you perceive this reality that we live in, and the research that you'll do in the future, and the way that you'll live your life, that kind of thing.
It kind of reminds me of if reality is a simulation or not. Some people say it doesn't matter if it is, or if it's not. You still have to wake up in the morning and go to work.
Yeah, exactly. So that still has to be done.
Yeah, but you're going to work, at least you know why you're going to work. What you're going to work on. You're going to work on a creation. I'm not referring to a god. I'm referring to this realm has been created by something or someone or some others. We don't know. We can only speculate. We can only try and find out the truth. But the point of the matter is, if it's not just a coincidence flying through the cosmos at stupid speeds, then it's stationary and it's flat as observed, and it's created because
it's going to lead to a lot more questions. A lot, you're gonna go deep. Can't wait till you can get home from work and do some more research, that kind of thing. It will lead you down other rabbit holes as well, like looking into history. Right, and then you might start finding that, okay, there's actually a lot of deception as well when it comes to mainstream history and what happened in the past. Okay, so and then after a time, you'll start to notice that it's kind of all connected, and it is definitely an interesting rabbit hole to go down. That's for sure.
Hey everyone.
Hey, what's up, man?
I'm great, bro.
Good.
So, are you flat earther or something?
There's a mixture of people in here.
Okay. I'm also flat earther, I guess. Yeah.
Oh, nice.
Mm-hmm.
Yeah. What is it? Yeah. Go ahead.
Go ahead.
Dexter.
What?
Well, someone just was.
Yeah, it was me. All-Star.
Yeah. All-Star. Yeah. Cool.
Yeah, I was going to say, if you think that other planets are similar to Earth, like in shape and in environment and things like that, or Earth is just special and there's only one of a kind of its, like, the environment.
No, that's a good question. So that sort of goes back into the first thing that I was talking about, where people try to kind of insert the flat Earth into the heliocentric space vacuum model that we have been taught that we live in. And they've told us big stories about the planets and stars and things like that they're these huge distances away, and they're giant, like, balls of gas or gas planets or whatnot, right, in a space vacuum. And people say other planets, kind of insinuating that we're also similar to these things that we can see in the sky. Whereas in reality, if you throw away that story that you've been told about what we see in the sky, what we see is a series of essentially lights in the sky that move in cycles, right? Like, all the stars will move in a particular cycle, and then they'll reset back into the same position each year. It's kind of like the sky is like a big cosmic clock, so to speak. And we tend not to make claims about things that we can't empirically validate. Like, what are the stars? What medium are the stars in? What size are the stars? That kind of thing. We try not to get into that, but everyone sees the same thing in the sky. So if you look through a telescope and you see a blurry little light in the sky, you've been fed a huge story about what that is and how far away it is. We can't validate that, but what we can validate is that the Earth shares no similarities to the things that we're seeing in the sky. Okay, so say we see the moon, kind of looks like a half a sphere, That's kind of what we see. It would be logical
earlier
to say
I took a picture of the moon, and it looks like it doesn't look like a circle. It looks
it looks spherical. It looks like half a sphere kind of thing. But then again, it's kind of difficult to say 100% exactly what it is. Okay, so there were scientists in the 60s that were speculating that the moon is actually made of plasma. I'm not saying that I agree with that. I'm just saying that was a big, speculation, along some mainstream scientists back then. And he said no one would ever be able to land on the moon. That's ridiculous. That's impossible. That will never happen. And that kind of thing. So I think there's a lot of mysteries behind the moon, but I agree with you that when we look up at it, it looks kind of like a half a sphere. So does the Earth share any similarities to that? Okay, and when we observe the Earth, when we measure or take long distance observations and laser tests, it doesn't have any signs whatsoever that it is spherical or anything like any of the things that we see in the sky. Okay, kind of like if you've got a flat floor and you have round lights on your ceiling, that doesn't mean that your floor is also round. Okay, it's only because we've been taught this heliocentric model that we think, we're also floating around in space like these other things that we've been taught about. Whereas I think you could more think of the surface of the Earth like the floor or the foundation of this system that we live in, and then we've got other things in the sky. Okay, we don't go out into the forest and see trees everywhere and say, I must also be a tree. That would be silly logic. So I understand the logic, right, because of the way that we've been fed the globe model. Okay, so it's understandable that people will say, what about the other planets? It's a good question. But I think this is a completely different way of looking at it. And if we want to think, are we like any of those things we see in the sky? What evidence is there for that? And there isn't any.
Yeah. And if you look at the post I just posted, then you can see that you can't assume, the shape of something with such a vast distance.
Yes, good point, Shaggy. Yeah. Any light, right? Any shaped light at a distance looks like a round light. You look at a tube light or a street light, which is like a long, like tubular like light in the distance, it just looks like a round light. You look at a train coming that has a series of lights on the front of it. In the distance, it just looks like one round light, but once it gets close, you'll see, actually it's 6 lights. So with the stars, we have no idea what we're looking at. Could be anything, because at a huge distance,
You're right. When you zoom, you get more clarity, and now we
stars.
Now we have telescopes that are very strong that you can zoom a lot into the object.
But exactly, but it's a light, right? So when you're zooming into stars, right, you still just see the magnification of the same thing. You're not zooming in; you're just magnifying. That's all you're doing. Yeah. So we don't know exactly what we're looking at when it comes to stars. But hey, have a look at this example in the side chat here.
May I make a quick point? Yep. Like they say we can zoom into distant planets that are millions of miles away, and yet we can't zoom in on the flag on the moon, on the American flag.
I don't think that was true.
That is true.
Yeah, no one can put a telescope in their backyard and zoom in on the American flag, and yet you can zoom
on
in
the moon.
Yeah, exactly right.
They might say the aliens took it.
James Webb parked in your backyard, you still wouldn't have the zoom capabilities to see a poxy little flag.
Anything left on the moon.
Let me just show this example quickly. See the 4 objects in the side chat there.
Which one?
I just posted them in the side chat. 4 red objects.
Yeah.
Okay, only one of those is a sphere. Okay, so let's just say you were looking up in the sky and you can see these 4 objects. Kind of looks like 4 balls, right? It looks like 4 balls.
It does.
And, okay, so one of them's flat. One of them's a bowl, right? One of them you're looking at a bowl. One of them's half a sphere and one of them's a sphere. And you can't even tell by looking at this which one is which. They all just look like balls from a distance. Now, if I show you the actual GIF of this test, right, you'll see the lady,
Maybe we'll be able to notice the texture of the sphere.
Okay, so which one of these is the sphere? You'd
The
have to
third
guess.
one. The third one from the left.
Yeah, that's incorrect.
Yeah, I've already put the GIF up, just so you know.
You did?
Yeah.
Oh, yeah. Okay, Shaggy, if you just scroll up a bit to 25 minutes after the hour, yeah, you'll see which one's which.
Oh, it's a video.
Yeah, it's like a GIF. GIF's a video. But yeah, see, we can't tell exactly.
You're right.
Yeah. Look, the only point of this is just to say that, like, we can't make definitive claims about things that look a certain way because we've been told a backstory about it. So if you get told a backstory, like if I told you these are all spheres, but they're at different distances, and can you tell which one's bigger than the other sphere? Right? You would already have in your mind that they're all spheres, and you wouldn't even be questioning that they're spheres. And then you would try to work out which one's further away and which one's bigger and which one's smaller. So I was like, we need to question what are they in the first place, and we can't tell unless we can actually empirically validate that. So you'll see in the GIF, she empirically validates it by lifting them up and physically inspecting them. So the whole point is, there's a lot of speculation when it comes to things that we're looking at in the distance. That's all. Can't be completely sure when it comes to things in the sky that we can't access. We have to basically trust the mainstream narrative or not trust the mainstream narrative when it comes to that kind of thing. What we can all test is surface curvature. That's something anyone can go out and test. So that's the prerequisite, the requirement for the Earth to be a globe. That curvature has to be there, and it's not there. So all of the additional claims, they need that pre-requirement to be validated in the first place. And if you look into it, it's not even claimed to have been measured empirically in the first place. It's based purely on assumptions and mathematics and models rather than empirical evidence.
Okay, so let's take a moment because we know that people went into space, right? So they had to calculate things like the air pressure, the gravity, and all those things. If they are basing their information on a curved or a globe Earth, then but the Earth was actually flat, then there would be a mistake, or the rocket wouldn't fly into space because there's a mistake in the calculation.
Correct.
But people have went into space. That must mean the scientists are correctly calculating all those things that you need to know before going into space.
Yeah. Yeah, if that were the case, maybe America faked the moon landing.
Right.
Look at
That's the question.
have you really? Most people haven't looked at the footage that they've been presented from the Apollo missions, right? Remember, I said earlier, only 26 people have ever said to have gone to above low Earth orbit to space, right? High enough to see the curvature of the Earth. That's the Apollo astronauts. The same ones from this footage here. That's clearly like ridiculously fake looking footage.
Right.
The last one you sent?
Yeah, I'll post a bunch of these are all taken from NASA's YouTube channel. Okay, this is Apollo footage. Apollo 11 footage.
Looks like I'm watching Star Trek.
It's worse, dude. If they used this footage in Star Trek, no one would have watched Star Trek. This is like Thunderbirds footage. Okay, so I'll post a few more clips.
You're gonna blow his mind, DJ. You're really gonna blow his mind up.
Well, most people haven't looked at the footage. The footage is just laughable footage. Maybe it looked cool back in the 70s, people were like, "Whoa, that's amazing!" But now it's kind of like looking at a video game from 1995, and you're like, "Oh my god." Right, just look at the movement of these things as well. Like, I would speculate that this is probably more like miniatures and models on strings in a studio, right? Like a animation type setup with a very large budget like they had, rather than actual footage of a spaceship, that looks... The spaceship itself looks kind of like a grade 6 science project where they're like, all right, kids, you need to make a spaceship. Here's some tinfoil and some sticky tape and some curtain rods. And then they're like, look, teacher, I made a spaceship. And then it looks like this crappy looking NASA spaceship. Yeah, have a look at it.
On this video on YouTube, I thought it was interesting. I haven't watched it yet. But it's like 15 minutes long. Yep.
Yeah, so there's a documentary called American Moon, and it's 3 hours long, and it goes over everything, all of the technical impossibilities and glitches and clear fakery behind the Apollo missions. It doesn't prove the Earth's not a globe or anything like that. It's just, they were in like a space race with the Soviets, and they wanted everyone to think that America's untouchable and can do things that no other nation can do, blah, blah, blah. Also, there's a whole list of reasons why they would have faked the moon landings, but they definitely faked the moon landings. If you do enough research into it, you'll at least be skeptical that America went to the moon.
And I wanted to just touch on something because before you even go into all that, all right, so Ulster, I heard you say, we know that people have gone to space, right?
Yeah, because we've seen rockets fly.
We've seen rockets go into the sky. We don't know where they went. There's no way for you to verify where they went. You see a rocket go into the sky, you watch some stuff on TV, and you listen to their story about what they're saying they're doing. You believe the claim. That's a claim that someone's made to you, right? But you are left with nothing but the choice to disbelieve what they're saying or believe them. There's no way you can verify for yourself that what they're saying they're doing is true or not. That is not knowledge. That's belief, my friend. I'm sorry. I can personally say to myself honestly, I don't know that people have been to space. I'm told they have been, but I don't know it.
That's right, but I also think that knowledge is a justified true belief. So if you believe something, you obviously believe it to be true in the first place, or else you wouldn't believe it.
Yeah, it's fine if you want to have a belief, right? But if you want to take that to the next level and turn that into something you know, then you would have to do a stack of research to make sure that that belief is actually nothing more than just a blind belief. Have a look at this last GIF that I put in the side chat. I kind of like this one, right? This is a 1959 movie. Side by side, SpaceX Falcon 9 landing. It's just a funny one. It kind of looks just as bad as the 1959 footage.
If I may add quickly, so the gentleman, who invoked the justified true belief thing. I've heard that a lot too. I think there's contention on that definition, but that doesn't matter, right? In this context, if you want to run with that, you might want to ask yourself, what is it that you are using to justify that this thing that is being presented to you is true? Right? There's 3 parts to it, right? Or two parts, one with a qualifier.
Yeah.
Right? You're believing the material. You think it's justified for some reason, probably because it comes from an official source and all this stuff, and you think what they're saying is true. So just because you believe it and that's your criteria, unless you investigate the criteria, it looks satisfying, it looks legitimate because but have you really checked that out? You know what I mean?
Yeah. I get that.
Right, which is like where that's when the footage like that DJ's been showing you comes into it. It's like, yeah, like a lot of people, they've only just seen little things here and there, little clips, real glimpse, just a glimpse, right? But when you look into it, you like even as a glober, right, with the moon landing, you could look at it
Close your mouth.
and go,
Close your
wow,
mouth.
that does not look real. Thanks, Greenflower. Thanks for your input. It was really helpful.
If you question everything, then nothing truly can be trusted. Even your own
Nothing
senses.
nothing should be immune from scrutiny. Now, if you come to the end of your scrutiny and you say it's solid, right? There's solid foundation for this being true. I can rest on it easy, and good for you, man. That's fine. You go with it, right? But nothing should be immune from questioning. A famous physicist once said, "I'd rather have questions that can't be answered than answers that can't be questioned." That was Richard Feynman, renowned physicist.
Or even if you find your answers, you still need to question them. Even if you established or experimented, you still need to experiment.
Yeah, exactly.
Because it could be
There's nothing
changed.
wrong with that.
Yeah.
That's a good thing to do. It's being I can't think of the exact word, but you know what I mean. Being thorough.
Right.
Extremely
including
thorough.
what we say, right? When I said nothing should be immune from scrutiny, including what we say, man. Everything we say should not be taken on face value.
That's why, like many of us, we didn't just look into this for a year and then just stop doing research and then start saying, "Oh, look, like this is our conclusion." Like some of us have been looking into this for over 10 years, and there's still so much to learn and to research. It's like, and the more you look into it, the more the evidence just keeps stacking up, like stacks and stacks of evidence that don't align with the globe. And that show that NASA can't be trusted, so to speak, or that people have a misconception of what NASA's showing you when they're saying, look, here's a photograph of the Earth from space. Is it really? Okay, how come there's copy-pasted clouds all over the image? How come you used the same clouds in 2007 Blue Marble and the 2002 Blue Marble? And then you do a bit more digging and you'll be like, oh, actually, NASA actually admits these aren't photos of the Earth. They're actually composites. And they're made in Photoshop, and they actually put the clouds in later on after they stitch together a bunch of low altitude images of the Earth and wrap it around a ball in Photoshop. Then they add the clouds in, and that explains why they've got the same clouds in Blue Marble images of the Earth that are 5 years apart. So NASA wasn't lying. Most people just, they haven't looked into it. So they think, oh, there's all these photos of the Earth from space that from NASA, I saw them. It's a ball, but they don't realize it. Go look into the raw imagery that they used to stitch these together. None of the raw images that they used, and they're not even images, they're scans of data. None of the raw scans of data have any sign of the Earth being a globe. Okay, so they get data in from these radio telescopes, apparently. And then it's like 4 months worth of radio telescope data, and then they have an artist, okay, a guy named Robert Simon, who works for Goddard Space Center, and he takes that data and he converts the data into what looks like images. And then he stitches the images together into a big giant flat map of the Earth, like a collage. And then he wraps it around a ball in Photoshop. And then it's his job to make the Earth meet people's expectations of what the Earth should look like from space. That's exactly what he says in the interview when he talks about how he makes these. And then he says that, it still looks kind of flat, so he adds in like specular highlights and hotspots and colors it all in, and he keeps working on it. He says it's a lot of work to make it look like a globe and what people think the Earth should look like from space, and then then he puts the clouds in, and he has to copy paste them, and all sorts of different things like that. So Matrix just put like a write-up there. It's like actually an audio interview as well with him. So these images that we're getting from space quite often are admitted by NASA just to be composited images, not actual photographs. That's a whole nother rabbit hole in itself. Is like you could still be a globe earther and go deep into NASA fakery. Like a lot of globe earthers are just huge NASA critics. They know that NASA didn't go to the moon, but they still think the Earth's a globe.
I guess that's a fair criticism. But what do you think about the people who own telescopes that you can just buy one and look into the sky and make your own pictures or images?
Yeah, so choose Mars as an example. Yeah, choose Mars as an example. Like, look up the best quality telescope that there is and say, you know, show me what the raw images look like from this great telescope, right? And what you're going to see is a blurry little red circle. Okay, blurry little red thing in the sky. And then you'll say, oh, hold on, that doesn't look like the processed images that I'm seeing. And then you'll learn that, okay, well, what they actually do is they do a whole bunch of magic in post-production where they stack thousands of images on top of each other. It's called image stacking. And then they'll just keep tweaking it in software until it kind of starts to look what they want it to look like, or kind of look like what these NASA CGI images look like. Okay, and then you'll see the final product and someone will say, look, this is my picture through my telescope of Mars. But really, it's being processed like crazy in post-production. The actual raw image just looks like a blurry little dot in the sky.
Yeah, true.
And then you've got a whole story attached to that dot that you are thinking of. That goes for everything we see in the sky that's too high for us to really test. You have to start using mathematical models and concepts and things like that. Leaps of logic, basically. Like that's what.
Is it really matter? Is it really matter if Earth is flat or spherical?
It's flat. It's definitely not a globe.
It's matter?
Does it matter?
Yeah, it matters. Yeah, it's important.
Well, how about you go home and sitting at the table with all your family and say to them, I'm a flat earther, and you'll see if it matters or not.
I don't think it's matter.
Really? Oh, mate, you'll understand soon enough.
Listen, for me, Earth is spherical, right? For you, Earth is flat, and we live same life, right?
So, how did you come to the conclusion it was spherical?
Just intuition.
Intuition?
Yeah.
So, you came to this conclusion all by yourself.
Yeah.
Nobody ever told you it was a ball. You just woke up one day, looked outside and went, well, I'll be. It's a ball.
Yep.
I don't think so.
You know, like, for example, I have my God, right? You have yours, for example. And what does it matter?
What's that got to do with the shape of the ground?
It's a belief, right? You believe in one thing, I believe in another.
No, that's where you're wrong. That's where you're wrong.
They're not comparable, dude.
Yours is a belief.
So if
ours is actual measurements.
For example, Christian.
No, he's missed it. Hold on, Semi. Semi, yours is a belief. The reason yours is a belief, you have no knowledge of this.
Listen,
for us saying the Earth is flat, it's not a Semi. For us saying the Earth is flat, it's measured flat. It's not just, hey, I believe it's flat. It is actually measured as such.
And can I add to that? The guy, it sounded to me like you're trying to make a comparison to
tells another man that his religion is wrong, right? And it's okay.
Hey,
this is not religion.
Am I Carlos de Tabarnak, can I speak? You guys hear me, or am I not coming through?
Yeah, you're good.
Yeah, he keeps
God
talking
damn.
over you.
Yeah, semi, like, manners, bro. Okay.
How?
What I was getting at, dude, is, when you invoke that comparison between, God this, God that, worldview or earth view, this, that, they're not the same thing, man. Okay? One is strictly a faith-based topic or subject. The other thing is a geometric question. It's like asking me, I have this pizza on my table, or this basketball on my table, or whatnot. What is it? Oh, I don't know. I think it's a triangle. Oh, well, I think it's a cube. Oh, you're allowed to believe that because, I believe in God and you don't. So it's just like, what the fuck is that, man? Excuse my language, but hello? You just take out your tape measure and you measure the damn thing. Get the angles, if there are any, et cetera, et cetera. Like, what is this comparison, man?
We all experience the Earth as a flat and stationary plane. Okay, that doesn't prove that that's what it is, but that's the starting point. That's the beginning of the thought process. Okay, we go to a large body of water, and there's no curvature, right? If there's no wind, we see a perfect mirror on the surface. Okay, then when we go and further test it, right? Because it could just be a big globe, right? And you're too small to be able to see the curvature. So you experience it as flat, but then we go and actually test over the distance. Okay, say we got 20 miles. If it's a globe, there would have to be 260 feet of curvature over 20 miles. We can go test it over and over again and validate that there is no curvature at all over this distance, right? So it can't be the globe, the size that they're telling us. That's not possible because we went and measured it. You can still believe it's a globe if you want to, but that's just going to be a blind faith, a blind belief that defies empirical evidence.
Is it just limiting your view and imagination?
One more thing to that, DJ. At best, semi, okay, you can critique the measurement. You can say, you could argue, right, that, whoever's doing the measurement has a belief that what they did is sufficient to let them arrive at the conclusion they did, right? But you can critique that, and you can get in. You can get into it, investigate, and find where there may have been mistakes made or information omitted, et cetera, et cetera. You can investigate that, right, and discover whether or not your suspicion is true. Right? It's not just a raw belief type thing like you would have in some sort of higher power. Like, it's not without scrutiny, dude. You know what I mean?
For me, flat Earth believer, it's like a man in a cave who lives all his life in a cave and saw a world through shadows.
That's you. No, you're in the cave.
Okay.
No, spherical Earth believers, it's that who.
It's a belief. That's it. It's just a belief. You seem to think it's something greater. It is just a belief. You have never verified, validated, or proven you live on a globe. And until you do, it will always be just a belief.
Well,
here's the thing, though. The topic of discussion, right? The topic itself, okay, can seem like that, right? Plato's cave, where you have limited information, you're restrained from really verifying anything or the source of anything. I get that kind of analogy, okay, but it's like, in one context, you're kind of like you're chained to the rocks or something like that. You can't leave the cave, so you don't know what's going on. And the other context, you have gentlemen or ladies who's going on outside. You see what I mean? Like, it's not, you're limited, but not entirely. You can ask the questions. Like, you don't have to, though. That's up to you.
I would suggest if you don't like what we're saying, go out and check it for yourself. Prove us wrong. Go and measure it. See how you come back. If it comes back as a globe after you've measured it, lay your data down and we'll shut up and leave you alone.
Isn't I believe it's a start point for everything what human achieved. You know, like seamen's, you know, on the ships, they believe there's somewhere Earth, another island, and just starting their journey, you know, and eventually they found out there is another Earth. But if they just sitting still, not believing that there is another island, and I don't know, maybe human beings just live in a small area of, you know, islands of planet.
This is what we've done is gone out and actually tested for the Earth curvature in countless different locations over huge distances all over the world. Okay, and we can't find any curvature. And then when we go seeking for who throughout all of history went and found the curvature of the Earth, we don't find anything. We don't find any empirical evidence, right? We find philosophical decisions and theoretical models and calculations based off those assumptions, not empirical evidence of Earth curvature. The more you look into it, the less you'll be believing that the Earth is a globe, right? Because the evidence doesn't match reality. You can go and test it yourself as well.
I think it's a question of scale, you know, like ant on a...
Yeah, we take the scale into account. Okay, so it's so big. Okay, so that's the
two-dimensional world. But for us, it's...
Do you think we didn't take scale into account? Do you think that we were testing a smaller globe?
I think you didn't.
Really? Okay, so how much... Okay, so I guarantee that every single flat earther in the room here knows the rate of curvature on a globe, and you don't.
No, you're applying mathematical formulas into small areas, you know?
Yeah, so if you got a basketball and you know, okay, you get a basketball, okay, and then you put a tape measure around the basketball and you say, okay, this is the circumference of the basketball. Now, based off that circumference value, we can determine the radius value of the basketball and the diameter of the basketball. And then we can calculate how much over a certain portion of that basketball it should be curving. And then we can test the basketball, right? And say, yes, the measurement over this smaller section matches up with the overall circumference, radius, and diameter of the basketball. And therefore, it is confirmed that this basketball is the size that we first measured. And now we can start, you know, doing other things with the basketball. We know the size of it, blah, blah, blah. That doesn't work with the globe, okay? Because they tell us the circumference, diameter, and radius of the globe, but it was never measured. You're not going to find anyone that measured that, okay? It was assumed. And then when we go and test over the smaller section, based off those values that we're told, it doesn't match, okay? There's huge amounts of curvature that would have to be present over these distances that we're testing. So if you're doing a test over 20 miles, there's 260 foot of curvature over that distance. That's like a skyscraper building. Okay, if I'm on a 20-mile lake and I've got the freaking Titanic boat right next to me, and it sails across to the other side of the 20-mile lake, you can't see it. You can't see the boat, right? It would be completely hidden behind the curvature of the Earth if the Earth were a globe. But when we go to a 20-mile lake, we can zoom in all the way across the 20-mile lake and see the shoreline on the other side of the lake. Okay, there should be hundreds of feet of curvature over that distance.
I don't know where you got those numbers, but I really appreciate if you have some researches with these calculations, you know.
Yeah. So you can look up so this is all based off the circumference, the diameter, and the radius of the globe, right? I can give you links to, say, Washington University, send you links to Earth curvature calculators where they will tell you this is how we calculate how much curvature there should be over a certain distance. Okay, and that's what we're just getting the numbers that we're testing from the mainstream. Okay, this is the mainstream belief. that the Earth has a radius value of 3,959 miles. Okay, then we can apply an 8 inches per mile squared formula, which works fine over distances that we can measure. And we can say, okay, over 10 miles, there should be 66.67 feet of curvature over that distance. Then we can start doing different tests to try to detect the curvature. And it's not there when we test for it. So we're not making up this mathematics. We're given the mathematics by the globe side, the mainstream, and then we're just testing.
Is their article not just result picture, but
like you want to see one of the observations that we're doing? Is that what you mean?
Like ordinary article in chemistry, for example.
About what?
About this calculation. About this calculation.
The calculation? Yeah, sure. I can give you a link to Washington University, and I'll explain how to calculate the distance to the horizon. And then we can go test for that distance to the horizon and see if it matches up with reality. Okay, so I'll grab you the link right now. Okay, so this is sites.math.washington.edu. This is a PDF from Washington University directly off their website. Okay, so Matrix has posted the Pythagoras theorem formula to calculate how much curvature there should be over distance. And then here's the Washington University PDF where they will explain and show diagrams about, okay, so if you're 5 foot high, the horizon would be at 2.73 miles away, and so on. And then we can go test for that. We can show you real-world tests where we're testing the globe mathematics against reality to see if it matches.
How about read together this article and you explain me if I have a question? Hello, are you here?
Who are you speaking to?
I opened this article, How Far Away is the Horizon? And that's what I read. When we stand on the shore with our feet just at the sea level and look out the sea, we may ask how far away is the horizon. We start by making the simplifying assumption that the Earth is a sphere with a radius r. Then the line from our eye to the horizon is tangent to a circle of radius r representing the Earth as shown here in the picture. But we must be not in a sea level, we must be in the center of a sphere, right? To correct this radius line. But we stay on an external layer of sphere. It's not a radius, right?
You're on the surface of the circle or the sphere.
Yeah.
Right. So
in the middle of sphere. That's right. But we stay in the circle.
No.
Hold on, Semi. Just let 20 Cups explain it to you. He's very good at math, right? He can explain it to you perfectly.
Check this out, right? So if you picture this, you take a basketball and you put a little Lego man on top. You know what Lego is? You know, a little toy for kids, little blocks.
If a basketball would be a size of a planet, then that's okay.
Sir.
But
Can you answer my question, please? Do you know what Legos are?
Legos?
The toy.
I believe I know.
Okay, so what I'm getting at here is, analogously speaking, okay, if you take a basketball and you put a little Lego man on top, and you have him walk around on the surface of the ball.
Okay.
Now, obviously, this is not to scale or anything. Okay, I'm not trying to insinuate that, but the analogy holds. So what they're talking about in the article is this little Lego man. He's standing on top of the ball, and he's looking out over the surface. So from his eyes, right? Let's say he had a little camera on his head or something, right? From his eyes outwards, what would be the limitations of what he could see? And the math that they use in this article go to depict how that would apply in our context if we were on a giant ball also. The scale would be different, but the math is the same. So you don't need to be at the center of the ball per se. You're measuring from the center, right?
Central sphere, right?
In this case, yeah. This is how they get the radius. Yeah.
Okay.
Or their claimed radius in this context, right? And notice what you said earlier before in the reading. They have to assume they're on a ball. So if they use that assumption, take that assumption into account and work with the math that is appropriate for that assumption, this is what you would expect.
What is the h height of our eye?
Height.
Right. What is it?
Height of eye, meaning the head. Basically, in the Lego context, right? How high the guy's head is off of the surface of the ball, or how high his eyes are off the surface.
Well, are we in a central of sphere or on the surface?
On the surface.
Then why is this radius line exist? It's not radius. If we
because
surface.
The reason why it's important is because the radius is what dictates the rate of curvature. Okay.
No, radius.
So if you take that into account.
Radius, it's a distance between the central of the sphere.
Right. Exactly.
And its external line.
I understand that.
Right. But
if you want to calculate, Semi, if you want to calculate how far away the distance to the horizon is on a globe with a radius of 3,959 miles, okay, you need to know what the radius is first. That's what we're questioning. We're saying that that's bullshit. Okay, but they're saying that they're saying the radius value is 3,959 miles. Okay, so if we assume that the radius is correct, like they do, right, that means the horizon should be a certain distance away. And that line that you're looking at is the tangent line, not the radius line, right? We're doing the mathematics to test if the radius is correct. Does that make sense? How did they measure the radius in the first place? That's the question. They didn't do it.
So,
it's an assumption.
Okay, we have a radius assumption. We have a radius. Okay, we stay on the surface. H, our height of our eye. Okay, L is the length of the line connecting our eye directly to the horizon. Can you explain me what is this? Length on the line. On the line connecting our eye. Length of the line connecting our eye directly to the horizon.
Yeah. Here's a good example, right? Go back to the Lego.
L, it's our horizon, right? Distance.
No, well, just to make it clear, right? The best example would be going back to the Lego on the basketball. If you take a ruler and you put one side of the ruler on the guy's head and you put the other side on the ball, the distance between where the ruler touches his head or his eyes or whatever and where it is the tip of the ball, that's what they're describing here.
Am I right? L, we want to find L, right? Distance horizon.
Pretty much.
Okay. And as small is the arc length. Arc length. Okay, the distance on the surface of the Earth to the horizon. Okay. The angle. Theta is the angle made between our position and the horizon. Okay, made our position and horizon. Okay. Since the triangle in the figure is a right triangle, is it right triangle?
Mm-hmm.
How can we be sure is it right? Mm. From what rule the end point of our eye capability and the line from central sphere to this end makes 19 degrees? Why not 89, 91? This is assumption, right? But I don't understand why is it right.
This is trying to calculate how far away the horizon would be based off how high the observer is. That's all. It's very simple.
I understand, but I don't understand this sentence that the triangle is right. You know, why this angle between L and R sides is 90 degrees?
What it's saying basically is this, okay? If you want to do the exercise, feel free. If you have the tools or whatnot. If you draw a circle, draw a radius line, okay, maybe from top to the middle, okay, and then form a right angle triangle between at the extremity of the circle, okay, where the line meets it, okay, create that 90 degree to the left or the right. It doesn't really matter, okay. However long you want to make it. Okay, I'm asking you if you want to do the exercise so you can better understand what's being described here. Okay, you'll see why it's important. Okay, so if you draw that 90 degree, okay, however long you make it, and then on that, the other point on that, how do I put it? The line that you just drew to make the 90 degree, okay, if you connect that to the center point of the circle that you created, okay, what that's going to tell you is in order to see that first point that you drew the first line from, okay, you would have to be however high necessary that you see, okay, on the other line from the edge of the circle upwards. There's a relationship between the furthest distance and the height.
Look, for example, my age height, right, would be 10 times bigger, for example. Then this L length would be much longer, right?
Oh yeah, like And these diagrams are just for illustration. Yeah.
Yes, I will find the angle between R and L on the right side of this circle, right?
Let me double check.
Would it be also 90 degree?
There's only one 90 degree angle there, dude. Go ahead.
What are you trying to determine at this point? Whether Washington University and every other university is getting their math wrong?
Yeah, it doesn't understand why.
I'm trying.
If you want to go and learn basic mathematics, right? Because you can't understand the way that they're describing how to do this, then go do that somewhere else and come back after you understand. Okay? Because Washington University, have a look in the side chat. Have a look in the side chat. This is the determination here. Okay, this is from the PDF. Hold on a second. Hold on a second. It says that from a height, dude, shush. From a height of 5 foot. This is the problem. You're dragging the conversation into the weeds right now. Okay, Washington University clearly says that from 5 foot observation height, the horizon would be 2.7383 miles away. They show you the math on how to get that. If you want to say that they're doing their math wrong, go and write them a letter. And then you show them how the Washington University's got their math wrong. And their math matches up with every Earth curvature calculator and also any AI that you put it into. Okay, so if you want to think this basic math is incorrect, then go take it up with the whole rest of the scientific community in the rest of the world. Okay, and then you show them the correct math. You're trying to drag the conversation into the weeds, right? So do you agree that if you go to the surface of the water, right, and you're 5 foot above the surface of the water, if you were on a globe, the horizon would be 2.73 miles away? Yes or no? Do you agree or disagree with that?
I don't understand your question.
Okay, if you were 5 foot height, right, and you went to the shore,
can you translate
what don't you understand?
SI metrics.
To me, the guy sounds drunk. I don't know about you guys, but this is actually starting to get very aggravating.
So you want to
let's go nice and steady. Semi.
High school.
Do you know what a tangent to a curve is?
Age what?
A tangent. In mathematics, in geometry, a tangent. You draw a circle, a straight line touching a circle. Tangent.
Let me see.
Could be a language barrier, I'll grant you that.
Straight line or plane that touches a curve or curved surface at a point, but if extended, do not cross it at that point. Straight line or plane that touches a curve or curved surface.
So what happens when you don't have to read it out? What happens? Yeah, this is what it is a language barrier. This is what's taken so long.
No, this is a fish that keeps swimming into the weeds. Yank him out.
If extended, doesn't cross it at that point. If extended, doesn't cross it at that point.
So, if you believe you're living on a ball and you're standing at the beach and you're looking at the horizon from your eye to the horizon, would that be a tangent? Yes or no?
Try again.
You are standing at the beach, okay? Lots of water. Excellent. Standing at the beach. You are looking at the horizon. From your eyes to the horizon would be the tangent.
Yeah,
if you believe you live on a ball, okay?
Okay.
Excellent. Because they already have a claimed radius, distance from center of ball to outside of ball, because they have that, they can calculate from your height from feet to eyes, using how far the horizon should be.
You know what's the problem with this calculation? They assume that Earth is a perfect sphere, right?
What's the problem with that? It doesn't matter.
Earth is not perfect sphere. It's,
well, you've got to prove that. Stop. It doesn't matter.
If we're using eclipse,
it doesn't matter. Not matter. No problem. I'll tell you why. No, listen carefully. The reason for it, if you say not perfect sphere, that means some places are going to have more curve. And that would mean trouble for you.
In this calculation,
you don't even want to listen, do you? If you say not perfect sphere, these numbers are average. A little bit up, a little bit down, take the middle. Average.
What numbers are average?
The ones that you're complaining about not being correct because the fucking sphere isn't perfect.
You know, if there is an article that some have a
you're reading it
on ellipse, not perfect sphere, then
okay. Obviously, you've got some hang up about Earth not being a perfect sphere.
Yeah.
Nobody gives a fuck because you can't prove curvature, whether it's big curve, small curve, or any curve. So until you can prove curvature, you don't have a sphere in the first place to complain about it.
In this article, we make an assumption.
They take an average. Do you know what an average is?
Is sphere, right? Then in another article, we also can make assumption that the Earth is an ellipse, right? And make same calculation. And
if you don't like the calculations, feel free to redo the bastards yourself, and then get back to us, and we'll still tear them apart.
So you don't have this article?
Dude,
no,
Semi,
you don't have article.
They say that Earth is almost a perfect sphere, right? It's slightly oblate. It's such a small amount that even Washington University doesn't take that into account because it's such a small difference. It's irrelevant. Okay, so it's 0.33% of being a perfect sphere Earth. Such a small amount that it doesn't make a difference when you're doing these drop over distance calculations. So you could use the maximum radius, right, which would be pole to pole around the Earth, right? Or, around the equator would be the maximum, and then the minimum radius would be around the Earth from pole to pole, right? Great north to south, great circle. Okay, that would be the minimum radius value. It's only slightly different. Okay, I think it's.
I don't know. I think in a
you don't know anything about the globe, right? That's the problem. We're the ones having to teach you. This whole thing is us teaching you your own argument that you're arguing against us with. It's absolutely ridiculous, man. We're having to teach the flat earthers are having to teach you how to argue against the flat earthers. Like, what the hell is going on?
I'm open-minded, right? But
okay, so it's not a perfect sphere according to the mainstream,
right? And
it's not a perfect sphere. It's 0.33%, right, off being a perfect sphere. Okay, so that's why Washington University doesn't even take that into account. They use the average radius, which is 3959 miles. That's what you would use to calculate how far away the horizon is. Okay, so if we go to a lake, okay, and we have 20 miles across the lake, and we're 5 foot above the surface of the water, 1.5 meters. Okay, that means the horizon should be about 2.7 miles away, or 4-point-something kilometers away. Okay, but we can see the whole way across the lake, 20 miles away, and there's no horizon. Okay, so that doesn't match with the globe, even taking in the slight difference in the fluctuation of the radius value, right? It's like, it doesn't make a difference. We're seeing orders of magnitude further than you would see on a globe. We're seeing thousands of percent further, whereas the radius value fluctuates by 0.33%. Okay, so it wouldn't matter where you are on the Earth, it's going to be approximately at 2.7 miles away, this horizon. If it were a globe, it's not there. It can't be a globe. Game over.
hey, how can you even think that like Earth is flat? Like, how is that possible?
Your microphone sucks.
Yeah.
Yeah, so can you maybe try to talk a bit louder into your microphone?
All right. So, I mean, like, why do you even think that like Earth is so much flat?
Because when we go and test it, it can't possibly be a globe.
So did
because
you
there's no
test it?
curvature. What's that?
So did you test it?
Yeah. Mhm.
So can you show the proof?
Sure.
All right.
Okay, have a look in the side chat.
All right. Let me see that.
Okay, so this is an observation done in the United Kingdom. Okay, we're looking out at a windmill farm and in the ocean. Okay, so we're going to calculate how much curvature there should be between the observer and the windmill tower on the far right. Okay, the windmill tower on the far right is 11.2 miles away. The camera height is 3.5 foot.
Yeah.
Here's the screenshot from the Earth curvature calculator showing how much obstruction there should be if the Earth were a globe of the windmill towers. Okay, so the horizon should be at 2.3 miles. It's not there. Okay, there's no horizon at 2.3 miles because we can see the water goes far beyond 2.3 miles and then far beyond the windmill farm. Okay, the bottom of the windmill should be obstructed behind the curvature of the Earth by 52.9 feet. If the Earth were a globe.
So you mean you have studied the physics?
Well, this is
And
basic. This is just geometry that we're doing here. Okay, so we're calculating. We're seeing if the mathematics from the globe Earth matches with reality when we go and test it. Okay, because they tell us the size of the globe, and then we can do the calculations based off the radius and calculate how much curvature there should be in this observation over a certain amount of distance. Okay, so we're testing for the horizon. Okay, so this is what the horizon should be, right? The maximum distance that you can see. And then you shouldn't be able to see any further because things would be behind the curvature of the Earth, beyond that point.
If you look at the picture, it's like there is a man and like he's like seeing from like telescope, not telescope, but like through some kind of thing, like he's seeing the sea. But like this whole picture is really wrong because
what's wrong about it?
Because Earth is really big, okay?
Yeah, it's not to scale, right?
Yeah.
It's just a diagram to show you the concept of how you would calculate the distance. It's not to scale. If it were to scale, it wouldn't look like this, right? So the actual diagram is not to scale, but the concept is correct. Okay, the horizon line would be the maximum distance that you could see the water at up until if the Earth were a globe. And that should be a certain distance away from you, depending on the height of the observer. So if you're 6 foot tall.
Yeah.
Mm-hmm.
So can you share that YouTube video in the chat so I could like see myself?
What's that? Say that again?
So you were like watching the YouTube videos and you take a screenshot.
No, I'm not watching YouTube videos. I've gone out and done tests myself.
Oh, okay.
I didn't post any YouTube videos, but there's nothing wrong with a YouTube video. NASA has a YouTube channel, you know?
Yeah. So I need the link of that video. You just take a screenshot off so I could like witness myself and like with the explanation of it.
Okay.
All right.
There you go.
Okay.
It's an hour and 15-minute video, though. Akio, Grandpa, you're unmuted. You must have been muted last time you came in here. That's why you were muted when you came back today. You know what's wrong with this article? Which article? That's you gave me Washington. Yeah, what's wrong with it? They assume that at the start, Earth is a sphere and make a calculation, and I checked it's all right, okay. But at some point, they started assumption that Earth is flat, and there make an error. You know what? It doesn't say anything about Earth being flat. It's a globe-based calculation to determine the distance to the horizon. I will read. So we calculated this L, right? Our horizon distance, and if we make the assumption that L should be approximately the same as S here, their assumption is that Earth is flat. What? If Earth is flat, then S and L it will be approximately the same, since H will be very small compared to R. But in our calculations from the start, Earth is sphere, so S not just right line, it's a curve.
No, you're completely misunderstanding what that statement is.
They assume that us is a right line.
No, Sammy, you're misunderstanding that statement. Okay. S is an arc segment, right?
Right.
Okay. So what's the percentage? What is the percentage difference in this context? Do they give you any values?
I don't know what is percentage. I ask why it's approximately the same. If it's S is
because the margin, because they're not exactly the same. But for the illustration, for the math there,
no, they not exactly. Approximately.
They're approximately the same. Yeah, so there's no problem with that.
There is a problem.
At this scale, you're talking like 4 or 5 decimal places of equivalence or something like that.
I think from this point they make a wrong assumption and get a wrong result.
Okay. Did you do the math? Did you do the math to check?
Yes. If I continue the assumption that the Earth is a sphere, then I will get a right result.
Hang on, dude. You're gonna have to listen. Okay. If you didn't do the math to check, then you're kind of just, spinning your wheels for nothing. If you did the math, can you show it, please? And we'll check how much precision, it's got and whether it's accurate or not. Or whether it's justified for them to say it's approximately equivalent.
I don't need anything else. I just see their goal.
If you did not do the math to check, right? Okay, so again, right, Sammy. So you did not do the math to check, to scrutinize whether their statement of it being approximately equivalent is or is not the case.
Can you send me another article with the,
Sammy,
I don't know.
Sammy, I'm going to ask you one more time, otherwise you're going on fucking YouTube.
I find error here.
Sammy, one more time. Did you or did you not do the math to check?
Let's check. You're just
yeah, he's spinning wheels, man. No, fuck this guy.
You have some denial what's happening right now.
Yeah.
So look, Washington University has given you a chart here, Sammy, which I've posted in the side chat. If you think any of those distances are wrong, if the Earth were a globe, then tell us what the correct distance would be for any of those, right? Give the result, give the math that you used. Otherwise, shut the hell up. Simple as that.
Yeah, I put him on mute for the time being. Sammy, if you can actually do that and put it in the side chat, ping one of us, maybe we'll talk about it in the interim.
So that's your ticket to get unmuted. Okay, so you have to back up your claim. Okay, you said Washington University got the math wrong. So you have to show us the correct math and show us the correction of one of those distance calculations to the horizon that I posted in the side chat. Any one of them. Pick any one you want. H is the height of the observer in feet. Okay, the second column is the distance to the horizon in miles. Okay, pick any one of those. Tell us what the correct answer is, and then show us the math that you did to correct Washington University, and then that will be your ticket to be unmuted. Otherwise, it's just a waste of time.
I don't know about you guys, but the guy sounds hammered. I don't even know if it's worth
we could only hope that that's the reason.
I hope, man. Fuck. Either he's hammered or there's a language barrier. I don't know, man.
Yeah, it's not our duty to teach the globe earthers basic math, for their own model that they're defending, that they don't know anything about. Funny how they'll throw like their own mainstream .edu sources directly under the bus just because a flat earther shared it. Has to be wrong. Now Washington University has to be wrong. Every Earth curvature calculator now has to be wrong because a flat earther agrees that on a globe that would be the numbers.
Hello.
Oh, man.
Can I ask a question, bro?
Mm-hmm.
It's a little bit of off topic, by the way.
Okay.
Do you think that the 9/11 was a government attack or a terrorist attack?
I don't know exactly what happened with that, but I don't believe the mainstream story.
Okay.
I don't think anyone will ever know exactly how that went down, but there's definitely a lot of interesting inconsistencies with the mainstream story about what happened.
Okay.
Yo, DJ, what did he ask? I didn't even understand him.
He asked if 9/11 was a government attack or a terrorist attack.
Oh, okay. Damn, I'm surprised you understood that. I wasn't expecting you to answer. Then you just went to the start. I was like, damn, that was impressive.
No, I understood.
Oh, wait.
I got it too.
All your songs, man.
Very clear. Well, I was going to say that I don't know if you gave him the right or the wrong answer there, right? Globalist.
I just gave him an I don't know answer.
Yeah, that was funny, man. I was like, what the fuck did he just ask? You're like, yeah, no problem. Yeah, here's the answer. Like, holy shit.
Yeah, dude, I know. I was like, holy. That's what I was saying. I wasn't expecting him to answer. It was the most impressive thing since like the beginning of the year. It was awesome.
I was like, there was a dead silence after the guy asked at the end of the end of the question. I was just expecting for DJ to be like, what?
Yeah. That was awesome.
Fuck.
I'm telling you, man, those songs, they're helping you out, dude.
Yeah. It's my month in India last year. Got the accent down. And obvious Itby lives in the UK, so he probably knows the accent well as well.
Oh, there are a lot of Indians over there?
Oh, yeah.
Yeah. Fairly big population.
Same in
Oh,
Australia.
wow, I didn't know that. Oh, I didn't know that.
The town that I grew up in Australia is like the capital, the Indian population capital of Australia. There's like, they've been living there for a long time. And, you know, they got like farmers and things like that. Yeah, a huge Indian population there. And if you go to Sydney or somewhere like that,
third, fourth generation Indians here.
yeah. And then if you go somewhere like Sydney, some suburbs are like India.
Oh, wow.
Yeah.
I did not know that.
Tons of Indians and Nepalese students. Tons.
It makes sense now why you're so familiar.
Sydney's a weird place, the outer suburbs. You can drive 5 minutes away to a different suburb, and it's like you're going to a different country. Like you'll drive to Campsie, and it's like you're in Asia. It's like all Korean, all the shops all have Korean writing, no English writing, and everyone's Asian. And then you just drive 5 minutes away in a different direction, and it's like you're in Little Italy, like in Five Dock or somewhere like that. It's like Italian butchers and Italian cafes, and it's literally like you're in Italy all of a sudden. And then, you know, you can drive 20 minutes or 10 minutes away in a different direction, and it's like you're in Lebanon. And then go to Ashfield just a few minutes away, and it's like you're in China. And all of the shops are like have Chinese writing on the fronts, and it's Chinese people everywhere. Yeah, it's like 20 countries in one like little area.
That's actually pretty cool.
It is. It is interesting.
Does anybody have them particular moon prop photos that old dude just dropped in that meme?
I got some.
Just as they are, like by themselves.
Mm-hmm.
I think I have that one he posted, but I don't like stuff with text. You know, I'd rather they're just, you know, speak for themselves type thing.
Here's a couple.
Yeah, there we go. Cheers. Because I was looking for images like these the other day for someone, but sure I'd saved some, but seemed not. Yeah, but I mean, Globers really underestimate how good our prop game was back in the day.
Oh yeah, like even look at like the movies from the 80s and like the 90s especially, like the Titanic and things like that. Like the amount of effort they went to with the props and the sets. And they built like a freaking half a Titanic or whatever. And it looks so real when you look at the movie. Imagine what they could do with basically an unlimited budget.
I'm on the fence about saying that faking shit is humanity's greatest skill.
Yeah.
What was the follow-up with all that Kim Kardashian stuff? Did she have to get go to the principal's office, have a sit down?
Which I'm probably got told to shut up about it from her manager or something like that. I'm not sure. Haven't heard any repercussion. But NASA got straight into damage control.
Yeah. As they would. Do you remember that scene in Interstellar where he's at the school principal's and he's speaking with the principal about his daughter, and they're teaching her that the moon landings were faked to, disrupt the budget of the Soviet Union. That was the reason in the film. And he was still adamant that they happened. And it was...
Man, I need to rewatch that. I don't remember that at all.
Yeah. It's like what were they trying to imply the school system that they went full delusion? Of course, the premise of that whole film is that space is now easily accessible and they're expanding out into it and yada yada. But I mean, we know they put truth in the films, lies on the news.
Yep. All right, Byron, yes, I can explain that again. Okay, so he's got his camera set up at 3.5 foot above the surface of the water. And then, based off that height, we can calculate how far away the horizon should be if the Earth were a globe. And that distance is 2.29 miles. That's the distance that the horizon should be at on a globe from that observation height. But in the observation, we can see a windmill farm that's actually 11 miles out into the ocean. Okay, so the horizon isn't where it would have to be on a globe. We actually just see the water continue on past where the horizon would be. And then beyond the windmill towers, we can actually also see the windmill towers touching the water as well. So there's no obstruction at all. And then in the distance, we can also see a boat, which is 14 miles away. The bottom of the windmill towers should be obstructed by 52 feet. Behind the horizon, that should be at 2.29 miles, but it's not.
Is that windmill is in the ground or in the ocean?
Yeah, it's in the ground, but it's in the ocean. You know what I mean? Like it's fixed in the ocean. I'll give you some more information about the windmill farms just a second. Yeah, they don't move or anything like that. They're fixed, but they're out in the ocean.
Yeah.
Okay, so this is the windmill farm. It's called Rampion Windmill Farm. And then here's like a close-up. So those are actually giant windmill towers. But he's looking at them from 12 miles away, right? Like that's a long distance. Okay, so have a look at the close-up pictures. You can see that when it's low tide, we can see the black section where the paint has corroded off the bottom of the windmill towers. And then when it's high tide, it comes up to where the yellow paint starts. Okay, so he's done this observation at low tide. And here's a screenshot from the zoom footage from the shoreline. Okay, so we can see the black portion at the bottom of the windmill towers touching the water.
Yeah.
So yeah, there's no obstruction. And the horizon isn't where it should be.
Okay.
And then he did a different observation on a different day as well, where he actually put the camera down to 2 foot height. Okay, so here's a comparison from the 2 foot height and the 3.5 foot height. So in both of the days, we can see the bottom of the windmills touching the water.
So, do you believe that the Earth is present in the center of the universe, and the sun is just like?
Hold on a second, man. I'm going to turn your volume up. Oh, I already got you on 200%.
Okay. So, do you think Earth is in the center of the universe?
Oh, well, this is what you should do, right? So, try not to think of the Earth, right, of the flat Earth inside the globe Earth version of outer space. Okay, so we've always been taught that there's a big space vacuum, and then we're a planet inside the space vacuum, and then there's other planets. Okay, don't try to fit the flat Earth inside the globe model of outer space.
Okay.
I like to think of this. Think of it from scratch. Okay, we're on the surface of the Earth. You could think of the surface that you're on, kind of like the foundation or the floor of this system that we are in. Okay, it's not moving, and we can't find any curvature. And
so you mean like there is no space, there is no gravity?
Gravity is something that is needed to have a sphere Earth, right? So you need the sphere to have gravity, and you need gravity to have a sphere. So gravity is going to explain things like how you can have all the water, all the oceans sticking to the outside of a ball that's spinning through space, right? And how you can have a ball in a vacuum in the first place, all of that kind of thing, and how we would have gas pressure that we're breathing on the Earth, right? Because if there wasn't gravity, then all of the gas pressure would fill the available space in the vacuum, and we would all die and all the water would boil. Okay, so you need to have some magical force like gravity, pseudo force, right? To be able to explain all of these things on the globe. You know, we don't really need to have that in reality. We don't need that. We don't have to explain things that defy logic and common sense, right? We say that. Hello. We would say that water requires a container. Okay, so if you have a large body of water, you need to have a container. And whether it be like a pond or a puddle or something like that, right? It's where you have the low spot in the land, and then the water will gather in the low spot in the land, and then the water will be flat across the surface. Now, over 70% of the surface of the known area of Earth is covered in water. Okay, and that water is not curving over distance, and that's what we mean by flat Earth. Okay, it's talking about the description of the surface area of the Earth, not curving. We're not claiming to know the shape of the Earth, and we're not claiming the Earth is like a flat disk inside the globe Earth version of outer space.
Okay, so in your point of view, Does any of the planets like Saturn, Jupiter, and Mars that exist alongside with flat Earth?
Well, I don't think flat Earth is a planet. Okay, so it's fair that you said. Yeah, so we don't think that the Earth's a planet, but we definitely agree that everybody sees the same things when we look into the sky. The difference is the globe Earthers, right, which was us as well, right? We're all taught all of these stories about what we're seeing in the sky and how far away it is, and that it's in a big space vacuum and it's this certain size and it's made out of gas or it's made out of solid or it's made out of diamond or whatever they're claiming with a particular planet or a star or something like that. We would be challenging that right at the core and say, okay, we're not detecting any Earth curvature, so it can't be a globe. Okay, we have gas pressure, so we would need to have a container. And there's no evidence that the Earth is in motion, right? The Earth is stationary as far as anyone can tell. So that's kind of where we're coming from. Quite often it's questioning what we're told by the mainstream, by the globe, and seeing if it matches reality. And it absolutely doesn't match reality. So we're not trying to say that we know everything about everything, right? If something's too high for us to validate, like the stars and whatnot, right? We're going to say we can't validate that. We would only be able to speculate about these things. Whereas the globe side tries to have an explanation about everything. Okay, because they want people to think that they know everything about everything and you should just, trust everything they say and don't question it, or you'll be deemed like a science denier or something like that. So we admit what we don't know, and then we go out and we record empirical evidence and just present it to people, and then we ask people not to believe us, question the evidence, and then you can go and repeat it yourself if you want to go and try to validate for yourself, because this isn't something that you have to believe. This is something that anyone can actually go and test if they want to.
I don't understand the part when you say like Earth is not a planet.
Yeah.
Why?
Yeah. So so a planet. The word planet comes from the word wandering star. Okay, so that would be celestial bodies in the sky, or celestials in the sky.
So do you think like
I
Earth
would
is
say
not a
that
celestial body?
no. The Earth is like the floor or the foundation of the system that we live in, and it doesn't have any commonalities or any similarities, right? There's nothing in common with when we look at the moon, for example, or we look at a planet or the sun. Okay, the Earth doesn't have any of those characteristics. Okay, it doesn't have.
You agree that like moon and the sun are spherical? And the Earth
I
is the only one.
I can't tell exactly what they are. I could show you some tests now where things look spherical, but in reality they're not spherical, but they look spherical.
But what if it is spherical?
Yeah, it could be spherical. Okay, so the moon, for example, it looks like it's spherical to me. Okay, but that doesn't mean that the Earth has anything to do with the moon, right? The Earth is the floor. Kind of think about it like this. Say you've got a light on your ceiling that's round. That doesn't mean that the floor is round as well. It's a completely different thing. But because of this heliocentric model that we've been brought up believing, people think that the Earth is also like the things that we see in the sky, because they say that you're also floating around in space on the globe. Okay, we're challenging that. We're saying if the Earth is a sphere, then there would have to be curvature. And then when we go out and measure for the curvature, there is zero curvature. So it can't be that. It doesn't have anything in common with these things that we're looking at in the sky. Even if I were to grant you that the moon is a sphere, right? The Earth doesn't have any evidence of it being a sphere. The moon's just something else, right? It's like if I go out into the forest and I see trees, that doesn't mean something else is a tree. That doesn't have any similarities to the tree. I'm not a tree. I don't have any tree features. Okay, but I see trees everywhere out in the forest. Okay, it would be completely illogical for me to make an assumption that something else is also a tree that doesn't have any evidence of being a tree.
Okay. So, from what I heard, like flat earthers believe that Australia is just a hoax and it doesn't exist. What do you think about this?
That's something that no flat earther ever claimed. Okay, that's just propaganda by the media to try to make flat earthers seem like they make silly arguments. Why would anyone suggest that Australia doesn't exist? There's multiple Australians in this channel right now. I'm from Australia. Like, that's ridiculous. Why would Australia not exist if the Earth were flat?
And like here also like the Antarctica is the continent which is like surrounding all the Earth, and beyond that, nothing knows. Like no one knows like what is that because the government is hiding something. I like to see that.
Yeah, I'm not making those claims, right? People in this channel aren't making those claims. Nobody's ever just kept going south. That's the fact, right? That's the brute fact. No one's ever just kept going south that we can validate. So if the Earth were a globe, someone could just keep going south, right? And then they would come back to where they started again. No one's ever done that.
Okay, so explain this. So why flat Earth theory is not popular among the people?
It is, okay, so it was becoming the most popular search term on all of the internet. So on YouTube, right, back in 2015 and 2016, flat Earth was the #1 search term on YouTube. Flat Earth videos were getting millions and millions of views. And what happened was Congress, right, American Congress got together with the owners of these platforms, and they decided that they're going to censor flat Earth content and hide it from the search results and replace the flat Earth videos with a warning and with propaganda videos, right? With silly videos saying flat Earthers say Australia doesn't exist. So instead of promoting the popular content and saying, look, everyone should look at these observations, they actually hid them from people. And that's still valid to this day, right? It's still happening now. And there's video footage of the Congress meetings where they talk about it.
So,
and it is quite popular. It is actually quite popular. Look, we're in an English hub server right now, right?
Yes.
Okay, so this is a server where people come to learn English. It has 350,000 members. Right, so I'm going to do S*T. Let's see what the most popular channel in the entire server is. Okay, so here's the results in the side chat. Oh, look, 24/7 Flat Earth Discord by over 1,000 hours is the most popular channel in the entire server. So yeah, it is a popular topic when it's not censored.
Oh, so like back in the days, like 18th centuries, the flat Earth thing was like really popular. And so what do you think like it went down after the 19th century?
After the 19th century, well, I guess education systems were pushing the globe theory, right? And they were not teaching people both, right? They weren't teaching people about flat Earth, so they weren't talking about it anymore. It became mainstream to teach that the Earth was a globe. So people people have blind belief in what they get taught at school and on the television and on the radio and things like that, right? People will just believe what they're told to believe, and that's the way it is. And most people don't question it, right? They don't question if the Earth's a globe. They grow up believing that the Earth's a globe because they're taught from a very young age that the Earth's a globe. Most people don't know anything about it either, right? They don't know how fast it spins or which way it spins or how big is it, how did it form. People generally, they don't know anything technical about it. It's just a belief system that they've never questioned, right? They think, oh, of course it's a globe, right? We actually go out and test to see if the mathematics matches up with reality, and it turns out it doesn't. And there's millions and millions and millions of flat earthers now because people that have access to this information, they can't really deny it. And we encourage people, don't just believe what we're showing you. Go out and test it yourself. Check for yourself.
Hey, Life Forever, you must have some compelling arguments for the globe. You're going pretty hot in the chat. Let's see what you got. Why are you going all gung-ho in chat then? Not more sensible to just remain quiet? Yeah, you're just listening while voicing a bunch of ridiculous opinions in the chat. Do you want to substantiate your opinions and takes? But that's fine, man. I'll just take away your text privileges. You're supposed to be speaking in the VC first before text. You don't get to sit and skank up text if you can't hold your own in VC. There we go, man. Now you can sit and listen in peace. I wonder if you're about to drop out of the channel in about 5 seconds.
I understand it. Stop it. Shut up. Shit. Smoke that baby. What are you doing? Standing there talking. What? Going on? What? Really? You fucking can do that. You're honey. Really good. What kind of family like that? Five. What? 4, 5. Oh, lost your mortgage. $10,000.
We already spoke to Semyon, DJ.
Too much already. Yeah.
Yeah, that was the guy that was arguing that the Washington University has got their distance to horizon calculations wrong and blah, blah, blah.
Fair enough. Well, we've got Cabbage and Patricia.
Can if anyone does anyone have a question? We were chatting with Byron just a second ago, or Brian, sorry.
Yeah, sorry, I didn't mean to interrupt that.
Yeah, so I'm eating something, so.
Oh, you're right.
Yeah, no, I'm.
Yeah, enjoy your food. So yeah, Semi said Semi had a challenge to get unmuted, and that was to provide us where Washington University was wrong in their distance to horizon calculations. Show us the correct answer. But they didn't do that. You can keep chatting to them if you want, obvious. You can unmute.
Well, he keeps posting stuff in chat regarding real-world measurements matching their models, but where's the real-world measurement?
Walls of text from AI now. Yeah, great.
You know, it's funny, DJ, the thing we asked him to produce, right? If I'm not mistaken, not 20, 30 minutes before we muted him, or no, never mind. Maybe 20 minutes from before, you had posted that table that basically shows exactly what we were talking about. That table, and we were spot on, man. Yeah, five digits after the decimal point of, precision.
Yeah. Well, that was a wall of text, and then he left.
Well, look at the conclusion. Or the last sentence in the last paragraph. The fact that real-world observations consistently match its spherical calculation is compelling evidence against the flat Earth. Meanwhile, we're fucking sitting here showing him every observation that doesn't match the goddamn model.
Exactly.
Does he not understand what's going on here? Like basic ABC shit.
Yep. So the conclusion actually is that 0 observations match the globe. And we challenge anyone to find one that matches the globe and present it here. Because we can present endless amounts of observations that don't match the globe. Not only don't they match the globe, they're orders of magnitude off matching the globe.
I've yet to see a single observation done by a glober.
Yeah,
that
not
matches
even
the
close.
globe.
You know, and they can have their begging the question standard refraction. That's fine. Popping at 8% on there. That's cool. You can have that. It's not going to help them at all. There's not one that even matches it, even accounting for a standard atmospheric refraction. Begging the question atmospheric refraction, that is.
Yeah, the only observations they generally make are waiting around to cherry pick like a boat looking very funky with what's obstructed and what, and whatnot. They don't provide any math. They don't say, oh yeah, this is exactly where it should start to be obstructed this much, It's like, yeah, they just wait around till they can catch something funky looking and then reify the globe with it.
If no one's got any pressing questions, like any newbies or whatnot, I thought to throw out there. Did anybody watch the Dr. Shiva segment earlier today?
I watched a little bit of it. It was a bit of a train wreck from the bit that I saw. The only good thing that came out of it was a screenshot that I managed to take from Fight the Flat Earth.
I saw that.
Yeah, so I'll just post it because it's
not a
funny.
fucking loser, man.
But this is what good came out of it was I managed to get Fight the Flat Earth to join English Hub and to DM me, and now we have a DM going where we're organizing a debate between Indio and Fight the Flat Earth. So that will be happening very soon.
Oh, that's actually pretty good.
That's pretty good.
Yeah.
How much of the video did you actually watch? Like, did you see the first presentation on the FE side?
Of the radio waves?
And the airplane descent angle stuff, yeah.
Nah. No.
No? Okay. Because Shiva opened up at some point after babbling. Okay, let's hear some experiment proposals from both sides, And I think it was not FTFE, but the other guy that looks similar to him. What's his name? Fuck. I forget. I get confused between the two. He said, one experiment is like, get like a, azimuth and elevation angle from various points on the surface, and let's see if it matches either model. Very simplistic. But then the other one after that, they opened up to the FE side, and the guy went full, like, balls deep into this proposed test of some, ideally, if you have airplanes kind of descending at a 3-degree angle, the radio waves from like the towers blasting up at it, they can gauge all this stuff and, measure the distances and see if it fits. Like it went on and on and on. And I couldn't help but notice how much critique, right? Like the guy did a poor job, or he did an okay job, but, he was missing some stuff. But I couldn't help but notice that I think they extended just that portion of the whole discussion there by the same amount as the guy took to present, just to critique it and give some feedback and all that. It was cordial and all that, but it was obviously like with the intent to be like, this guy's an idiot, he doesn't know what he's talking about. And I found that a little strange, man.
Yeah, I stopped paying attention right at the intro where they introduced MC Toon and Dr. Shiva Dr. Shiva made the point to mention that MC Toon has had death threats by flat earthers, and then that's just not cool. I was like, oh, okay, this is bad faith, right? This is going to be ridiculous. So I didn't bother with the rest of it.
Even if that were true, let's fucking speak about what Glovers have been up to.
Exactly. So
Which
yeah,
he
Dr.
obviously
Shiva's
didn't
bad
mention.
faith, MC Toon's bad faith, Fight the Flat Earth's bad faith. Right? These guys toxic pieces of crap in my opinion. So
Oh, totally, man.
yeah,
That's
I don't
why
think
I
we should
haven't
pay them
bothered
attention.
with that debate. It's a total stage, you know.
Yeah. But if he wants to debate India, right, in like a controlled environment that's neutrally, moderated, then I think that would be good. If they want to do
Yeah,
that.
that's very cool.
For him.
So it's still in the works. Nothing scheduled yet, or
No, I spoke to him yesterday. He's in America at the moment, hanging out with MC Toon. And he said, I think very soon he will be available, but after that he won't be available. So I'm waiting to hear back from Indio in a DM, and we'll try to line it up and work out like a way to conduct the debate. Right? I think it should be. Because this topic can just drag into the weeds, like what happened with Dr. Blitz, it just dragged straight into the weeds, and it was all about how can you really prove anything's correct, and I don't know if I have hands, and blah, blah, blah. We want to keep it topic specific, subject specific, have it about long distance observations or something like that, right? And just keep it straight on actual empirical evidence based long distance observations or something, whatever they agree to do. And just keep the discussions about that. Make sure there's rules where not to make it about the people, and keep it on point as a rule, something like that. Got to work out a good structure.
Gotcha.
Hello, I was watching the video that you sent before, and I have a question.
Sure.
So okay, I will send a picture, and I want you to explain to me, like, why do you believe there's a curve here?
Mm-hmm.
This is 60 mile away from. You can see the Chicago skyline across the Lake Michigan. So how do you think this is possible?
Okay, so things disappearing bottom up on a flat surface is something that can easily be replicated on a smaller scale, right? We can have a flat room, for example, like a flat floor, and we can put small objects on the other side of the floor, and then we can get the camera down low and we can make it look like those objects disappear bottom up. Okay, so there can be various reasons behind why this happens. Okay, so we can have miraging effects known as sinking, where something that would normally be visible on the horizon appears like it's sinking behind the horizon, even though it's geometrically unobstructed. I can give you citations for that from the mainstream. And then we can also have ocean swells, right? If this is a lake, then we can also have waves in a lake. Okay, that can also play a part in it as well. And then we can have the atmosphere acting somewhat like a lens. Okay, because if it's a very humid location, it can act a bit like a lens, right? So if we have a flat surface and we put a lens in front of the camera and then we move something away, it looks like that. It looks like it disappears bottom up as it moves away, because of the atmosphere could act a little bit like a lens. But yeah, sinking would be a plausible reason. Okay, so not sure most people haven't heard of what sinking is, right? Sinking and looming and stooping and towering, right? These are all miraging effects or minor miraging effects, types of inferior and superior mirages. So maybe I can just give you a few citations, because we don't even have to talk about flat earth arguments, right? We can just use mainstream explanations, right? Just by people that believe the Earth's a globe, right? Just to explain why there are other explanations. So just a second. So I've got two really good citations here. I'll just post them in the side chat and then read them out. Okay, so if we want to say something's disappearing behind the horizon because of Earth curvature, we would have to dismiss the other potential factors that could make that same effect happen. Because we can, like I said, we can reproduce it on a small scale on a completely flat surface, proving that it's not exclusive to the Earth curvature. Okay, so here's two citations. So this is something that would have to be validated by the globe side that this isn't in effect in the observation. Okay, so this is Andrew Thomas Young. He's kind of like a leading expert in the subject of atmospheric refraction and optics and that kind of thing, right? He has his own .edu website. So this is from his, I think it's from maybe a book, Optics in the Atmosphere, Reports on Progress in Physics. Okay, so atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. This effect results from vertical refractive index gradients near the surface that produce curved ray paths. Okay, and then under that we have Perkins, David, N. Atmospheric refraction in geodetic and astronomical observations. So the same sort of thing, right? Refraction caused by temperature gradients near Earth's surface causes distant land, sea, or urban features to appear distorted or partially visible when they would otherwise be fully visible in the absence of such non-uniform atmospheric conditions.
Okay,
and now I'll just quickly, I'll just show you a small scale demonstration of the same thing happening on a flat surface. Okay, so this is an observation someone did, right? This person has hundreds on their YouTube channel, but this is just a small clip from one of them. Okay, so what they've done here, okay, so they're just on their flat floor, and they've set up some blocks across the floor that are all equal height, and they've also put a red light on the other side of the floor, on the other side of the room. Okay, so at the start of the video, they have like pretty uniform temperatures inside the room, and you can see all of the blocks going across the floor, and you can see the red light on the other side of the room. Now, all they do is they manipulate the temperature conditions in the room.
And that is called temperature inversion?
Well, that would be, yeah, exactly. So the temperature is going to create a gradient, okay, and that temperature gradient is going to change the refractive index properties of the medium very slightly, but that's going to affect the way that the light is traveling back to the camera, okay. And if you've got cooler air above the warmer layer of air on the ground, then the light will always deviate towards the more dense portion of the medium, which would be the cooler air. Okay, because cooler air has a very slightly higher refractive index than warmer air. Okay, so those light rays bending upward will cause the object in the distance to be displaced downwards a little bit, right? So all of a sudden, it looks like the laser, well, it's not a laser, it's just a red light. So it looks like the red light in the distance, all of a sudden you can't see it anymore. It looks like it's hidden behind a horizon that's been created on the floor, right? Even though the floor is flat, it looks like there's a horizon, and it looks like the laser, oh, sorry, I keep saying laser. The red light is no longer visible, and it actually looks like the blocks that they put down on the floor are actually curving, right? And disappearing bottom up behind the curvature of the flat floor. Okay, showing that it's just an optical effect that's taking place due to the manipulation of the temperatures or the temperature gradient.
Right.
Which is essentially manipulating the refractive index gradient in the room.
True, but in the video, I noticed something questionable. He says the observer must see the actual object. You're not supposed to see the actual object.
Yeah,
I think
this is a later portion of the video, right? And that image that he's showing you there
is actually not anything to do with the observation that he presented, right? He's showing you examples of different types of miraging effects, okay? And then he's trying to go into detail about how different types of mirages would only work if the Earth were flat. Okay, it has nothing to do with the observation. It's additional information that he's providing about mirages and his theories on how mirages would only work if the Earth were flat. Okay, that image that you showed there isn't from the observation at all. It's later on in the video where he's just having a section about talking about mirages, right? This guy is a PhD in the field of optics, right? So he has a very, very high knowledge when it comes to miraging effects and things like that. So he's just going into deep detail about miraging effects and how he thinks that it wouldn't be possible on a globe. That's all.
That's false, though.
Okay, well, that's what he's saying. What's false about it?
What's false about it is that he doesn't consider the colder air and the warmer air. So the air over the water should be colder. If it's colder, then it should be denser. And when you have the heat near the ship, it looks like it's bending. Did I have it mixed?
No, you got it right. So the water temperature is like 18 degrees and the air temperature is like 21 degrees. Okay, that's not going to provide much of a difference in the refractive index gradient. Okay, to be able to see orders of magnitude further on a globe, you would have to have crazy gradients in the temperature, like in the refractive index, and along with that would come crazy miraging effects, right? Like inverted images and floating ships and like crazy distorted optical things in the distance. It wouldn't be a nice crispy clear image like this, right? You can't have, even if you go into AI and you ask it, right? Go ask AI about it. It will agree that it doesn't match up with the globe, and you can't use like a slight change in the temperature gradient to explain the observation. Okay, because if we assume the Earth's a globe, okay, they have something called standard atmospheric refraction. Okay, and this is what's used by surveyors and people that do celestial navigation and whatnot. Okay, and they say that under standard conditions, right, which is clear conditions essentially, conditions where you don't have crazy miraging effects and things like that in when you're looking out, okay, you would apply standard atmospheric refraction, which presupposes, right, it begs the question that the Earth's already a globe, and what it does is it's basically increasing the radius value by 8%, 8 to 15%. Okay, so that means that the horizon would be 8 to 15% further away. You would essentially be able to see 8 to 15% beyond the curvature of the Earth. In this observation, that would just move the horizon from 2.29 miles to 2.4 miles or something like that. Okay, we're not seeing that. We're seeing the horizon's actually like past 14 miles away. So this is thousands and thousands of percent beyond where it should be on a globe. Okay, not standard atmospheric refraction, which would make it 8 to 15% further away. This is thousands and thousands of percent further. So if you take the way that the globe side begs the question and tries to calculate for atmospheric refraction, you would have to say that there's so much refraction that it's making the Earth essentially look flat. Okay, and the way that's done is by using a refraction coefficient. Okay, so when it's 0, that means that it's essentially like looking through a vacuum. The horizon would be at exactly where it should be on a globe, 2.29 miles. No further, no closer. Okay, and then they would say that the refraction coefficient in this observation is basically at 1, which would basically, like, as you slide it up, it increases the size of the globe more and more and more and more to try to reverse engineer the observation to make it match a globe. So for these observations, you would have to slide this refraction coefficient up to 1, which would be so much refraction that the Earth just looks flat. Then we go to a different body of water, we do it again. Oh, there's so much refraction, the Earth looks flat again. We go to a different one and a different one and a different one, and then we do it on a different day.
so much refraction that the Earth's flat all the time. It's ridiculous. It's a ridiculous claim.
So you're saying that refraction or seeing the Earth is flat is not a result of the refraction, it's a result of the Earth
being flat.
Yeah.
Yeah.
Exactly.
Yeah, crazy claim, I know. It's flat because it looks like it's not.
It does
like
look
it
flat.
wouldn't be possible. It wouldn't be possible to have this extreme refraction all the time. Okay, so if you look up, even if you just go on AI, right, and you say, okay, to have a refraction coefficient of 1, what would the temperature gradient have to be doing? It would say that that's extremely rare. They would say it's like near ducting conditions, such extreme refraction that you would have to have this ridiculous change in temperature from, say, really, really cold temperature down low, and then all of a sudden over just a small distance vertically, it gets really, really hot. Okay, so it's going from like, say, 2 degrees Celsius, and then all of a sudden it's 40 degrees Celsius, right? So that's not possible when we have almost uniform temperature conditions between the water and the air temperature. It's not possible. And then you could ask it, right? Say, what would things look like in the distance if we had this extreme refraction condition, where the refraction coefficient is 1? It will say, oh, it would be like crazy distortions. You would have crazy miraging effects. You would see things floating in the distance. You would see flipped images. It would be like a chaotic, distorted environment that you would be looking at. But the observations that we're presenting, they look exactly the same from a distance as it looks close up, right? That's why I showed you, this is what the windmills look like from close up. And then here's a screenshot of what the windmills look like from the shoreline, 11 miles away. It looks the same. We don't see crazy refraction. We don't see crazy miraging effects or anything like that that would be a byproduct of this extreme refraction that would have to make this observation work on a globe. Does that make sense?
I'm still thinking about it.
Yeah. There's a lot of information.
You did talk a lot, and I'm trying to process all the information. I'm not going to say that I understand and I agree without really processing.
Well, it wouldn't be agree anyway. This is a fact. Agreement or disagreement wouldn't change measurable physical reality.
Well, you can't really measure things in a vacuum. It's not possible. You have way too many confounding variables. Like the atmosphere, you told me about them just now. Like the atmosphere, you told me about.
Yeah, that's just the way that that's just the way the refraction coefficient model works. Okay, so if you go and use an Earth curvature calculator, like Walter Bislin's, okay, so Walter Bislin's, it's like an anti-flat Earth sort of Earth curvature calculator. So if you go on that, wait, I'll try to find it. It has a refraction slider, okay, and it goes between 0 and 1. 0 would be, hypothetically, if you were doing the observation with no atmospheric refraction at all, essentially what it would be like in a vacuum, with 0 refraction, with 0 change in the refractive index. Okay, it would just, the horizon would be at exactly 1.2 miles, or 1.225 miles away if you were a 1 foot observer height. Okay, and then they call standard atmospheric refraction, you slide that up to 0.13 to 0.17. Okay, and that would be standard atmospheric refraction. Okay, so that's like 8 to 15%. And what that 8% to 15% is increase of the radius of the globe. Okay, so the radius isn't 3,959 miles anymore. It's actually a bit more than that, right? 8 to 15% more. And that would be called standard atmospheric refraction. It would just allow you to see a little bit further than what you would normally see. Now, you have to slide this slider up to explain the observations that we're presenting you all the way to maximum setting. And then if you look up what maximum setting is on this calculator, it's 1. And it says on the website that the calculator's on that if you have a refractive index of 1, that means the Earth would look flat. I'll show you examples as well, and I'll send you the links. So just give me a second. All right, so here's a link to the calculator. They call it the Advanced Earth Curvature Calculator. And now I'll find the section on the website where it says how if you had a refractive coefficient of 1, then it would make the Earth look flat. Okay, here we go. So it says right here, okay, so K equals 0. So refraction coefficient is K equals 0. If the light rays follow the Earth's curvature, which is quite possible. Okay, so it says K equals 0. It would match up perfectly with the globe. Mathematics. The horizon would be at the exact calculated distance away. There would be no atmospheric distortion at all. Okay, and then it says here, if K equals 1, in this case, the Earth appears flat.
What is K again?
It's the refraction coefficient. Okay, so it's kind of like where they beg. It's a begging the question fallacy. Okay, so they're pre-assuming that the Earth's a globe, and they're trying to reverse engineer what we see in observations by saying the light rays are bending X amount around the globe back to your eye. So here's the section on the same website here, where it says if the refraction coefficient is 1, then the Earth would appear flat or even concave. Okay, so when I put in the metrics of these observations into this calculator, you basically have to slide that refraction coefficient up to 1 to be able to explain the observation on a globe. Basically, that there's so much Earth curvature that the Earth would be a globe. That the globe would look flat. Okay, and I'll post
What did you select the temperature as? Did you select it as 20 degrees Celsius?
It depends which observation that you're putting into the calculator.
Okay, so there's the refraction.
So quite a lot of these observations, people don't know exactly what the temperature of the water was or the temperature of the air was, but luckily, quite a lot of the flat earthers have taken that into consideration, and they'll give you the weather report, which will say what the water temperature was and what the air temperature was. So what are you putting in? Like, which observation are you putting into the calculator? Because this is what people do, right? They use that calculator and they'll just put in the distance, like the height, right? They'll say, 1 foot height, distance 9.4 miles, and then they'll slide the slider until it works on a globe, right? That's ridiculous, right? That's just reverse engineering until it works on a globe, and just pretending that there was a certain refractive index happening between point A and point B. Absolutely ridiculous. That's what most people use that calculator for, trying to reverse engineer observations. Okay, so if you wanted to find an observation that matches, like that's claimed that this observation matches the globe, you would have to know exactly what's going on with the refractive index between point A and point B. And there's a bunch of factors.
I'm trying to replicate what you have, the calculations that you have, on the tab. So I'm on the refraction
Okay.
tab. What should I
Okay.
select to see the same things?
Well, hold
that
on.
you're saying?
I'll put it up on my screen as well, so
Yeah,
I can
okay.
see. I'll help you put in this stuff.
Or you can just take a screenshot.
Yeah, I have screenshots, but hold on a second. So what have you put in so far? We've got observer height.
On the basics tab, yeah.
So what did you put in for
Just
observer
left it.
height?
I left it default 5.5.
5.5 what?
Meters, I'm guessing.
Okay, but which observation are you trying to put in? Are you trying to put in the Walter Bislin observation? Not Walter Bislin, the Dr. John Dee observation?
We can put the observation that makes the Earth flat, like how the Earth would be without, like in a vacuum, for example.
No, in a vacuum, if it was a globe, it would match up perfectly. Okay, so the horizon would be at 2.29 miles away if the Earth were a globe. That's what we're testing for. We're not testing for flat Earth, right? Obviously, it already looks flat. Okay, we're testing. People say that it looks flat, but really it's a globe. That's what we're testing for. We're testing for that curvature that would have to be there if it's a globe.
Okay, I'm looking at the screenshot. So this measures the curvature of the Earth, assuming that it's a globe.
Yeah, this is an Earth curvature calculator.
Okay.
So you're gonna put in all of your metrics from an observation, and then it's gonna explain how it should work on a globe. Okay, so the observer height's 1 meter.
It's 1 feet.
1 meter.
1 foot. Okay.
Yeah, mine's in metric. Is yours in metric?
Sorry, DJ. Sorry to interrupt. Yeah, I'll start. When you have a second, maybe look at the ones I sent you there. What I put is not the same as the one you guys are talking about. I just wanted to throw that in there to corroborate it as an example. So yeah, finish with DJ and then check this out after.
Okay.
Yeah, they're different contexts.
Okay, so we've got observer height 1 meter.
Okay.
Okay, target distance 18,024 meters. That's 11.2 miles in meters.
18,000 and what?
24.
And the target size?
Forget the exact size of the windmill towers. Just give me a second. $140 meters from sea level to the tip of the blade.
140?
Mm-hmm.
The refraction? You said 1? Or
We'll leave that for the end, right? Because
okay.
Yeah, that's what we're trying to show, how you would have to have so much refraction it would make the Earth look flat. Okay, so let's put in the rest of the details first. Okay, so the focal length at maximum zoom on a Nikon P900, which was the camera that was used, I think it's 2,000 or 3,000 millimeters. Let me check. 2000.
2000.
It doesn't really make a difference, but yeah, we'll put in everything as we should.
And the diagonal FOV. What is the next one?
Yeah, I'm not sure what the diagonal field of view. I'm guessing that stands for. Mick, do you know what diagonal field of view means? Does it mean the angle that he has the camera set on?
I have no idea on that. I've never had to work with it. I just left it for the default for any of the attempts.
I would just leave that as the default, and we can dig into exactly what that is later on. I don't think if you change it, I don't think it makes much of a difference. Last time I remember that. Okay, so model globe. Okay, and now if you scroll down, it says nearest target data.
Yeah.
Okay, and it should say hidden. Okay, so hidden. Okay, so now we're looking at the just a second. I'll just repost the thing we're talking about, the actual observation. Just a second. Okay, so what we're looking at is the how much would be missing of the bottom portion of Windmill Tower 6. Okay, so how much it should be hidden behind the curvature of the Earth, obstructed behind that horizon. Okay, so if we go back to the Advanced Earth Curvature Calculator, it says 16 meters. Okay, so 16.39 meters should be hidden behind the curvature of the Earth. Okay, so obviously...
4 meters for me.
Huh?
It says 4 meters for me.
All right, well, I'm going to take a screenshot of everything I put in, and you can check if you put in the same thing. Okay, observer height 1 meter, target distance 18,024 meters, target size 140 meters, refraction 0, because we haven't added that in yet, because that's what we're about to test. Zoom F, focal length 2,000 millimeters, and then just leave diagonal field of view at 1.23945.
Yes.
Okay, so then when we scroll down to nearest target data, it says hidden 16.3985 meters.
I don't know if I selected something different, but it will show you.
Okay, so I'm going to post what I'm going to post in the chat.
Did you forget a 0 in the 18,000? For example?
I forgot a decimal point.
Ah, there we go.
Wait. Oh yeah, it was the refraction. That's why it was giving me a different number.
Okay, now
it's 16 meters. Yeah.
So now what you need to do is you need to try to make it work on a globe, right? Because clearly with 0 refraction, it doesn't work on a globe, right? It should be hidden behind the curvature of the Earth, and the bottom 16 meters should be obstructed behind the horizon. Okay, so now you have to start just sliding up the refraction slider. Okay, so slide it to standard refraction, 0.17. Okay, so even now we've applied standard refraction. Okay, that's what you would probably should apply here, because we have very, very clear conditions, right? We have very, very near uniform water and air temperature. We don't see any miraging effects. Okay, so we can say that, okay, maybe if the Earth were a globe, we could fairly say that this would be standard atmospheric refraction conditions, okay? So even going at the high end of that, which would be 0.17 K factor, then there should still be 12 meters hidden of the bottom of the windmill tower. Okay, so now you have to start going into like extreme refraction. Okay, so you're gonna have to start sliding it up, up, all the way to. Okay, you want to have 0 hidden Okay, so now I've had to slide it up to a K factor of 0.97 for it to have 0 hidden on a globe.
For me, it's 0.999. That's the refraction? Yeah.
Yeah. Okay, so it's approximately 1. Okay, so it's basically maxed out. Okay, so all right, so now I'm going to go to my ChatGPT. Because you can research this on your own if you want, but it's going to take you time, right? You have to learn a bunch of stuff. Let's just go to ChatGPT just for the moment. Okay, this is what I'm going to type in. Now I've done all of this before, and basically what it says is what I said before, right? So that would be such an extreme condition. It would be near ducting. It would be extremely rare, right? It would be extremely short-lived. It wouldn't be something that would be consistently observed. And then if you ask it, like, what would you see optically? Would there be a lot of distortion and miraging? It would say, yeah, it would be chaotic. Okay, you would have extreme distortion and miraging conditions, things like that, right? Floating objects, inverted images, and that kind of thing. And then we've got observations where they've done the observation like during the day, and then also during the night, right? And it looks exactly the same at daytime and at nighttime. Okay, and then you could ask your ChatGPT, okay, well, I have the observation done during the day and during the night, and to make it work on a globe, right, you would have to have a refraction coefficient of 0.99. And it would say that that's impossible. It's not possible. So yeah, you can do some more research on that, but look,
yeah.
According to even Walter Bislin's Advanced Earth Curve Calculator, right? It's basically trying to debunk flat Earth, right? He's like an anti-flat earther. He hates flat Earth, and he's put a hell of a lot of effort into this Earth curvature calculator. But it very clearly says here that if the refraction coefficient was 1, it would essentially make the Earth look flat. So to reverse engineer these observations to make them work on a globe, you have to assume there's so much refraction the Earth looks flat, and the observations don't have any like crazy distortion or anything like that. So this is how crazy it is to suggest such a thing. Okay, really, the horizon's at 2.29 miles. Okay, there's a physical geometric horizon cutoff point at 2.29 miles. Okay, less than halfway to the windmill towers. Everything beyond that is just an optical illusion. It's not really there. Okay, it's just appearing, right? So somehow the way the light rays are bending is making everything like lift up to the perfect level to make the entire surface of the Earth look completely flat. It's also lifting up the entire windmill farms and the boat and everything else in the scene just to the perfect level to completely hide that the geometric horizon is really there and just flatten everything out. And then it's the same on different days in different weather conditions, and then daytime and then nighttime, and then different locations all around the world. The same thing happens. It's impossible.
Yeah, this kind of model is impossible to happen in real life, right? With like almost 1 refraction.
It's like super rare. Like it could apparently it could. I've never seen like even if you try to look up like an observation where you have this kind of refractive index and it's been validated that this is happening, you can't find any footage of it. If you try to look up like ducting, atmospheric ducting observation through the air, nothing really comes up. Yeah, it's not something that it's like super rare. Like even AI engines will tell you, yeah, it's like super rare, and then it wouldn't happen like consistently. That wouldn't be possible.
Or even
it wouldn't. Last thing, it would also be impossible to happen with no optical distortion, right? You would have crazy miraging effects, because what happens once according to the mainstream, okay, what happens once you have a change in the refractive index gradient caused by temperature a temperature gradient, a vertical temperature gradient. Okay, once it gets like a very high temperature to a very low temperature, or a very low temperature to a very high temperature, you start to get miraging effects, like typical miraging effects, like mirroring, kind of like what you were posted before in that John D observation. Yeah. You get inferior mirages and superior miraging. Those come along with kind of like consequential extras, right? Like total internal reflection, like when you look down the road and it looks like there's water on the road. It's kind of like a mirroring effect. It's called total internal reflection. That's a byproduct of an inferior mirage. It's something that comes along with it. And it's super obvious. Okay, so if you're looking out and you can see this like mirroring effect, you know that you've got like inferior or superior mirage happening. It doesn't happen when you have these very small changes in the refractive index and you get like a little bit of sinking or looming. Okay, this is once you start to get a drastic change in the temperature gradient, that's when you start getting more extreme miraging effects, right? And then once it gets really extreme, you start getting like Fata Morganas and things like that. I'll show you an example of the kind of thing when the refraction is very, very crazy. Okay, so 1 second. And you could never present an observation where you've got these crazy miraging effects and say it proves like it debunks the globe or proves the flat Earth or something like that. Would be ridiculous. Like have a look at this effect, right? This is the kind of thing I'm talking about. You wouldn't use this observation for anything, right? Because you've got like a Fata Morgana's type situation. You've got a bunch of towering. You've got bands of like hot air and cold air, and it's causing like a big chaotic scene, right? That's what AI will tell you should be happening if you've got this extreme refraction effect taking place. But if you actually have a look at the observations that we're presenting, this isn't the case, right? So let me show you these same oil platforms again at a time where you would want to present the observation. Okay, so the same oil platforms in really, really nice conditions would look like this. Okay, so this is the same location, similar location, same beach, same platforms. But in this one, right, we don't see all of that crazy distortion. It looks pretty
distance?
Good. Yeah, pretty much the same distance because the observations are done from the shoreline of the beach. So it's roughly between 9 to 10 miles away in the second one here. It's 10.1 miles to that second oil platform. It's the same platform that you can see on the right. So you can see in the top observation, it's just from a little further to the right down the beach, right? So he's looking out just on a very, very slightly different angle, but from the same beach, because there's only one beach there. Okay, so it's approximately 10 miles away. Okay, so in this observation, we can see that once again, the horizon isn't where it should be on a globe. So this is done from 8-foot observer height, and the horizon should be halfway to that first oil platform. The first oil platform 6 miles away, called Platform C. Okay, so that's what the globe earther will say, is that really there is a horizon at 3.46 miles away. That's where it should be from an 8-foot observation height. So really there is a horizon there. But everything beyond that horizon is just being refracted, right? It's not really there. It's just an optical illusion. It's just completely perfectly hiding where the geometric horizon is, and it's making the horizon pop up beyond the oil platforms, right? Past 10 miles away. That's impossible.
So in the latest video, did we have what's the refraction that's showing? Do you think?
I can get into that one. I was just going to ask a second ago. DJ, do you happen to have the Black Swan observation from the 1-foot observer height on hand?
Yeah, I do, and that would be a good one to put in because we actually have we know that the temperature of the water and the temperature of the air are almost exactly the same. So that's a great one to use. So do the 1 foot, the 1 foot observation height one. I'll put in the
cool.
So I'll put in the video and stuff, and you can go over the.
Perfect. Yeah, because that's what I posted earlier, All Star, at the 42 minutes past the hour. Those two screenshots, they represent same sort of exercise that you guys did a minute ago, right? But this one's for the furthest oil rig. Okay, so in that last video that you just saw, that's at 10.10 or 10.10 miles away. The other one I was just asking about, same beach, different position, similar distances, and it's a little bit closer, I think. About half.
It's 9.4. It's 9.4 miles away. So this is the observation. So it's the same person at the same location, but on this one, he gets his camera down to about 1 foot height. So there's the GIF there. So he's looking out at the same oil platforms, but it's 9.4 miles away because he's a bit further up the beach.
There you go. So when you do the work on that, okay, you see that the necessary refractive index to achieve such an observation is in the ballpark of what you guys did for the other one. So on the second image that I did at 42 minutes past the hour, same thing, refraction index necessary of 0.989182. Now, in this case, the zoom F and the diagonal, those were different defaults. For some reason, now I'm not sure why. Maybe it's just because they're different units. I don't know. I didn't touch those deliberately. But yeah, same thing. Extremely high refraction index. Doesn't make any sense. Now, I do recall, I think India was talking about this, DJ. Walter Bisland actually posted an article. I can probably try and find it in a minute if you guys want. Trying to explain this whole thing away. And what you notice in his article, he posts some data that he would have gathered from the model that he was using to justify everything. And the data shows some graph depicting the necessary temperature gradients or something that would be contributing to being able to see it the way we do. And the graph, it depicts that over, I think it was between 10 and 20 feet. Okay, so let's say from top, just above the water to 15 feet up in the air or something like that, you would need like a 10 to 20 degrees Fahrenheit or degrees Celsius change in temperature in that short of a distance. Some crazy kind of value like that. Like when DJ was saying, like, it's unlikely or not, inconsistent. I mean, like, this is impossible, dude. You know what I mean? Like, shit like that, it makes you really think. Now, I'll try and find the. I think I actually have it. Give me a second. I'll give you the graph.
So, since I guess we assume that the Earth is flat, can we get a 0 meters hidden in the nearest target data section? Is that possible?
Well, that's what we're getting here. There's no hidden height.
Yeah, only if you increase the refraction to almost 1, then you get the hidden to be 0 meters.
But that's if we're on a ball.
And if we're not on a ball?
If we're not on a ball, we don't have to play with the refractive index. What we see is what we get. Right? There's no hidden height.
So
anyway, didn't want to cut in too much there, DJ. If you want to continue on that, there, I'll get that graph for you in a sec.
So you assume there's no refraction because the Earth is flat, right? Because you said now if there's refraction, then that means we are on a globe.
We're not.
we're not assuming no refraction in these calculations. What we're doing is depicting what the necessary refractive index would need to be if we were on a ball to achieve these results. And we see that these indexes are absurdly high. They don't happen. What they actually are, you need to go out there and gather all the data points. You know, and technically that should have been done all along on their side to try and justify it, but instead they backwards engineer a value, as DJ was pointing out to you before.
How did they even come up with that to vary the specific amount of refraction? So if we're seeing through like the medium of air over a distance, how are we able to quantify that in a real way? Does anybody know how to do that so that we can extract the value between target distance?
Niggers.
I think even Yoder's point out that there's no real way to do that.
Yep.
Because things are so turbulent.
That's the important part.
Yeah.
There's no way to do that. Therefore, any numeric value that you ascribe to it couldn't be the thing that you're actually seeing from a point of observation to a target distance.
Yeah, there's no way to verify.
So all the numbers that are being tossed around can't be tested. So you can't say, oh, well, there's this much refraction, and you're putting it through some sort of numeric value, and then you're going to be able to go out and test that numeric value because the fluctuation of the ambient temperature outside between point of observation to the target distance is going to be variable. That's going to be variable. The air between you and the target distance is going to be variable, so there's no way to actually quantify this in a meaningful way to extract the numeric value. Therefore, the pursuit of this is pretty much futile. Unless you can prove me wrong. I mean, I'd like to see that.
Under which conditions would the Earth be flat? When we have a refraction of almost 1?
No. Okay. Yeah, you're trying to ascribe a numeric value to the thing that I'm saying you can't put a value to. Do you understand? I don't know if you do or not. Like, the point's not landing. If you think that you're trying to move a refraction to the value of 1, that means that you're trying to give a numeric value to the thing that you can't put a numeric value to.
You can put an average number of it, or just measure it on site.
No, absolutely not.
You can't measure it on site.
It's that thing that you're trying to measure is not quantifiable.
Yeah, because All-Star, what you're measuring, the argument put forth in the past has been the contributing factors to all of this, okay, are temperature, air pressure, and humidity, okay? Now, one would have to gather all or as many data points of these 3 variables across the entire line of sight from from the observer to the thing, okay? It's technically an infinite number of data points.
Exactly that. Exactly.
Right. So, and if they do get less than that, right, it's discretized, right? So it's approximating it. Okay. So then they have to fit that to a model. Now things are so turbulent throughout the entire thing, okay, that to get a generalizable model for this, I mean, it hasn't been done yet, and arguably can't be done because things are so chaotic.
Yep. And then, as you raise up in the elevation or altitude, the temperature between a line of sight and a target, the point of observation to target distance is going to be it's going to vary again because the air on the ground mixing with the air right above the ground is different from that of like raising in altitude or elevation line of sight. So there's compounding variables here that you couldn't possibly put a numeric value to it, even though you want to, like with
That's the thing.
No. I don't think you understand what we're saying here. Like, you can.
I don't think you're understanding too.
You can do it mathematically, but it doesn't change the fact that you are gonna go out and test what you think you're doing. It's a mathematical construct, no doubt, right? There's a, the terrestrial refraction 7/6R with the radius value included, which is also begging the question. But you're going to be able to do it numerically through a mathematical construct. Yes, I agree with you. You can do it that way. But you can't go out and test the actual variance of the ambient temperature from like a refractive index that you're going to create based on a model. It can't be done, sir. You're not able to, like, the target distance to like where the point of observation is, the space in between those two it varies too much. There's too much fluctuation. And not only that, like the angle at view that what you're seeing from the ground to the, like let's say a 6-foot man at sea level is going to vary when you raise an elevation with a line of sight to a target distance from a point of observation of a different elevation or a different altitude. And this is important, right? Because if you're doing this, if you're trying to quantify it, you need to have values that you can ascribe to then put us like for lack of better words, a science to it. And nobody can do this. You can do it as a mathematical construct, yes, but you can't actually do it outside to know what you're seeing is exactly like the numeric value. Doesn't work like that.
I think he's a little bit confused at the moment, which is fair enough because he's posted a link to math.ubc.california about Snell's law. Yeah, so he's confusing Snell's law with atmospheric refraction, which would be exactly what AV was just talking about, and how variable it is and how they can't really model it out properly, even according to their subject matter experts, right? They have whole sections where they explain how different Snell's law is, and you can't apply Snell's law to this constantly changing single medium situation, like with the air. So just quickly, okay, so you've put in the law of refraction. That's Snell's law. Okay, so that's a very specific scenario when you've got two different isotropic media and you've got like a light ray traveling on an angle from one medium with a particular refractive index and then entering a second medium through a sharp boundary layer with a different refractive index, and that's used to calculate the deviation in the light as it goes from one medium to the other medium. It requires two mediums, it requires a sharp boundary layer, and it's a very specific thing. It's very easy to model and very easy to use for specific scenarios where it's useful. It's not useful in the scenario where we have like the atmosphere, just like AV explained to you just a second ago. Right, and just one last thing, just to give you like an analogy. Okay, so here's something that I wrote down like a while ago, right? So Snell's law is like hitting a sudden patch of mud on the road, right? So you're driving down the road with a car. So Snell's law is like hitting a sudden patch of mud on the road. One clear boundary, your car jerks in a new direction, right, towards the denser medium. Okay, atmospheric refraction is like driving gradually into thicker mud. The car slowly curves without one sharp turn. Both are the same phenomenon, a change in direction caused by a change in medium. So if someone says atmospheric refraction isn't really refraction, they're making a category error. Snell's law is a tool, not the definition of refraction. Okay, so refraction is simply the change in direction of a wave as it passes from one medium into another or through a gradient in the same medium. Because the wave speed changes, the light slows down or speeds up depending on the optical density of the medium.
Okay, there's a charge coupled device that you can use to measure those things. The things that you said they can't be measured.
Yeah, but you're using. Did you hear what he said about Snell's law? I don't know if you are bypassing that.
I did.
Okay,
so look at the diagram. Look at the diagram they provided, right? It's showing a light ray, okay, going from one medium to another medium, right? It's like air to water, diamond to air to glass, that kind of thing. Okay, and it's
you are using a camera. You are using a camera when you're looking at the thing. You're not using your eye.
But
Even your
it
eye
doesn't
is
matter if you're using your eye or you're using a camera. You're looking through a single medium. Okay, so that's what you're doing here. You're not trying to measure, like, the refraction effects isn't caused by the camera lens, right? As the light ray comes from all the way through the single medium of the air and then goes through the camera lens into the sensor. That's not what you're trying to calculate when you're talking about atmospheric refraction. Okay, I posted the American Meteorological Society official definition of atmospheric refraction in the side chat there. And it says clearly in there, atmospheric refraction of visible and near visible light usually is dominated by temperature gradients. Okay, it's not a Snell's law scenario, and Andrew Thomas Young has a whole section on his website where he talks about the difference between Snell's law and how easy that is to model and how difficult it is to model atmospheric refraction. That's why these websites will have one section for Snell's law and a completely different section for atmospheric refraction, because it's not the same thing.
So how do you determine the refractive index of a substance? Like of an object?
Well, that's something that's been well established, right? The known refractive index of a specific substance has been well recorded, and it's temperature dependent. Okay, so at 17 degrees, then this particular substance will have this particular refractive index. Okay, if you wanted to use, so because all these observations are through the medium of air, okay, and the primary controller of the refractive index when it comes to air is temperature. Okay, and it only changes it a little bit. Okay, a really, really small amount. I forget the exact amount, but it's not much. But it's enough to cause these mild effects that we see.
So what kind of model would show?
Well, you would need it's something, right? So they don't have a model for it. They don't have a model that you can just apply for it because it varies so much. That's what AV was explaining to you, right? So between point A and say we have 10 miles. Okay, so between point A and point B, you could have pockets of warm air, pockets of cold air. Okay, you could have generally cooler air closer to the surface if you have cooler water than air temperature, or the opposite if you have the opposite of that. You can have pockets of air. Then you've got to take wind into consideration because wind's blowing all of that hot and cold air around. It's constantly changing. Then you've got to take humidity into account. You've got to take all of these things into account, and it makes it like a big, giant, chaotic soup.
Yeah, you remember the photo that was taken over Lake Pontchartrain? I don't know if you've ever seen that. There was brackish water that was that specific day that Soundly was taking his pictures. Indio has the details on that, like the temperature outside and such. And over the area where he was taking a photo, and it looked like there was something happening in the image. Like there seemed to be some type of curvature, like in the photo. And a lot of the Globers clinged onto it, saying that it was the curve of the Earth. But because of the fact that the way the air was like between the point of observation where Soundly took that image and the far distance where he was trying to see the furthest, electrical pole, it just seemed like there was something optically happening. So because of the fact that Soundly didn't understand, he just assumed that it was Earth curvature, and it was proof of that. So this is the reason why that we get into these conversations with people, because they've been taught to believe that all they see is curvature when there's optical phenomena at work here. And we have evidence that the optical phenomena that's at work here is evident through a time-lapse footage, which we have like with Skunk Bay. There's other time-lapse footage that I think Indio has some too. People come up with you can do a time-lapse footage anywhere you are over a body of water. You'll notice that the visual target distance will always look like it's fluctuating, or it's like wiggly, or but you can never quantify that. It's a qualitative viewing description. So
specifically like with the miraging effects, right? Which is why there people that try to ascribe some sort of variable to it, some sort of number, are not able to, because like as DJ and me and anybody else that wants to talk about it will explain to you that it's not able to be quantified. You can't ascribe a numeric value carte blanche and say that it's going to go from where you're at to where the target distance is, because the more distance you increase, the more variance is going to happen. You're increasing the turbulence between you and the target distance. And these are just well-established facts. You don't have to believe me. There's just no way to quantify it. I mean, sorry, but there really isn't. If there was, we'd have the table to actually look it up and be able to talk about it. But there isn't. So
what is the proof that the Earth is flat? Like, what do you have? Any kind of proof?
Yeah, line of sight. So line of sight to a target distance is always straight, right? So we see something in the far distance, and that distance that covers the line of sight will be something greater than the amount of curvature that should be there predicted by the Earth being a globe. So the surface of the Earth being a globe would have a specific numeric value. Now that is something that's like written in stone. So if you look at how big the Earth is, online, you take the radius, the diameter, the circumference, and you apply those values to a observer height. Let's say you're a 6-foot man, right, on sea level, looking across, like, let's say an ocean. You'd be able to only see to a certain distance based on your height, because the curvature of the Earth would then be obstructing your view from anything beyond that. So there would be a geometric horizon distance that you could measure to based on the curvature that should be there if the Earth were a globe. So when we do line of sight, target distance to the horizon or any other thing that we see in the distance, what happens is that predictable distance that should obstruct your view based on the Earth being a globe does not obstruct your view, which means that you can see farther than the expected curvature would allow you to. So the curvature for a 6-foot man looking across the distance should be somewhere in the range of like, you can quote me if I'm wrong here, but like 3 miles, somewhere in that variance, right? And, you can say give or take because of what you might consider as refraction, terrestrial refraction, with the 7/6R and such. But yeah, to us, it's important because you can't, there's no way to quantify that in a real way to extract that you're looking over a distance with the Earth being a curve. So what we see is a distance greater than the expected curve would allow you to see. So we don't see 3 miles, we see like 20, 30 miles away. And the curvature should have far exceeded that viewing distance. Like it should have prevented you from seeing that thing that you see at 20 to 30 miles. And we have line of sight observations that far exceed even 20, 30 miles. Well, I'm saying all of this to say that a test with line of sight will always show that we can see far past that geometric curve that the Earth would be obstructing your view, determining that any distance over water, because water's mechanics are such that you have any body of water at rest will display no convexity. That means it won't be curving on its surface. So you can see over a body of water that there is no curvature to be measured because the mechanics of water are such that water lays flat on its surface because of surface tension. So understanding the physics of water compounded...
All Americans get something like flat earth.
Yeah, just I'm always about done. So
what's a flat earth?
Yeah. Well, I'll answer your question in just a moment. So the water is flat on its surface, and when you're doing a line of sight target from point of observation to a target distance, which would be the horizon in this case, you don't see the curve of the Earth obstructing your view, and that's the most important. Yeah, did that make any sense? I'm trying to lay it down so that we don't get too convoluted with how the explanation is, but definitely you see a lot farther. Yeah.
Let's say you're in the Sahara, right? You're
Sure.
standing somewhere, and you see in the distance. You think that you see something, but when you actually go to that location, you don't see that. You don't see that object that you saw before. Does that mean that it disappeared, or were you imagining things, or
Yeah, these
was
are
it real?
Yeah, these are effects of mirage. So the miraging effects that occur are categorized in different ways. There's inferior and superior mirages that occur over a viewing distance, depending on the distance, right? So the greater the distance, the more turbulence you'd have in the air between you and the target distance, which would be the thing that you think you see, right? And anybody could probably talk about this because we all see this like on a hot day. You know, the road looks like it has water over it, like over, not even a mile, I would say, away from you. And that's not true because, there's a shimmering effect. It's called heat haze. It's a type of inferior mirage that occurs. And heat haze or shimmering occurs when, the surface of the ground is mixing with the air above it, which causes like a mirroring effect, which then reflects like the sky, which of course you see it looks like a clear mirror or a mirage like water, that effect, I'm pretty sure you've seen it. That effect occurs. So it's light actually not being able to penetrate that layer, which you're seeing that effect. So the miraging effect is only it's qualitative, not quantitative. So we can see something happen and we just don't know the exact amount. You get me? Like you can categorize it and say, I know what type of miraging effect it is. I just don't know the exact amount of it. Like there's not like, you could give me a numeric value to ascribe how much of that effect you see from where you're at to where the distance is, because it's fluctuating. So there's never going to be a static numeric value that you can ascribe to it. It's a miraging effect that occurs, and it's qualitative, not quantitative.
But it is possible for this kind of effect for you to see it over water, because the water could be cold and the weather is warm.
Yes, you're correct. Yes, that's correct. Which is it's another way to describe something that and we have. I don't know if you guys can put this up or not. I'm a bit busy, but there's a GIF of a dolphins jumping in the far background over what it looks to be like, like they're jumping in the middle of air. But there's a miraging effect that's occurring at the very layer of the horizon where you can't really tell where the water is. So exactly what you just said is what happens in the water as well. I mean, it happens over any surface, really. So long as you have a disturbance in the air temperature with the ground and the right above the ground. So it's not something that people actually want to look at because it debunks the fact that they think that what they're seeing is curvature. So when we get into these optical effects, what happens is that we get a better explanation than what somebody would say is just Earth curve. So then now we start to talk about like, well, how much distance do we need to have between us and the target to say that how much effects we should see? And not only that, dude, like I'm telling you, this subject is pretty much, it's a huge topic because of the fact that we got like the opaqueness of the air between you and the thing that you're seeing in the target distance that makes it difficult for you to see, including, things like dust, fog, smog, different other things like mist, that can cause an obstruction from like what you see in the target distance. It is a huge topic, and it just doesn't end with just curve. Like it just doesn't satisfy, the guy who wants to know, So
Well, do you think the moon landing is real?
Well, that's not what we're talking about.
Hold on a second, because we're just chatting about refraction and whatnot, and Alstar was about to respond to Miggy, but we will get into that. Okay, Sean, soon.
Yeah, just hold tight.
Is it possible for you to explain flat Earth using another explanation?
What do you
Or
want
do you
to
think, is the only explanation for what you see that the Earth is flat, or is there another explanation could be at play of what you're seeing?
I don't like. What do you mean, like another
It's not
type
what
of
we're
Earth?
seeing. It's not what we're seeing that's the argument, right? We're not saying just because we experience the Earth as flat, therefore it's flat. Okay, because if it were a globe from your perspective, you would also not see any curvature from your perspective. We're taking it to the next level and actually going out and testing for that curvature that would have to be there, and there's no sign of it whatsoever. So it's not just that we experience it as flat, that's the baseline, right? So if you believe you live on a globe, you would also agree that you experience a flat stationary Earth as your basic reality. Okay, we don't feel motion, we don't see any curve, right? You'll say that it's because we're so small that we don't experience those things. Really, it's happening, and we're saying, okay, that's a bold claim, and we've gone looking for evidence of that, right? And there isn't any. And then we've gone out and done our own observations, and we're like, all right, look at these tests, there's no curvature. So that's where we're at. We have objective reality on our side. What we're saying matches up with everything everyone experiences in reality.
Can science explain those things?
No, okay. Let's kind of break it down for your mind to understand what we're saying. So there might seem to be an explanation you think that the mainstream science or whatever has for you to, like, they're offering you something. And I would challenge you and I would ask you, because it seems very convenient to say what you just said. But now I'm going to challenge you. What have they said that you think convinces you that it is a globe, so that we can examine it? Let's review what you think is the answer.
I think it can be explained by refraction. Like what you see of the dolphins jumping. You're not really seeing dolphins.
Did you see the GIF?
Yeah.
Yeah, I put it in the sub chat. Yeah.
Thank you. But okay, so what are you saying? You're not seeing dolphins?
Yeah, you're not seeing actual objects of dolphins. You're seeing their reflection of them.
Right. So what do you mean?
What?
Like, what do you mean by that?
It's like your vision goes down a little bit, so it doesn't.
I see. So that you're saying whatever you're seeing is a mirage? Is that what you're saying?
Yeah, you're seeing a reflection of the dolphins.
Okay. So you're not actually seeing the dolphins themselves. You're seeing the reflection of the dolphins over the curve. Is that right?
Yeah. Just
what are they reflecting off? What are they reflecting off? You know how reflections work, right?
Yeah. Do you know what? I'm sorry, man, but do you know what you're saying? Like, do you know what a reflection is? First of all,
refraction.
Refraction. I thought you said reflection.
I said reflection, but I meant reflection.
Okay. So you think refraction's the answer? Okay. Now I want you to make a distinction. What they're jumping over and above, it looks like there's some other layer there, like a boundary layer, that you can't tell if it's water or not, right? Can I get an answer on that? Okay. You can't tell if that's water or not. And then in the foreground, up closer to where the observer is, you can tell that there's water, right?
I can't.
Okay.
Say it again.
So the foreground, like closer to the observer, you can tell that there's water right in front of him, right? Like not where the dolphins are, but closer. Okay.
Yeah.
So just to clarify, we do have a distinction between where the dolphins are and closer to where the observer is. You can tell that there's water, but where the dolphins are, you can't really tell if there's water because it looks like a shimmering effect is there, right? Okay. So we do know, or at least you can qualify that visual observation with something considerably called a mirage, right? You could say there's a miraging effect occurring. You know what I mean? Can you see that? Okay. You can qualify it to say that there is a mirage, right? Am I, like, are we good here?
It qualifies as a superior mirage.
Yeah, you're getting it. Okay, so yeah, and if you look them up, you'll see the different types. There's like 5 different types. Qualified as what they say that they are. And when you qualify them as what you're saying it is, then how did you make the distinction that the curve of the Earth is somewhere in between the observer and where the dolphins are?
Because that's how it appears to be. I have other examples of.
Yeah, no. Wait. No. I mean, how can you know that there's curve between where you see the mirage? Because like you have to make the distinction between what is a mirage and what is curvature. So I need to know where you're making the distinction of where there's curvature and not a mirage.
Because you're not seeing the full object, you're seeing half of it.
Well, I mean, you are seeing to a certain distance, and then there's a miraging effect that's occurring.
Like the dolphins are disappearing.
Yeah, well, they're not. Yeah, they are jumping over this boundary layer. There's a boundary layer.
Yeah,
and then,
only half of them is shown.
Right. So the important part here that I'm trying to get to is, how do you know that right there where the dolphins are is anything to do with the curvature? How do you know that?
Because if there was no curvature, it would show the full dolphins. It would show the actual objects.
Yeah. Okay, wait a minute. So you're saying that miraging effects cannot occur on a horizontal plane, on a flat surface. Is that what you're saying?
Yeah.
Okay, what if we were to... okay, well, just hold on. What if we're to show you that it's possible to have miraging effects over a flat surface? What about that?
Yeah, like a hot street. That's what I can see here.
So, right. So if it's possible to have miraging effects over a flat surface, then it's not far beyond the imagination to think that even more distance, there will still be miraging effects in the far distance on a flat surface.
I guess my question is, why... Yeah.
Okay.
But why do you think why do you think there's a... I guess it's a combination of two things. You have the mirage and you also have the curvature of the Earth. And it gives you the illusion of flatness.
Well, there's two different things to think about here, right? We can have miraging effects on a flat surface. That much you know. That much at least there's evidence of, right? Now, to say that there's miraging effects over the curvature, well, we have to make a distinction where the curvature is, so that we don't say that the miraging effect is happening over a flat surface, but you know that you can say the miraging effect is happening over the curved surface. So you have to make a distinction where the miraging effect is and where you see and where the curvature should be. I don't know if you follow there, but I'm trying for you to get to separate the miraging effect and the curve.
Let's construct a model of this.
Well, I don't know how you get. See okay. Do you remember the earlier problem that we were talking about, is that miraging effects are not quantitative? Like what you were talking about, refraction and all that. You can't quantify it.
But
it's not quantifiable. No, the reality is you can't quantify it. The reality is it's only qualified. So you're describing what you see. You're not quantifying it in a numeric value. There's no way to do that. That's what we're trying to tell you. So
the Earth is hollow.
That seems to be the issue here. So we have an issue. The issue is you can't quantify the thing you're trying to ascribe. How to make a distinction between what you think is refraction and what you think is Earth curve. There's no way to separate those two because you can't quantify what you think refraction is. Hopefully this point is going to land. I hope it does, because you can't make a distinction between what is curve and what is refraction, because you can't quantify what refraction is, even though you think you can. The challenge to you would be, how do you quantify refraction, something that would be incredibly variable between a point of observation to a target distance? You know what I mean? Like you're trying to use refraction as the answer, but it's not quantifiable. Don't worry about that guy. They don't like flat Earth, so they come in here and do that. All right, so you understand that, right?
Yeah.
So if you're saying it's refraction, you need to quantify it first, and then you can insert it into the viewing distance, like the dolphins, let's say. Is that making sense, sir? I really want you to, this point needs to land, like it really does.
You said there's no way to quantify it, but I'm trying to find a way to disprove that because.
Well, no, yeah, I
there
want you
is.
to. Like, that's the most important part about the challenge is that you do the research yourself. Like, I can't help you here. You have to actually do it yourself so that you can at least come to a knowledge of like, dude, I tried to quantify it. It's not possible unless you use a standard model, which of course, using the 7/6R equation, like I mentioned earlier, is the only way that you can do that. But there's a caveat to that. If you use that, you're going to have to be able to tell me how much of it is in the viewing distance when we see certain observations like the dolphins. So you know what I mean? Like, you're going to have to apply that same method to a viewing distance. Sure. And it has to be something that we can say, we have like a gold standard. We're going to be able to apply to a point of observation to target distance at any distance. So we'll say, with increased distance, of course, you'd have more of the thing that you think you have in a numeric value that you can ascribe to the viewing distance. So we're waiting for, like all of the flat earthers are anyway, somebody able to quantify what they consider refraction being, and then give us the gold standard so that we can apply it to a viewing distance. I hope I'm challenging you, sir, because I think that is.
I am. I'm looking it up.
Okay. Like, I'm not just whistling Dixie here, man. Like, everybody in here has tried doing this, and it's not possible. Like, we've looked up, like, even the experts, subject matter experts on what you consider to be refraction is, they understand the very same. And using Snell's law is not really going to help us here because we're looking through the medium of air. So Snell's law is applicable to things that have a contacting media. It's a boundary layer between two contacting media, like air and water. Like when you see, a fish in water, when you're looking down like a pond or something, the fish is not actually where you think you see it because of the fact that, it's being refracted through the water boundary between the air and water boundary. So yeah, I think it's more akin to Fermat's principle. If you look it up, Fermat's principle. So we're dealing with a lot of distortions and we don't have a way to quantify it. This is the challenge to you. We don't have a way to quantify it to then therefore say that we're seeing something like the dolphins, that GIF of the dolphins, and then apply it to that to then extract how much distance between us and the horizon there should be using a refractive, equation or, method so that we know how much refraction there is to then say, the Earth curve is separate from that. So it's almost like, dude, I'm being honest with you. It's an impossible task that you're being tasked with right now. But I mean, if you want to shoulder it, that's up to you. And that hopefully you can see for yourself.
Hopefully. Thank you.
Yeah, thanks for the challenge anyway. But if you do come up with that or you want to keep talking about this subject, go ahead. But if you want to have some time to look it up, maybe, or I don't know what you want to do, but DJ, if you.
Yeah, refraction is the globe's worst nightmare, which is funny considering they're the ones that bring it up the most. And refraction is flat Earth's best friend as well, because it's the globe's worst nightmare, basically. It makes it very easy to explain their boats over the horizon argument or their this thing in the distance from this cherry-picked image looks a little bit lower than what it should, right? The globe earthers don't have one observation throughout all of history made by one person where an observation lines up with the globe and has had the potential, the variables, right, that would have to be taken into account to make such a hyperspecific claim, right? They haven't taken the variables into account that they would have to be able to make such a claim. Not one. Even if we were to give you like the standard refraction or whatever, it's still like I've never even seen one that even fits in with that, right? 8 to 15% or whatever you want to call it. 7/6 there's not one observation that even taking that into account, even though it's begging the question, we can grant that to you. It still doesn't even. There's not one that even aligns with that. We're seeing 500% further, 1,000, 2,000, 3,000% further constantly than you should see on a globe.
Yeah, he's right.
Essentially, so much refraction that the Earth would have to appear flat. There's that much refraction.
It's funny though, because you think about it is a glober's worst nightmare, man, because they don't know how to get out of this. And the only way to get out of it is to prove it. If it's actually happening, then, it would be a, quantitative description. Be able to ascribe numeric values to it. And, we'd have a method. The method would be the gold standard. I'm telling you that right now. It would be. Everybody would be talking about it. We'd all be using it. And we'd be able to explain things a lot easier. It's not there, bro. Trust me.
That's what all of this is about. How do we know that geometric horizon exists in the first place? And how do we know the Earth curvature exists in the first place? How do we know that radius value exists in the first place? That's where we're at.
I have an interesting scenario for you. So let's say you're driving your car and there's a grass field on your right. You look at the grass field and you think that you saw like a sheep or anything that, like a cow, for example. You think that you saw a cow while the car was driving, and then you tell the passenger that you saw a cow in the field. But the person might say that they didn't see anything. They didn't see a cow. They saw like a sheep or something. And when you go back, you see something different. You don't see a cow. You see, I don't know, maybe a dog. Is it possible? So it is possible for you to for your perceptions to deceive you, and that is possible. It is normal. It is possible for the cameras to show things that are not there, even when you just open your camera and aim at the sun, and you will see some lights that are not there because of the lenses. Doesn't mean that the lights are there, but my question for you, is it possible to see those things?
But that's not analogous, right? It's not analogous to anything we've presented.
Is it not?
Yeah.
Really?
Completely. Explain how that's analogous in any way to anything that we've presented or said.
Because you are seeing something like
what? What are we seeing?
The Earth is flat?
Yeah. No. You're talking. Hold on. No, I know, but I'm saying you have to do it analogous to what we were saying, based on your analogy being something that could be comparable. So you said something about looking at a cow, and maybe it's not a cow, right?
Yeah.
Okay. So using that example, how can you correlate that to what we said about not being able to quantify it?
So you see the Earth is flat, right? In front of you. It's there. You see it on the camera, you see it with your eyes. That is proof to you. But it may not be the case. It may be something else. There may be a different explanation for that phenomenon that you're seeing.
So we're seeing flat, but it's not actually flat. Okay, so
yes, that is also possible. Yeah.
Yeah, so the challenge would be then, if it's not flat, then can we come up with a way to determine what it is based on what you're saying?
I would have to look it up, to be honest. I don't have all the answers.
I mean, that's where we're at, sir. That's where we're at right now. We're at the point where you're trying to make it like, okay, how can you tell it's actually flat if you're saying that we're seeing distortions between you and the target distance? And I gave you a good reason for it, right? So you can look it up. It's the mechanics of water. So do you understand how water on its surface lies flat and horizontal? Or I don't know if you don't know this principle or not, but I'm asking you.
What did you say?
Water.
Water.
The surface of water, when it's not disturbed, lies flat and horizontal on its surface.
Yeah.
Do you know this as a fact, or do you think it's just like I'm just telling you this because I'm a flat earther?
That's only if there's no air or any variables.
Yeah. Okay, that's good,
Yeah.
good stuff. So the mechanics of water are such that water lies flat on its surface when undisturbed. Is that correct?
Yeah. Okay.
Okay. Let's take that principle and extrapolate that out to a large body. You know, a lake or whatever. Same principle. You with me?
Yes.
Okay. We still got flat water. So the mechanics of water not only display that, but will also over distance be horizontal. You still with me?
Yes, to some point, because
Okay.
you, of course, you have
that's
the
okay.
cold
That's
water
good.
and
That's good. So at what point does that mechanics of water change to not being flat on its surface? What point? I want to hear your argument for this. And it needs to be something sound, right, as in physics or something that I could demonstrate to the audience or you could demonstrate to us.
yeah, the air would be hotter and the water would be cooler or colder.
No. I meant the water itself being manipulated in such a way that it's not flat anymore.
Oh. So you would see like waves?
No. I'm not talking about a disturbance. We're still talking about when there is no disturbance.
Okay. Which is isn't that impossible to begin with?
I know. What I'm saying is, have you ever seen a placid lake when there's no air?
Yeah.
There's something called a specular reflection. Do you know what I'm talking about? It's like
No.
okay. There's an image of like a mountain in the far distance in the background, and then you can see it reflected on the water. This is considered as a specular reflection. It's categorized as that. There's also the Salt Lake. Not Salt Lake. The Salt Flats.
I got a great example. I'll put it in the side chat for you.
I think I know what you mean.
Thank you. Yeah,
Like you see a
it's like
reflection of the mountain or something like that.
Exactly that. Yeah. So if we have this reflection, it's called a specular reflection. Yeah. So it's categorized that way so that people can understand that what they're seeing is a perfectly mirrored, surface with the mountain or whatever. So now what we're going to do is find out whether or not there's any. If let's do this. Let's apply our thinking of it being the surface being curved in some way, right? So if the surface was curved in any way, do you think the light rays would bounce off the surface horizontally, like on the horizontal water, bounce back into your eye and be able to see what you see, like as a perfectly mirrored, reflection? Or do you think you'd see something else, like perhaps maybe distorted if it was curved, like a funhouse mirror? Like have you ever been to the carnival where they have those wavy mirrors?
Yeah.
Okay, so that's considered a specular reflection too. You can have a smooth surface, but it shows a distortion, which means that there will be a specular reflection in that kind would be a distorted image because the surface is smooth. However, there's a bend in the mirror. So the bend in that surface would show a distortion, which would be like the image that you see being kind of stretched or whatever, a surface like that would show. So if the image is not distorted, like in a mirror that you might buy at a store to see yourself, when you're cutting your hair or whatever, you see a perfectly mirrored surface, which that would be a specular reflection. You'd see it where it's flat, a flat mirror reflecting back to you.
True.
Okay. Right. So we got some principles here that we're standing on, which is obviously the facts, right? So perfectly mirrored surface is a horizontal plane. Therefore, the specular reflection that you see with the mountain, on the background, and you see it on the lake, is perfectly mirrored in such a way that it's not distorted or elongated or distorted in, kind of a curved way, because the Earth is like displaying over water a perfectly mirrored horizontal plane.
Right.
Yeah, so that's a strong argument for the mechanics of water over distance based on you seeing it over a body of water. Out in nature.
What do you think the water reflects of? Like, does it reflect just the mountain, or does it reflect the sky? or-
No. I mean, okay. Let's just say that whatever it's reflecting. Okay, let's put it that way. Whatever it's reflecting, it's perfectly mirrored up to whatever you see in the background. So the angle of the light hitting the water and bouncing back up into your eye is at such a critical angle that you see it perfectly mirrored. But if the surface of that water was curved in any way, there would be elongated or it would be distorted, like the image itself would be stretched because it's over a curved surface. But it's not, because we see the perfectly symmetrical mirrored surface. It is like as we would see a horizontal plane mirror. Like if you lay your mirror flat on the ground and you get your eyeball down to the, like close to where the mirror is, you'd see it perfectly reflecting something up towards that horizon line. Okay, well that's a established fact. We know this, you and I. So therefore, when we're looking over that distance, over a lake or whatever body of water you're looking over, and you see this perfectly mirrored surface, that's also an indication that it's not just we're seeing flat, but we know it's flat. Because otherwise, the distortion would be such that we'd be able to see elongation happening over a distance. It would have to be if it's curved. But we don't see that. So it is, for all intents and purposely observed as a flat plane. And also we can say that we can test it as that based on a line of sight from the point of our observation to a target distance. And then say that because of specular reflection gives us a better reason to understand the mechanics of water over distance. So we know that water will not bend at a far distance because the mirrored surface that it creates would be distorted, or the image would be distorted on that surface because it's curving.
You change your perspective, and instead of looking at it from the ground, you look at it from the sky, like if you were flying, for example.
Yeah. But what we're doing here is we're trying to cover as much first principles to establish a foundation. So we're making a foundation right now. If it's curved in any way, there would be a distortion to be noted, right? You'd be saying, well, the image looks elongated. It would have to, because it's, or maybe I don't see enough of the image, or whatever it is. Like you'd have an argument against what I'm saying, but because you don't, there isn't the other thing that's happening that should be there, the distortion of elongation. Like you don't see that. So it is symmetrical as if it were a horizontal plane. So you can now say that, but that's just giving us like another layer of foundation that we're establishing the fact that the Earth is a horizontal plane. And then we're going to take that now into a line